What if the story of human history that you were taught is not just incomplete, but fundamentally wrong? Picture this for a moment. Somewhere beneath layers of sand, ice, jungle, and ocean, there are remnants of a past that doesn't fit. Not missing puzzle pieces, but entire sections of the puzzle that were never supposed to exist at all. Structures too old, maps too accurate, stones too heavy, knowledge too advanced. Discoveries that, if taken seriously, don't just tweak our understanding of the past, they shatter it. And that is where the discomfort begins. Because archaeology, at its core, is built on timelines. Carefully constructed, fiercely defended timelines. They tell us when humans were primitive, when we learned to farm, when we learned to build, when we learned to think big. These timelines give us comfort. They make progress feel logical. Linear. Safe. But what happens when something appears that doesn't belong anywhere on that line? Over the last century, archaeologists, geologists, engineers, and independent researchers have stumbled upon discoveries that feel wrong. Not wrong in the sense of false, but wrong in the sense that they should not exist. Sites that appear thousands of years older than civilization itself. Stonework so precise it challenges modern engineering. Ancient knowledge that seems to require advanced mathematics, astronomy, or technologies no ancient culture was supposed to possess. These are not fringe internet myths. Many of these discoveries are real, documented, measured, and quietly acknowledged, then explained away, sidelined, or ignored. And that silence speaks louder than any theory. Imagine standing in front of a structure carved from stone so massive that even today, with cranes and computer modeling, replicating it would be a challenge. Imagine realizing that it was built by people officially classified as primitive. No metal tools. No wheels. No written language, at least none we've found. And yet, the evidence stands there, unmoved by disbelief. This creates a problem. A big one. Because if these ancient builders were capable of this, then what else were they capable of? And if they had this knowledge, where did it come from? And perhaps most unsettling of all, what happened to it? History tends to tell us that knowledge only moves forward. That humanity starts ignorant and slowly climbs upward, discovering fire, agriculture, writing, science, and technology step by step. It's a comforting story. It suggests inevitability. Progress as destiny. But the Earth tells a different story. The planet has endured cataclysms, massive floods, sudden climate shifts, impacts from space, volcanic winters. Entire ecosystems have been wiped out and reborn. Species erased without warning. And yet we are asked to believe that human civilization, fragile as it is, has always moved forward uninterrupted. What if that assumption is the greatest mistake of all? Across cultures separated by oceans and millennia, there are stories, strikingly similar stories, of advanced ages that ended in catastrophe. Flood myths. Fire from the sky. A golden age lost to time. Survivors who carried fragments of knowledge into a broken world and taught future generations how to rebuild. For centuries, these were dismissed as mythology. Symbolic tales. Primitive attempts to explain nature. But mythology has an uncomfortable habit of aligning with evidence, if you look closely enough. As technology improves, as radar scans beneath ice and soil, as underwater archaeology reveals submerged ruins where coastlines once existed, something unsettling is happening. The Earth is giving up secrets that refuse to stay buried. And with each discovery, the same pattern repeats: excitement, confusion, controversy, and then resistance. Because rewriting history doesn't just affect textbooks. It affects identity. Authority. Entire academic structures built on certainty. So instead, anomalies are labeled outliers. Structures are declared ceremonial without explanation. Precision is called coincidence. And timelines are protected at all costs. But curiosity doesn't disappear that easily. There is a growing realization, quiet, but persistent, that our past may be far stranger, far older, and far more complex than we are comfortable admitting. That ancient people were not merely struggling survivors scratching out an existence, but inheritors of something already old when they found it. This raises questions that are deeply uncomfortable. What if civilization didn't begin once, but many times? What if knowledge can be lost as easily as it is gained? What if we are not standing at the peak of human achievement, but on the ruins of forgotten ones? These questions are not popular. They blur the line between science and speculation, between evidence and implication. And yet, they refuse to go away. Because stone doesn't lie. Because maps don't accidentally show continents before they're discovered. Because mathematical precision doesn't appear by chance. And because every time we dig deeper, literally and metaphorically, we find ourselves face to face with something that shouldn't be there. This is not a story about aliens swooping down from the stars to build monuments for us. It's something more unsettling than that. It's the idea that humans themselves may have reached heights of knowledge long before recorded history begins, and then lost it all. Not once. But perhaps many times. And if that's true, then history isn't a straight line. It's a cycle. Rise. Collapse. Forget. Repeat. The greatest archaeological mysteries are not just about stones and ruins. They're about memory. About what survives catastrophe. About who gets to decide what counts as truth, and what gets quietly erased. As we begin this journey, understand this, there will be no easy answers. No single revelation that neatly ties everything together. What you'll encounter instead are patterns. Connections. Questions that grow heavier the longer you sit with them. And by the time we reach the end, you may realize something unsettling. The mystery isn't just buried in the past. It's unfolding right now, beneath our feet, beneath our oceans, beneath layers of certainty we've built to protect ourselves from the possibility that we don't know nearly as much as we think. And once you see that, there's no going back. There is a moment every archaeologist quietly dreads. It doesn't happen in classrooms or conferences. It happens in the field, usually in silence, when something emerges from the ground that shouldn't be there. Not because it's fake. Not because it's damaged. But because it breaks the rules. Archaeology is built on context. Layers of soil, sediment, and time are supposed to tell a clean, orderly story. Older things are deeper. Simpler things come first. Complexity arrives later. When an object or structure appears where it doesn't belong, too old, too advanced, too precise, it creates a fracture in that story. And fractures are dangerous. Throughout the last 2 centuries, there have been discoveries that didn't just challenge existing theories, they threatened to unravel them completely. In many cases, the initial reactions followed a predictable pattern. Excitement. Media attention. Scholarly debate. And then, slowly, quietly, containment. Because when something cannot be explained within the accepted framework, the framework is rarely questioned. The discovery is. Consider stone tools found embedded in geological layers dated far earlier than modern humans are supposed to exist. Or metallic objects sealed inside solid rock, estimated to be millions of years old. Or architectural ruins discovered in places where no civilization was believed to have lived at all. Each time, the same uncomfortable question arises: who made this, and when? Often, the answer given is the safest one possible. Contamination. Misinterpretation. Natural formation. Hoax. The explanations sound reasonable on the surface, but they share a common goal: preserve the timeline. The timeline is sacred. Without it, the entire narrative of human progress begins to wobble. Agriculture before cities. Cities before writing. Writing before advanced mathematics. Advanced mathematics before engineering. Engineering before precision stonework. Each step depends on the one before it. Remove one link, and the chain collapses. Yet again and again, evidence appears that seems to skip steps entirely. In South America, massive stone blocks weighing hundreds of tons sit fitted together so tightly that a razor blade can't slip between them. No mortar. No visible tool marks. Just perfect geometry. The official explanation claims these were shaped with stone tools by hand over generations. But modern stonemasons, people who cut and shape stone for a living, often look at these sites and quietly admit something doesn't add up. They don't say it publicly. There's no incentive to. Across Europe, ancient underground tunnels stretch for kilometers, dated to a time when humans were supposedly barely surviving. In Asia, precision drilling holes appear in stone that suggest rotational tools. In Africa, structures aligned to celestial events indicate astronomical knowledge long before it was believed possible. Each discovery, on its own, might be brushed aside. An anomaly. A coincidence. A misdated artifact. But patterns are harder to ignore. When multiple civilizations, separated by oceans and thousands of years, display the same impossible traits, advanced geometry, astronomical alignment, precise engineering, it raises a deeply unsettling possibility. Either these cultures independently achieved the same high-level knowledge under primitive conditions, or they inherited it. That second option is rarely spoken aloud in academic circles. Because inheritance implies a predecessor. And a predecessor implies a missing chapter in human history. The idea that our ancestors were more capable than we give them credit for is one thing. The idea that there may have been civilizations before them, advanced ones, is something else entirely. It suggests loss on a scale we are not comfortable confronting. There are artifacts locked away in museum basements that rarely see the light of day. Objects that don't fit neat labels. Discoveries that spark more questions than answers. When they are shown, they are often stripped of context, described in cautious language, and quickly moved on from. Not because archaeologists are malicious. But because institutions are conservative by nature. Careers are built on theories. Funding depends on consensus. And challenging the foundation of the field is a professional risk few are willing to take. So instead, the mystery remains, documented, catalogued, and quietly sidelined. What's fascinating is that many of these discoveries were made decades ago, long before modern fringe culture or internet speculation. Newspapers from the 1800s and early 1900s are filled with reports of bizarre finds, giant stone structures, unusual skeletons, strange tools. At the time, archaeology was still forming its identity. There was more openness. More curiosity. But as the field matured, so did its boundaries. Some discoveries were reinterpreted. Others were declared errors. Some simply vanished from discussion altogether. And yet, they never fully disappear. Because every so often, someone stumbles across the same type of evidence again. A structure uncovered by construction. An artifact pulled from the sea. A scan revealing something buried deep beneath the earth. And once again, the same questions resurface. Why is this here? Who built it? And why doesn't it fit? The most unsettling part is not that these mysteries exist. It's that they seem to cluster around very specific periods, times of transition, times of catastrophe, times when the Earth itself was changing rapidly. Ice ages ending. Sea levels rising. Climates shifting. It suggests that what we call prehistory may not have been a blank slate at all, but a graveyard of forgotten worlds. This forces us to reconsider the word primitive. Not as a description of intelligence, but as a snapshot taken after something was lost. Survivors rebuilding with limited resources. Knowledge passed down in fragments. Skills remembered, but not fully understood. Imagine inheriting blueprints without the machines. Instructions without the tools. Sacred knowledge without the infrastructure that made it possible. Suddenly, the myths of gods teaching humans agriculture, architecture, and astronomy don't sound so fantastical. They sound like cultural memory, misunderstood teachers elevated over time into divine figures. And that's where archaeology becomes dangerous. Not because it reveals monsters or aliens, but because it reveals us. It suggests that humanity is capable of far more, and far more fragile, than our current story allows. That progress is not guaranteed. That knowledge can vanish. That entire civilizations can fall into silence, leaving behind only stone and myth. Every discovery that shouldn't exist is a reminder of that vulnerability. And as technology advances, as more of the planet is scanned, drilled, and explored, these anomalies are becoming harder to dismiss. They are no longer isolated curiosities. They are forming a mosaic, one that doesn't match the image we've been taught to see. The real question, then, is not whether these discoveries are real. They are. The question is whether we are ready to accept what they imply. Because if even a fraction of them point to a forgotten chapter of human history, then the story of civilization is not a steady climb out of darkness. It is a cycle. And cycles can begin again. Centuries before Antarctica was officially discovered by explorers, a remarkable map appeared that continues to baffle historians and cartographers alike. Created in 1513 by the Ottoman admiral and cartographer Piri Reis, this map shows coastlines with astonishing accuracy, some of which, according to modern analysis, depict regions of the Antarctic continent entirely free of ice. The sheer precision of these depictions raises profound questions. How could a 16th-century mapmaker draw detailed coastlines of a land that would remain undiscovered for more than 300 years? More importantly, from where did Piri Reis obtain his sources? The map itself is a fragment, one of many in a compilation, but its surviving portion contains remarkable detail of the western coast of Africa, the eastern coast of South America, and even parts of the Antarctic coastline. Scholars have confirmed the accuracy of these sections through modern measurements, revealing that the features of Antarctica were drawn with a fidelity that is difficult to explain using the navigational tools of the era. The implication is staggering. Someone, somewhere, centuries before satellites and accurate longitudinal measurement, had charted coastlines that we only came to know in modern times. What makes the Piri Reis map even more extraordinary is the source material Piri Reis claimed to have used. In his own writings, he mentions using about 20 older maps, some of which were Arabic, some Portuguese, and some Greek. One of these maps, he asserts, was a map of the world made by Alexander the Great's era, a chart allegedly compiled from the explorations of fleets that no longer exist in historical records. This raises difficult questions about the origins of knowledge. How far back in time does the human capacity for global exploration extend? And if these ancient mariners existed, why are they absent from mainstream historical accounts? Experts have examined the Piri Reis map from multiple angles. Cartographers have attempted to reconstruct the original source maps and have tried to rationalize the Antarctic coastline as a misinterpretation of South American geography. Geologists and glaciologists, however, have pointed out that the map appears to depict the coastline before it was covered in ice, which would place its source data thousands of years earlier than previously thought. This is an uncomfortable reality for traditional historians. According to accepted knowledge, Antarctica was first sighted in the early 19th century. To suggest that someone mapped it accurately in the distant past challenges every accepted timeline of exploration. The controversy surrounding the map intensifies when examining the level of detail involved. Some features indicate knowledge of glacial retreat, including fjords and inlets that were not exposed until recent geological times. The precision is such that it cannot easily be dismissed as guesswork or artistic interpretation. Piri Reis was clearly compiling data from earlier sources, but the original methods and instruments used to gather such information remain unknown, fueling speculation and conspiracy theories alike. This map is not an isolated curiosity. It belongs to a broader pattern of ancient cartography that defies conventional timelines. Similar examples, such as the Babylonian world map or the ancient Chinese and Indian nautical charts, hint at the existence of sophisticated surveying knowledge far older than modern historians acknowledge. These maps suggest that certain civilizations may have possessed navigational abilities, global awareness, and technical skill long before the Renaissance. The Piri-Reis map, however, remains the most compelling example due to the specific and measurable accuracy of regions that were supposed to be undiscovered. In addition to the technical aspects, the map carries hints of cultural and intellectual transmission across time and space. The combination of Greek, Arabic, and possibly even older source materials indicates a network of knowledge exchange that spanned continents and centuries. This challenges the conventional notion that ancient societies were isolated and linear in their development. Instead, the map suggests the possibility of a more interconnected ancient world, where knowledge was preserved, transmitted, and perhaps lost and rediscovered multiple times. The implications extend beyond cartography. If ancient civilizations could chart coastlines of lands that were inaccessible for centuries, it forces us to rethink what we know about exploration, seafaring technology, and the accumulation of knowledge. Were these civilizations capable of voyages that rival modern expeditions? Did they possess instruments or techniques lost to history? Or is it possible that entire advanced cultures existed, creating maps, tools, and technologies that vanished without a trace, leaving only fragments like the Piri-Reis map behind? Skeptics have proposed alternative explanations, including claims that the map is merely a product of conjecture or coincidence, or that Piri-Reis relied on imaginative reconstructions of known landmasses. Yet the level of precision, especially regarding Antarctica, makes these explanations tenuous. The map contains details that correspond to coastlines only revealed by scientific research in the 20th century, centuries after Piri-Reis drew his lines. Such accuracy stretches the limits of chance and imagination. The fascination with the Piri-Reis map also arises from the broader human desire to uncover hidden histories. It stands as a symbol of the possibility that much of the past has been lost, deliberately erased, or misunderstood. Its existence compels us to question the reliability of historical records and the assumption that human knowledge grows strictly in a linear fashion. Perhaps ancient civilizations achieved feats that were erased by catastrophe, time, or cultural collapse, leaving only tantalizing fragments behind. Scholars continue to debate the map, but its enduring allure lies in its mystery. Unlike artifacts that can be carbon dated or structures whose origins can be traced through excavation, the Piri-Reis map is a testament to knowledge without a clear origin. It is a whisper from a past we barely understand, a challenge to the narrative that human progress began in a vacuum and advanced steadily over millennia. It reminds us that history is not always what it seems, and that the evidence of forgotten civilizations may be hiding in plain sight, disguised as parchment, stone, or legend. Ultimately, the Piri-Reis map forces us to confront an uncomfortable possibility, that the story of human exploration, knowledge, and civilization is far older and more complex than textbooks suggest. It implies a continuity of understanding, a lineage of learning, that stretches back far beyond what is documented. And it is precisely this uncertainty, this gap between what we know and what we suspect, that makes the map one of the most compelling and confounding artifacts in the study of ancient mysteries. Every line on that ancient parchment tells a story not fully understood, and every coastline challenges the limits of our historical imagination. To look at the Piri-Reis map is to confront the profound question of whether humanity once possessed knowledge that rivaled or even exceeded our own, and whether some of that knowledge was lost to time, waiting silently beneath centuries of ice, sand, and secrecy. It stands as a silent testament to a past that refuses to be neatly explained, inviting us to explore, question, and imagine the possibilities that lie beyond the boundaries of accepted history. Beneath the seemingly frozen expanse of Antarctica lies a landscape that has remained largely inaccessible to humans for thousands of years. Its massive ice sheets conceal secrets that may rewrite our understanding of Earth's history and the story of civilization. For centuries, Antarctica was imagined as a barren, frozen wasteland, untouched by humans and preserved in icy isolation. Yet beneath this frozen exterior, geological surveys, satellite imaging, and radar scans are revealing features that suggest a far more dynamic past, one in which the continent may have been home to landscapes that were not only habitable but possibly visited and mapped by ancient civilizations. Modern science confirms that Antarctica has not always been covered by ice. Geological and sedimentary studies indicate that between 6,000 and 11,000 years ago, large portions of the continent were ice-free, featuring valleys, rivers, and coastal plains. Fossilized plant life discovered under the ice suggests a temperate climate, with forests and freshwater ecosystems that could have supported life long before the arrival of modern humans. This challenges the long-held notion that Antarctica was always an inhospitable environment and raises the tantalizing possibility that humans, or civilizations with seafaring capabilities, could have explored or even settled there during ancient times. One of the most compelling pieces of evidence comes from radar scans conducted beneath the ice. These surveys have revealed intricate networks of channels, valleys, and what appear to be artificial structures. Some formations resemble roads or pathways, while others hint at the foundations of large, organized settlements. The precision of these formations has led some researchers to speculate that they are not natural at all but the remnants of a civilization that existed long before recorded history. Though mainstream science remains cautious, the implications are extraordinary. They suggest that humanity's understanding of habitation, migration, and exploration during prehistoric times may be profoundly incomplete. Compounding the mystery are ancient maps, like the Piri-Reis map, which appear to depict portions of Antarctica without ice. If these maps are accurate, they may provide visual evidence that the continent's coastlines were charted thousands of years before modern explorers first set eyes on them. The idea that ancient mariners or civilizations could have reached Antarctica at such an early date is difficult to reconcile with conventional historical timelines. Navigation across open oceans would have required advanced knowledge of seafaring, astronomy, and geography, skills that are not typically attributed to ancient societies of the period. Yet the evidence, both cartographic and geological, suggests the possibility was real. Further intrigue arises when examining peculiar anomalies under the ice, such as strange pyramid-like formations detected through radar imaging. Some of these structures exhibit geometric precision, with triangular faces and linear alignments that are strikingly similar to human-made architecture found elsewhere in the world. While skeptics argue that natural geological processes can create regular patterns, the consistency, scale, and arrangement of these features invite alternative explanations. If human intervention is even remotely possible, it would indicate the presence of a lost culture with extraordinary engineering capabilities, far earlier than conventional archaeology has acknowledged. The notion of an ancient, ice-free Antarctica is further supported by climate studies. Ice cores extracted from deep within the continent reveal periods of sudden warming and cooling, suggesting that the Antarctic climate has fluctuated dramatically over millennia. These cycles would have periodically exposed coastal regions, creating environments suitable for life and exploration. During such interglacial periods, sea levels were lower, and ice coverage retreated far from the coastlines, opening passages that could have allowed ancient civilizations to navigate the continent's perimeter. This creates a compelling scenario in which humanity could have explored, mapped, and even temporarily settled regions of Antarctica during windows of opportunity that were subsequently lost to rising ice and catastrophic climate events. The evidence, however, is far from definitive. Much of Antarctica remains inaccessible, and the ice itself is both protector and destroyer of the past. Layers of glacial ice can preserve artifacts for thousands of years, but the movement of ice sheets also has the power to erase evidence entirely. Structures could be buried, deformed, or crushed beyond recognition. Yet even within these constraints, tantalizing glimpses of the past continue to emerge. Fossilized flora and fauna, unusual rock formations, and anomalies detected by satellite imaging all suggest that the continent's history is far richer than previously imagined. Adding to the mystery is the historical context of exploration and knowledge suppression. Early accounts of polar expeditions often mention sightings of strange formations, unusual rock structures, and hints of human-like activity, yet these reports were frequently dismissed as errors, exaggerations, or fabrications. Some researchers argue that this dismissal reflects an underlying resistance to the idea that ancient humans could have ventured so far into the unknown. Accepting the possibility of a prehistoric, ice-free Antarctica challenges conventional narratives about civilization, migration, and technological capability. It forces scholars to reconsider what humans were capable of achieving long before recorded history. The implications of an ancient Antarctic civilization extend beyond geography and archaeology. They touch on the very nature of human history, knowledge, and memory. If such a civilization existed, even briefly, its disappearance beneath the ice could explain the loss of technological knowledge, astronomical records, and cultural memory. Myths of lost continents, flood stories, and ancient seafaring tales may not be entirely symbolic but could be echoes of historical events and migrations influenced by climate change and environmental catastrophe. Antarctica, in this view, is not merely a frozen wasteland, it is a silent witness to a chapter of human history that has been erased, intentionally or otherwise. Even the scientific debate itself reveals something remarkable. The idea of a lost, ancient Antarctica forces experts to balance skepticism with the possibility of revolutionary discovery. Mainstream scholars emphasize natural explanations, citing erosion, tectonic activity, and ice movement as likely sources of unusual formations. Yet the presence of patterns, alignments, and anomalies that defy easy explanation keeps curiosity alive. It is precisely the tension between skepticism and speculation that makes Antarctica such a powerful symbol in the study of forbidden archaeology. It represents the boundary between what is accepted and what might yet be discovered. Technological advancements are now allowing unprecedented exploration of the frozen continent. Satellite imagery, ground-penetrating radar, and sub-ice robotic probes are revealing details that were previously invisible. Each new discovery adds weight to the possibility that Antarctica was more than a passive landscape. It may have been an environment interacted with, mapped, and perhaps even partially inhabited by ancient humans. The scientific community approaches these findings cautiously, but for researchers willing to consider unconventional hypotheses, the evidence is tantalizing. The mystery of Antarctica also challenges the assumption that human civilization has always progressed in a linear fashion. The notion that sophisticated exploration, mapping, and possibly settlement could have occurred in a period traditionally labeled as prehistoric suggests a discontinuity in human achievement. It hints at the possibility that knowledge can rise and fall, civilizations can flourish and vanish, and that our understanding of the past is only a fragment of a much larger story. In this context, Antarctica is more than a geographical curiosity, it is a repository of lost knowledge, waiting to be revealed by those who dare to look beneath the ice. Ultimately, the frozen continent remains one of the greatest enigmas in archaeology and geology. Its ice-bound landscape holds clues to an ancient world that challenges everything we thought we knew about the timeline of human history. As we continue to uncover fossils, anomalies, and subtle hints of civilization beneath the ice, we are forced to confront the possibility that Antarctica is not simply a remote wilderness, but a silent testament to a chapter of human achievement that has been buried for millennia. Each discovery, each scan, each analysis brings us closer to understanding a past that has been hidden, forgotten, or erased. And in doing so, it compels us to reconsider not only the history of a continent but the very story of humanity itself. Long before the rise of the great civilizations of Mesopotamia, Egypt, and the Indus Valley, a monumental complex arose on a barren plateau in what is now southeastern Turkey. Known today as Göbekli Tepe, this site has completely upended our understanding of human history, forcing scholars to reconsider when and how civilization truly began. Conventional narratives depict early humans as simple hunter-gatherers, surviving in small, nomadic bands with little capacity for monumental construction or abstract thought. Agriculture and permanent settlements were thought to come later, forming the foundation for temples, cities, and complex societies. Yet Göbekli Tepe, dated to approximately 11,000 years ago, predates agriculture by thousands of years and contains massive stone structures that demand a level of organization, planning, and symbolic thought previously deemed impossible for its time. The site consists of a series of circular and oval megalithic enclosures, each containing enormous T-shaped limestone pillars, some weighing up to 20 tons. These pillars are arranged with precision, often in pairs, and adorned with intricate carvings of animals, abstract symbols, and human-like figures. Lions, snakes, foxes, vultures, and other creatures are etched into the stone with remarkable detail, suggesting not just artistic skill but a sophisticated symbolic language. The very act of carving and arranging these stones required coordination, engineering knowledge, and a social structure capable of mobilizing and sustaining a large workforce, a striking contradiction to the presumed simplicity of hunter-gatherer life. One of the most astonishing aspects of Göbekli Tepe is its age. Radiocarbon dating places its earliest layers at around 9,600 BCE, making it over 6,000 years older than Stonehenge and nearly 7,000 years older than the Great Pyramid of Giza. At this time, humans were supposedly still engaged in basic survival activities, gradually learning to cultivate plants and domesticate animals. Yet here, in an era without known agriculture, a group of people undertook a monumental construction project that required immense labor, architectural planning, and an understanding of structural stability. The very existence of Göbekli Tepe suggests that the story of civilization's origins may need to be rewritten entirely. The purpose of Göbekli Tepe remains a subject of intense debate. Archaeologists have long referred to it as a temple, implying a religious or ritual function, but the site's complexity and scale hint at something more profound. Some researchers suggest it served as a communal center, a place where disparate groups came together for ceremonies, feasts, or gatherings. The carvings themselves may encode mythological or cosmological knowledge, a symbolic record of a worldview that predates writing. This challenges the traditional view that religious and symbolic thought emerged only after humans became sedentary and agricultural, suggesting instead that complex belief systems may have been a driving force behind the transition from nomadic life to organized society. Equally compelling is the construction technique. The T-shaped pillars, some standing over 5 meters tall, are carved from limestone quarried nearby. Transporting these massive stones without wheels or draft animals would have required ingenious methods and coordinated effort. Archaeologists estimate that hundreds of individuals may have worked together to move and erect the pillars, carving the intricate reliefs over extended periods. The level of technical skill and social cooperation implied by these feats challenges assumptions about the capabilities of prehistoric humans. If people without formalized societies or agriculture could accomplish this, what other feats of knowledge and engineering might they have achieved? Göbekli Tepe also introduces a profound paradox regarding knowledge and memory. After centuries of use, the enclosures were deliberately buried, a fact that has puzzled scholars. Why would a community go to such enormous effort to construct these monumental structures, only to cover them with soil and abandon them? Some suggest it was a ritual closure, an intentional act of preservation or sanctification, but the precise reasons remain unknown. This deliberate burial hints at a society with sophisticated cultural practices, capable of symbolic thought that extends beyond immediate utility. It also raises the unsettling possibility that knowledge of construction techniques, religious symbolism, and social organization may have been intentionally concealed or lost, leaving future generations to rediscover fragments of what was once known. The discovery of Göbekli Tepe has also forced historians to reconsider the role of hunter-gatherer societies in human development. Traditional models depict a linear progression: humans begin as nomads, then settle, farm, build cities, and develop religion and governance. Göbekli Tepe turns this model on its head, suggesting that complex social and religious structures may have preceded agriculture rather than followed it. This challenges deeply ingrained assumptions about human progress and implies that the intellectual and cultural capacities of early humans were far greater than previously acknowledged. The idea that spiritual or communal needs could drive monumental construction predates the technological advancements often credited with enabling civilization, redefining the relationship between belief, society, and material achievement. Beyond its physical and symbolic significance, Göbekli Tepe has a broader, almost philosophical implication. It forces us to confront the fragility of human memory and the incompleteness of historical records. If such a sophisticated site could be built, used, and then buried in prehistory, what other achievements, technologies, or knowledge might have existed and disappeared without a trace? The site is a reminder that the story of humanity is not a continuous upward climb but a fragmented mosaic, with gaps, erasures, and surprises hidden beneath layers of soil, ice, and time. As archaeologists continue to study Göbekli Tepe, new questions emerge with every excavation. The alignment of the pillars, the patterns of the carvings, and the arrangement of the enclosures all hint at astronomical or cosmological significance, suggesting that these people had a sophisticated understanding of the heavens. Some researchers propose that the site functioned as a calendar, tracking celestial events that were crucial for social or ritual purposes. If true, this represents a level of scientific knowledge entirely unaccounted for in conventional narratives of human development. The discovery has also sparked speculation outside mainstream archaeology. Some suggest that Göbekli Tepe could be a remnant of a lost or forgotten civilization, perhaps one whose knowledge was transmitted to subsequent cultures in fragmentary forms. Others argue that it represents an advanced cultural phase of hunter-gatherer society that was previously unrecognized, a demonstration that complexity is not always dependent on agriculture or urbanization. Either way, the site stands as a profound challenge to conventional wisdom, a testament to human ingenuity in an era long assumed to be primitive. Göbekli Tepe's existence also forces a re-evaluation of timelines across the globe. If a society capable of such construction existed in the Fertile Crescent over 11,000 years ago, might similar achievements have occurred elsewhere in the world during the same period? Could other, lost, sites await discovery beneath soil, sand, and ice? The implications are staggering. Human history may be far older, more interconnected, and more sophisticated than the linear narratives presented in textbooks. In the end, Göbekli Tepe is more than a collection of stone pillars or a curiosity for archaeologists. It is a mirror reflecting the limits of human understanding and the gaps in our historical knowledge. It reminds us that civilization, technology, and spiritual thought may have roots far deeper than we imagined, and that humanity's capacity for creativity, organization, and symbolism has existed since the earliest days of our species. The site challenges us to ask uncomfortable questions about what has been lost, what has been buried intentionally, and how much of our past remains hidden, waiting to be uncovered. Every carved pillar, every circular enclosure, and every buried layer of soil tells a story that continues to baffle experts and inspire wonder, reminding us that the journey to understand humanity's origins is far from complete. Göbekli Tepe is not merely a relic of the past. It is a warning and an invitation, a warning that history may be far stranger than we have imagined, and an invitation to look deeper, question assumptions, and consider that the story of civilization is far more complex, mysterious, and astonishing than anyone has dared to believe. Göbekli Tepe presents one of the most perplexing enigmas in archaeology, not merely because of its size or artistry, but because of the people who built it. Conventional wisdom holds that the construction of monumental structures requires a settled society, agriculture to feed workers, a hierarchical social organization, and specialized knowledge. Yet the builders of Göbekli Tepe were, according to all evidence, hunter-gatherers. They lived in small, mobile groups, subsisting on wild plants and game. They had no permanent settlements, no domesticated crops, and no known system of written communication. And yet, somehow, they coordinated the quarrying, transport, carving, and erection of massive limestone pillars weighing up to 20 tons. The question that haunts scholars is simple but profound: how could a people without the logistical and technological advantages we normally associate with civilization achieve such a feat? The first clue lies in understanding the social and cultural dynamics of hunter-gatherer communities. While these societies are often depicted as simple or primitive, ethnographic studies suggest that they are capable of remarkable organization, cooperation, and knowledge transmission. Tasks such as hunting large game, seasonal migration, and tool production require precise coordination and long-term planning. Göbekli Tepe may represent an extraordinary extension of these capabilities, a large-scale project driven not by agriculture but by social cohesion, shared belief systems, and ritual necessity. The motivation for construction was likely not economic, but spiritual, cultural, or symbolic, suggesting that complex belief structures existed long before permanent settlements or formalized governance. The construction itself raises numerous questions about technology and engineering. Moving and erecting massive stone pillars without the wheel or draft animals would have required ingenious methods. Archaeologists propose that levers, ramps, and wooden sledges could have been employed, but the precision with which the stones were aligned and positioned defies easy explanation. Some stones appear to be cut and fitted with remarkable accuracy, leaving joints so tight that even a blade cannot pass between them. Carving the reliefs and symbols on the stones would have required specialized skill and significant time. This implies not only manual expertise but also planning, coordination, and knowledge of materials. It suggests that the builders had a deep understanding of stone properties, weight distribution, and structural stability, all without written instruction or formal engineering knowledge. Another layer of complexity is found in the symbolic and artistic elements of the site. The carvings on the pillars include animals such as foxes, lions, snakes, and vultures, rendered in astonishing detail. Some scholars interpret these images as representations of myths, spiritual beliefs, or cosmological concepts. Others see them as a form of proto-writing, a symbolic language conveying information about events, seasons, or social structures. Regardless of interpretation, these carvings indicate that the builders were not only capable of monumental construction but also sophisticated symbolic thought. They could conceptualize abstract ideas and communicate them through enduring, permanent forms. This challenges assumptions that symbolic expression and monumental architecture required sedentary societies or agricultural surplus. The very organization of Göbekli Tepe adds to its mystery. The site is composed of multiple circular and oval enclosures, each containing T-shaped pillars arranged in precise patterns. Some pillars appear to be aligned with celestial events, such as solstices, hinting at a knowledge of astronomy. The enclosures themselves suggest a sophisticated understanding of space, social interaction, and ritual practice. Coordinating labor to create such structures would have required strong leadership or social norms that encouraged cooperation on a scale far beyond typical hunter-gatherer groups. The existence of multiple enclosures, some built sequentially over centuries, implies long-term planning and intergenerational knowledge transfer, further complicating our understanding of these early people. The deliberate burial of Göbekli Tepe adds another layer of intrigue. Archaeologists have discovered that after centuries of use, the enclosures were intentionally filled with soil, effectively hiding them from view. The reasons for this act remain speculative, but it suggests a complex cultural practice, perhaps a ritual closure or an attempt to preserve the sanctity of the site. This decision implies foresight, communal consensus, and symbolic reasoning, traits not usually attributed to hunter-gatherer societies. It also raises the possibility that knowledge of the construction techniques, symbolic meanings, and purpose of the site was intentionally concealed or lost, leaving later generations to stumble upon fragments without context. The paradox of Göbekli Tepe challenges the linear models of human development. Traditionally, archaeologists have argued that monumental architecture, social stratification, and symbolic expression emerged only after agriculture, when surplus food allowed for specialized labor and permanent settlements. Göbekli Tepe suggests the reverse, that complex social and spiritual practices may have motivated humans to develop agriculture and settle in the first place. In other words, the need for communal gathering, ritual observance, and social cohesion could have been the driving force behind the transition from foraging to farming. This idea radically alters the narrative of human progress, positioning belief, culture, and cooperation as primary catalysts for technological and societal advancement. The implications of Göbekli Tepe extend beyond the site itself. If hunter-gatherer groups were capable of such monumental construction, what other achievements from the same period might we have overlooked or misinterpreted? Could similar advanced societies have existed elsewhere, leaving behind fragments of knowledge that were erased by time, climate, or cultural collapse? The existence of Göbekli Tepe suggests that our understanding of human capability in prehistory is incomplete, and that the story of civilization may include chapters we have yet to discover. Göbekli Tepe also invites reflection on human potential and ingenuity. It demonstrates that intelligence, creativity, and organizational skill are not bound by technological constraints or social complexity. Early humans were capable of remarkable feats, driven by shared purpose, ritual necessity, and collective effort. They could conceptualize structures that lasted millennia, carve intricate symbols into stone, and organize labor on a scale that rivals later civilizations. The site is a testament to the adaptability and ingenuity of our species, revealing that the roots of human achievement are far deeper and more sophisticated than previously imagined. Ultimately, the mystery of Göbekli Tepe lies not only in its construction but in the people who built it. They were individuals who lived in a world without writing, without agriculture, without permanent cities, and yet they accomplished what many modern societies would struggle to replicate. Their motivations, methods, and social structures remain enigmatic, but their legacy endures in stone. Göbekli Tepe forces us to reconsider assumptions about the capabilities of prehistoric humans and challenges the notion that civilization is solely the product of sedentary life and technological advancement. It opens a window into a lost world where belief, cooperation, and ingenuity intersected to produce monuments of enduring power, leaving behind a puzzle that continues to captivate, inspire, and baffle scholars around the globe. The enigma extends beyond history. It touches on philosophy and human understanding. Göbekli Tepe is a reminder that the past is not always orderly, that human achievement does not always follow predictable patterns, and that knowledge can be gained, applied, and lost in ways we cannot always comprehend. The people who built it have vanished, yet their work speaks across millennia, challenging us to imagine what motivated them, what they believed, and what they achieved. In studying Göbekli Tepe, we confront the extraordinary capabilities of early humans and are reminded that history is far more complex, mysterious, and astonishing than the narratives we have long accepted. The precision of ancient stonework continues to astonish modern engineers and archaeologists alike, challenging assumptions about the capabilities of societies long before the advent of modern machinery. Across continents, from the jagged mountains of South America to the deserts of Egypt, structures constructed thousands of years ago display a level of craftsmanship, alignment, and durability that is difficult to reconcile with the tools and techniques conventionally attributed to their creators. The meticulous cutting, fitting, and positioning of massive stones suggest knowledge and skills that often appear far ahead of their time, sparking both awe and profound questions about human ingenuity in prehistory. Consider, for example, the stone walls of Sacsayhuaman near Cusco, Peru. Here, massive limestone blocks, some weighing over 100 tons, are cut with such precision that the joints fit so tightly that it is impossible to insert a knife blade between them. These stones were quarried, transported, and shaped with incredible accuracy, yet there is no evidence of wheels or advanced lifting machinery. Scholars have speculated on the methods used, proposing levers, ropes, and earthen ramps, but even with these, the alignment and uniformity achieved remain extraordinary. The construction defies the expectation that large-scale stone masonry requires modern technology, suggesting that ancient builders possessed an intuitive understanding of physics, weight distribution, and structural integrity. Beyond Peru, similar examples abound. In Egypt, the blocks used to construct the Great Pyramid of Giza are astonishingly uniform, with some weighing up to 80 tons. The limestone casing stones were cut and polished to an almost perfect fit, allowing joints that are nearly invisible to the naked eye. Surveys reveal that the pyramid's base is level to within a fraction of an inch over its entire 13-acre footprint, and its alignment with true north is nearly flawless. These achievements were made long before modern surveying equipment existed, implying that the ancient Egyptians had a profound understanding of geometry, measurement, and astronomy, applied with extraordinary precision. In Lebanon, the ruins of Baalbek showcase what may be some of the largest monolithic stones ever moved by humans. The trilithon stones, each weighing over 800 tons, were cut, transported, and positioned with remarkable accuracy, yet the methods remain a mystery. Ancient records do not describe techniques for handling stones of such magnitude, leaving modern engineers struggling to replicate the feat even with contemporary technology. These constructions raise uncomfortable questions about what knowledge may have been possessed by builders whose methods are now lost, and whether entire branches of engineering skill existed that vanished along with the cultures that practiced them. The precision extends beyond mere size and weight. Many ancient structures display perfect alignment with cardinal directions, celestial events, or seasonal markers. Stone circles, pyramids, and temples are positioned to track solstices, equinoxes, or the rising and setting of particular stars. These alignments suggest a sophisticated understanding of astronomy and a deliberate effort to integrate natural cycles into architectural design. Achieving such precision would have required careful observation over generations, meticulous planning, and accurate measurement tools, none of which are conclusively documented in the historical record of these societies. What makes these feats even more astonishing is the apparent universality of the techniques. From Machu Picchu in Peru to the stone temples of Malta, from the precision-cut ruins of Puma Punku to the megalithic walls of Mycenae, cultures separated by vast distances and millennia achieved levels of craftsmanship that are strikingly similar. This raises profound questions about knowledge transmission. Did these civilizations independently discover comparable methods, or was there a shared repository of technical understanding that has since been lost? The similarities suggest either remarkable coincidence or a far more interconnected ancient world than conventional history acknowledges. The methods themselves remain partially speculative, yet several patterns emerge. Ancient builders often used hammerstones, chisels, and abrasives to shape stone, but the uniformity and precision achieved imply techniques beyond simple hand tools. The stones are frequently interlocked in a way that maximizes stability and resistance to seismic activity, indicating an intuitive grasp of structural engineering principles. Some blocks show signs of polishing and shaping with techniques that resemble modern machining, prompting speculation that ancient engineers may have developed tools and methods that we have yet to fully understand. Beyond technical skill, there is a philosophical dimension to this precision. The meticulous care, time, and labor invested in cutting and fitting stones reflect a worldview in which permanence, order, and harmony were paramount. Ancient societies invested immense human effort into structures that were meant to endure for millennia, not merely for functional purposes but to communicate stability, power, or sacred significance. Each stone, precisely carved and fitted, becomes a message in itself, a testament to human capability, intentionality, and reverence for material permanence. This interplay between technical mastery and cultural expression also challenges our understanding of social organization. The construction of precise stone structures would have required coordinated labor, leadership, and perhaps even a form of proto-engineering knowledge. Hunter-gatherer societies and early agricultural communities are traditionally thought to have lacked the capacity for such large-scale organization, yet evidence suggests otherwise. Sites like Göbekli Tepe demonstrate that monumental construction predates settled agricultural life, hinting that social complexity, spiritual motivation, or ritual necessity could drive humans to achieve feats previously considered impossible without formalized society. The phenomenon of precision stonework also intersects with mysteries regarding lost knowledge. Many of the techniques used to cut, transport, and align massive stones appear to have been forgotten over time, leaving only the finished monuments as evidence. Modern engineers attempting to replicate these methods using period-appropriate tools encounter enormous difficulties, suggesting that critical aspects of ancient technology or methodology have been lost. This raises uncomfortable questions about the continuity of human knowledge. Were these techniques deliberately lost, forgotten due to societal collapse, or simply never documented in a form that survived? In addition, precision stonework challenges the conventional timeline of technological development. The sophistication of ancient masonry indicates that humans were capable of engineering and architectural achievements thousands of years before they were officially recognized as capable. This disrupts the narrative that knowledge accumulates in a linear fashion, suggesting instead that civilizations may rise, achieve extraordinary skill, and then collapse, leaving subsequent generations to rediscover or reinterpret their accomplishments. The stones themselves become silent witnesses to vanished eras of human capability, monuments to ingenuity that challenge modern assumptions about what our ancestors could achieve. Finally, the visual and psychological impact of precise stonework cannot be overstated. The sight of perfectly cut, tightly fitted stones evokes awe, inspiring speculation about the minds that created them. Observers often report a profound sense of wonder and disorientation, as if encountering a civilization that was somehow both familiar and alien. These structures provoke fundamental questions about human potential, the transmission of knowledge, and the fragility of memory. They remind us that the past may have been far more sophisticated than we can currently comprehend, and that the mysteries embedded in stone await careful study, reflection, and perhaps a reimagining of human history. In the end, precision stonework stands as both a technical marvel and a philosophical puzzle. It demonstrates extraordinary human skill, challenges assumptions about prehistoric societies, and invites speculation about lost knowledge and civilizations. Each carved block, each interlocking joint, and each aligned monument is a testament to ingenuity, coordination, and vision that transcends time. The mysteries they contain are not just about engineering, they are about humanity itself, our capacity to create, to endure, and to inspire all long after those who shaped the stones have vanished. Through these enduring constructions, we are reminded that history is not a simple narrative of progress, but a complex tapestry woven with triumph, loss, and the enduring enigma of human potential. Among the most confounding and debated anomalies in archaeology are the so-called out-of-place artifacts, objects discovered in contexts that challenge our understanding of history and technological development. These artifacts, often referred to as OOParts, are items whose age, sophistication, or geographic placement seems impossible according to established timelines. From intricately carved tools found in geological strata dated millions of years old to metallic objects embedded in solid rock, OOParts compel us to reconsider the linear narrative of human progress and to question the assumptions underlying archaeology, geology, and anthropology. Their study lies at the intersection of science, mystery, and speculation, and each discovery carries profound implications for our understanding of human history. One of the most famous examples is the Coso artifact, discovered in California in 1961. Initially thought to be a geode, the object was later revealed to contain a precisely manufactured metal cylinder. When analyzed, it exhibited characteristics that suggested it had been machined with a degree of precision inconsistent with its purported age. Estimates placed the surrounding matrix at hundreds of thousands of years old, well before any human civilization capable of metallurgy is known to have existed. Skeptics suggested misdating or natural explanations, yet the artifact remains a striking example of how a single object can disrupt conventional chronology and ignite debate over the extent of ancient technological knowledge. Similarly, in the mid-19th century, ancient drilling cores were reportedly found in caves in England and Russia, featuring iron and other metals embedded in rock layers far older than the accepted timeline for human metallurgy. These cores displayed smooth surfaces, circular perforations, and tool marks consistent with controlled drilling techniques. Conventional archaeology struggles to reconcile such evidence with the timeline of human technological development. Either these artifacts were deposited by an unknown ancient civilization with advanced capabilities, or our understanding of geological processes and dating methods needs re-evaluation. Both possibilities challenge core assumptions about the past. Another category of OOParts involves fossilized human-made objects found alongside remains of extinct creatures. For instance, tools and carvings purportedly discovered alongside Pleistocene megafauna raise questions about the level of sophistication humans possessed tens of thousands of years ago. If the artifacts are genuine and accurately dated, they indicate a mastery of materials, design, and craftsmanship far earlier than conventional models suggest. Critics often question the context, contamination, or misidentification, yet the sheer number and consistency of such findings across disparate locations prevent easy dismissal. The global distribution of OOParts adds further complexity. From ancient India, where intricately machined metallic spheres have been found, to South America, where carved stones and tools appear in unlikely strata, the phenomenon is remarkably widespread. This raises fundamental questions. Were these isolated anomalies, or do they hint at a lost chapter of human history in which technology, engineering, and symbolic expression reached levels we can barely comprehend today? The recurrence of advanced artifacts in geographically and temporally disconnected regions suggests that the potential for technological sophistication may have existed across multiple ancient cultures, challenging the notion that innovation was strictly sequential and localized. Perhaps most intriguing are the implications for human knowledge and memory. OOP arts often embody skills or techniques that appear to vanish after their creation. Some items exhibit metallurgy, machining, or artistic methods not rediscovered until millennia later, implying that knowledge was gained, applied, and lost, sometimes repeatedly. This raises the uncomfortable possibility that history is punctuated not by a simple upward trajectory of progress, but by cycles of innovation and loss, with entire civilizations' technological achievements erased from the record by cataclysm, migration, or cultural collapse. The very existence of OOP arts also challenges the boundaries of scientific explanation. Mainstream archaeologists often favor naturalistic or misinterpretive explanations, objects misdated, formations misidentified, or contamination overlooked. While these explanations may account for some anomalies, they fail to provide satisfying answers in cases where artifacts are verified, measured, and repeatedly examined under rigorous conditions. This leaves the tantalizing prospect that there is a missing context to human history, an era or episodes in which humans, or perhaps unknown predecessors, possessed knowledge that has since vanished. OOP arts also intersect with questions of intellectual transmission and cultural continuity. If advanced artifacts exist in prehistoric contexts, did these represent isolated experiments, or were they part of broader traditions that have been lost? Could some of this knowledge have been preserved in myth, legend, or oral tradition, influencing subsequent civilizations in fragmentary ways? Many myths, flood stories, or accounts of gods teaching humans may not be purely symbolic but could encode memories of lost technologies or ancient cultures that achieved feats otherwise unrecorded in historical documentation. The study of OOP arts also invites philosophical reflection on the nature of human progress. If advanced knowledge existed long before it was supposedly discovered, it undermines the assumption that humanity has steadily accumulated wisdom and technology. Instead, it suggests that our past is fragmented, punctuated by achievements that rose and fell, and that our understanding is built on incomplete records, accidents of preservation, and selective interpretation. Every anomalous artifact becomes a silent testament to the potential breadth of human capability and the fragility of cultural memory. Scientific advances continue to shed light on some OOP arts, but often in ways that deepen the mystery rather than resolve it. Modern dating techniques, such as radiocarbon analysis, thermoluminescence, and isotopic studies, sometimes confirm anomalous ages that predate accepted timelines for the relevant technological or cultural context. Analytical tools reveal metallurgical compositions, precision cuts, or crafting techniques that would have been virtually impossible with the presumed knowledge of the time. In these cases, rather than diminishing the enigma, the evidence forces a re-evaluation of our assumptions about technological capability, experimentation, and the dissemination of knowledge in antiquity. The cumulative effect of OOP arts is profound. They are not merely curiosities or sensationalized anomalies, they are evidence that human history may be far more complex, fragmented, and surprising than conventional narratives allow. Each artifact represents a question mark, a challenge to established chronology, a puzzle demanding explanation, and a reminder that human ingenuity may have peaked, disappeared, and been rediscovered multiple times throughout history. They compel us to entertain possibilities that stretch the limits of imagination while remaining grounded in empirical observation. Ultimately, the study of out-of-place artifacts underscores the limits of certainty in archaeology and history. They remind us that evidence can exist outside expected patterns, that knowledge may be gained and lost in cycles, and that human achievement is not necessarily linear. These artifacts challenge us to expand our perspective, to acknowledge the potential for lost civilizations, forgotten technologies, and ancient ingenuity that defies conventional understanding. In contemplating OOP arts, we confront the profound mystery of human history, that the past may be far stranger, richer, and more complex than the records we have inherited, and that what we think we know is only a fraction of what might have been. The allure of OOP arts lies in their ability to provoke wonder, skepticism, and curiosity simultaneously. They are evidence of human potential and human enigma, bridging the gap between what is known and what remains hidden. As modern science continues to uncover, analyze, and debate these objects, one enduring truth becomes clear: the history of human civilization is far from complete, and each anomalous artifact is a reminder that the story of our past may hold secrets capable of rewriting everything we thought we knew about our origins, our capabilities, and the civilizations that came before us. Across the deserts and highlands of South America, a mystery lies buried in the remnants of an ancient city that challenges conventional timelines, engineering expectations, and the very notion of what early civilizations were capable of. The ruins of Puma Punku, part of the larger Tiwanaku complex near Lake Titicaca in Bolivia, have long fascinated archaeologists, historians, and engineers alike. The site contains massive stone platforms, intricately cut blocks, and precision joints that fit together so perfectly they defy conventional explanations. What makes Puma Punku extraordinary is not just the size of the stones, some weighing over 130 tons, but the level of precision with which they were shaped and interlocked, a precision that modern machinery would struggle to replicate even today. The construction methods employed at Puma Punku remain a subject of intense debate. Unlike typical ancient masonry, which relies on mortar or simple stacking, Puma Punku's builders utilized precisely cut stones with interlocking joints. Many blocks feature right angles, L-shaped cuts, and even precise holes bored through stone to accommodate metal or wooden dowels, allowing them to fit together seamlessly. These blocks, often weighing multiple tons, were quarried, transported, and positioned without the wheel, cranes, or draft animals that later civilizations relied upon. The technical sophistication required to achieve this level of uniformity is remarkable, suggesting an advanced understanding of geometry, physics, and materials science. Equally puzzling is the scale of the project. Puma Punku covers several acres, with stone platforms that span hundreds of meters. The monoliths are arranged in patterns that indicate careful planning, surveying, and alignment, possibly with astronomical or ceremonial significance. Some researchers have noted alignments with solstices or other celestial markers, suggesting that the builders possessed knowledge of astronomy and its practical or spiritual applications. Achieving this level of spatial organization would have required careful measurement, long-term planning, and coordination of labor on a scale that challenges conventional assumptions about the capabilities of early Andean societies. The tools used to carve the stones are another source of intrigue. Many of the stones exhibit perfectly straight edges, smooth surfaces, and precise angles that are extremely difficult to produce with the stone tools typically associated with pre-Columbian South America. Experimental archaeology has demonstrated that replicating these cuts with copper chisels or stone hammers is exceedingly time-consuming and often imprecise. Some of the grooves and channels in Puma Punku's stones are so uniform and regular that they suggest the use of advanced techniques, such as mechanical drills or even unknown cutting technologies. These observations raise difficult questions about whether the builders had access to tools or methods that are no longer known to us. Puma Punku also presents a puzzle regarding transportation. Many of the stones were quarried several kilometers from the site, often from deposits located on uneven, high-altitude terrain. Moving these massive blocks, some over 100 tons, across rough landscapes without wheels or draft animals would have required extraordinary ingenuity. Hypotheses include the use of wooden rollers, sledges, ramps, and levers, but the logistical challenge remains daunting. The scale of labor coordination implied by these methods points to a highly organized society, capable not only of technical achievement but also of mobilizing and sustaining large teams of workers over long periods. Beyond engineering, Puma Punku embodies symbolic and cultural sophistication. The stone blocks are adorned with intricate patterns, geometric motifs, and precise carvings, indicating a sophisticated artistic sensibility. Some carvings may have conveyed cosmological or spiritual knowledge, representing deities, mythological symbols, or ritual practices. The combination of functional precision and symbolic artistry suggests that the builders possessed both technical mastery and a deep cultural or religious motivation. The site was not constructed merely for utility, it was created with intention, foresight, and a sense of enduring significance. The ruins also raise questions about chronology and historical context. Conventional archaeology places Puma Punku within the Tiwanaku civilization, roughly dating the site to 500 to 600 CE. However, the level of engineering and precision stonework is so advanced that some researchers speculate the techniques could have originated even earlier, possibly inherited from a lost or forgotten culture. This notion aligns with a broader pattern seen in ancient sites worldwide, where advanced construction appears in unexpected periods and locations, suggesting the possibility of interrupted or fragmented transmission of knowledge over centuries or millennia. The site's current ruined state adds another layer of mystery. Puma Punku was clearly once part of a larger ceremonial or urban complex, but much of the structure has collapsed or been dismantled. Some scholars argue that seismic activity contributed to its destruction, while others suggest human intervention, either through ritual closure, conflict, or repurposing of materials. Regardless of the cause, the remaining structures continue to reveal extraordinary technical and artistic knowledge, even in their fragmented form. Every fallen stone, every carefully carved block, is a testament to the ingenuity of its creators. Puma Punku also challenges our understanding of the relationship between ancient technology and societal development. The site demonstrates that advanced engineering and precise stonework can occur in societies that, by conventional measures, are considered pre-industrial or early. It suggests that human creativity and technical skill do not necessarily follow a linear progression tied to metallurgy, urbanization, or centralized state authority. Instead, specialized knowledge, shared cultural motivation, and sophisticated craftsmanship can emerge in societies that remain largely decentralized or agrarian. The implications extend further when considering the possibility of lost knowledge. The precision and scale of Puma Punku suggest a mastery of engineering techniques that may have disappeared along with its builders. Subsequent cultures in the region did not replicate these methods with the same level of accuracy, raising the unsettling prospect that entire branches of technological expertise can vanish, leaving only the monumental evidence of what was once possible. This phenomenon is mirrored in other parts of the world, where architectural sophistication appears, disappears, and resurfaces centuries later, hinting at discontinuities in human technological history that remain poorly understood. Finally, Puma Punku inspires both wonder and reflection. Observing the massive, precisely cut stones, the interlocking joints, and the carefully aligned platforms, it is difficult not to marvel at the ingenuity, effort, and vision required to create such a site. It evokes fundamental questions about the capabilities of early humans, the transmission of knowledge, and the potential for civilizations lost to time. It also underscores a recurring theme in the study of ancient mysteries, that the past may be far richer, more sophisticated, and more enigmatic than conventional histories suggest. In the end, Puma Punku stands as a monument to human achievement, challenging assumptions about the limits of prehistoric societies and the nature of technological development. It compels us to ask how societies without modern tools could accomplish feats that continue to defy contemporary replication. It invites speculation about lost knowledge, forgotten civilizations, and the extraordinary creativity of human beings even in times and places where conventional wisdom assumes simplicity. Every stone, every cut, and every alignment at Puma Punku serves as a reminder that history is not merely a record of survival and progress, but a complex tapestry woven with ingenuity, skill, and enduring mystery. The site, with its precision, scale, and enigmatic construction techniques, forces us to reconsider the narrative of human advancement. It suggests that civilization may not have developed in a straight, predictable path but rather through bursts of innovation, knowledge lost and regained, and societies capable of extraordinary feats long before modern historians expected them. Puma Punku, silent yet eloquent in stone, continues to inspire awe, provoke debate, and challenge our understanding of humanity's potential across time. It is not just an archaeological site, it is a window into the boundless ingenuity of ancient people whose achievements echo across millennia, defying explanation and daring us to imagine a past far more advanced and mysterious than we have ever acknowledged. Few ancient mysteries capture the imagination like the enigma of the Egyptian pyramids. Among these colossal structures, the Great Pyramid of Giza stands as an unparalleled testament to human ingenuity, precision, and ambition. Built over 4,500 years ago, it has long baffled engineers, historians, and archaeologists alike. The sheer scale of the Great Pyramid is staggering. It originally rose to a height of 146 meters, comprised of approximately 2.3 million limestone blocks, each weighing on average 2.5 tons, with some blocks in the king's chamber exceeding 70 tons. The precision with which these stones were cut, transported, and assembled defies conventional understanding of the technology and methods available in ancient Egypt. The alignment of the Great Pyramid is among the most remarkable features. Its sides are almost perfectly oriented to the cardinal points of the compass, with an error margin of only a few minutes of arc. Achieving this level of precision would have required advanced knowledge of astronomy, geometry, and surveying techniques, as well as instruments capable of accurate measurement. Yet no surviving records describe the methods employed by the ancient Egyptians. Various theories have been proposed, ranging from the use of stars and the sun as reference points to sophisticated leveling techniques, but none fully account for the extraordinary accuracy observed across such massive dimensions. The construction methods themselves remain a source of profound mystery. Moving and stacking millions of stones without modern machinery would have required extraordinary planning, labor organization, and engineering ingenuity. Theories range from the use of massive ramps, straight, zigzagging, or spiral, to more unconventional proposals, such as internal ramp systems within the pyramid. The precision with which the blocks fit together, especially in the inner chambers, suggests an unparalleled understanding of weight distribution and structural stability. Even minor miscalculations could have caused catastrophic collapses during construction, yet the pyramid has endured for millennia, resisting both the elements and seismic activity. The purpose and symbolism of the pyramid add another layer of intrigue. While traditionally considered a tomb for Pharaoh Khufu, the scale and complexity suggest that it was intended to convey more than mere funerary function. The internal chambers, passageways, and shafts exhibit alignments that some researchers argue correspond to significant stars or constellations, such as Orion's belt or the circumpolar stars. These celestial alignments may have held religious or cosmological significance, linking the pharaoh to the heavens and eternal life. The level of planning required to integrate such astronomical knowledge into the architecture demonstrates not only technical mastery but also a sophisticated understanding of symbolism and ritual. Beyond the Great Pyramid, the surrounding Giza complex reveals a civilization capable of remarkable organization and vision. The causeways, temples, and smaller pyramids suggest coordinated planning on a monumental scale. Quarrying, transporting, and shaping massive stones for these structures required logistics that would challenge even modern engineering projects. Recent discoveries, including remnants of workers' villages and tools, indicate that tens of thousands of laborers, artisans, and engineers were involved, yet how such a workforce was managed remains a topic of speculation. Feeding, housing, and organizing labor at this scale, without the benefit of written instructions or mechanized technology, underscores the social sophistication of ancient Egypt. The precision of the internal chambers is particularly noteworthy. The king's chamber, constructed entirely from granite, contains massive blocks so finely cut and positioned that gaps are minimal, and the weight is distributed to avoid structural collapse. The sarcophagus itself, carved from a single piece of granite, fits perfectly within the chamber, suggesting meticulous measurement and foresight. The precision extends to the air shafts, which are oriented to align with specific stars, though their exact purpose remains debated. Some propose they were symbolic conduits for the pharaoh's soul, while others suggest practical functions related to ventilation or astronomical observation. Whatever the case, the integration of engineering, symbolism, and astronomical alignment reveals a sophistication that challenges assumptions about the technical capabilities of ancient civilizations. Even the choice of materials adds to the mystery. The majority of the pyramid is constructed from locally quarried limestone, but the interior chambers utilize granite transported from Aswan, over 800 kilometers away. Moving stones of such mass over this distance, without wheeled vehicles or draft animals, required ingenuity and immense effort. Some theories propose the use of rafts along the Nile, combined with sledges and lubrication techniques, but the precise methods remain speculative. The successful transport and placement of these stones reflect not only technical skill but also the ability to coordinate labor and plan complex logistics across vast distances. The question of lost knowledge emerges repeatedly when examining the Great Pyramid. While the Egyptians left behind extensive records of religious rituals, governance, and daily life, detailed explanations of pyramid construction techniques are absent. This has led some researchers to speculate that certain aspects of engineering knowledge were deliberately kept secret, preserved for elite knowledge holders, or lost over time. The absence of detailed records has fueled alternative theories, ranging from unknown ancient technologies to hypotheses involving extraterrestrial assistance, though mainstream scholarship remains focused on plausible human ingenuity. Regardless, the pyramid continues to challenge our understanding of the relationship between technological capability, social organization, and human ambition in antiquity. The precision of the pyramid also raises questions about human perception of time and effort. Estimates suggest that construction took roughly 20 years, involving tens of thousands of workers. The scale and uniformity achieved over decades imply a society with remarkable continuity, discipline, and resource management. Workers' villages, recently excavated, reveal sophisticated planning in terms of living quarters, food distribution, and healthcare, suggesting a society capable of sustaining large-scale projects over extended periods. This level of organization reinforces the notion that the Great Pyramid was not merely a monument to a pharaoh but a testament to the capabilities of a civilization operating at the peak of its technological and social potential. The Great Pyramid's endurance is itself a marvel. Despite millennia of natural wear, earthquakes, and human interference, the structure remains largely intact, preserving both its grandeur and technical ingenuity. Its survival is a testament not only to the skill of its builders but also to their understanding of material properties, environmental forces, and structural engineering. The alignment, precision, and durability continue to inspire admiration, study, and speculation, positioning the pyramid as a focal point for the study of ancient human achievement and a benchmark against which other civilizations' engineering feats are measured. Beyond its architectural and engineering significance, the Great Pyramid embodies humanity's drive for permanence, legacy, and connection to the cosmos. Its construction reflects a culture deeply invested in symbolism, ritual, and the integration of spiritual beliefs with practical achievement. The alignment with stars, the monumental scale, and the meticulous precision all suggest that the pyramid was conceived not merely as a tomb but as a bridge between human endeavor and cosmic order. This synthesis of functionality, symbolism, and technical mastery exemplifies the extraordinary capabilities of ancient civilizations and challenges modern assumptions about the limits of prehistoric knowledge. In contemplating the Great Pyramid, we confront questions that extend far beyond Egypt. How did a civilization without modern tools, machinery, or theoretical mathematics achieve such monumental precision? What knowledge, now lost, allowed them to quarry, transport, and assemble millions of stones with near-perfect alignment? Could similar techniques have existed elsewhere, appearing and disappearing in the archaeological record, leaving behind only fragments of their ingenuity? These questions fuel ongoing research, debate, and fascination, reinforcing the pyramid's status as a symbol of ancient mystery and human potential. Ultimately, the Great Pyramid is more than an architectural marvel. It is a testament to the heights of human ambition, intelligence, and artistry. It forces us to reconsider assumptions about technological and social development in ancient times, reminding us that humans have been capable of extraordinary achievement for millennia. Every precisely cut stone, every aligned chamber, and every astronomical correlation tells a story of vision, skill, and enduring legacy. The pyramid continues to inspire wonder, challenge scholarship, and provoke questions about the ingenuity of our ancestors, inviting us to imagine a past that is far more sophisticated, mysterious, and remarkable than conventional history often allows. The mysteries of ancient Egypt extend far beyond the monumental pyramids and massive temples. They are embedded in artifacts whose sophistication challenges conventional timelines and our understanding of prehistoric technology. Among these artifacts, the dendrolite stands out as one of the most provocative and controversial examples. Found in the Hathor Temple at Dendra, this bas-relief has been the subject of debate for decades, capturing the imagination of archaeologists, engineers, and enthusiasts alike. Carved into the stone ceiling of a crypt-like chamber, the relief depicts a bulbous object connected to a series of tubes and a lotus-shaped stand, often interpreted by some as a representation of an ancient electrical device. While mainstream Egyptologists describe it as symbolic iconography related to Egyptian cosmology, the striking resemblance to a modern light bulb has fueled speculation that ancient Egyptians may have possessed knowledge far beyond what is conventionally credited to them. The relief measures roughly 1 meter in length and is intricately carved, depicting a figure seated on a lotus flower holding a serpent-like object within a bulbous enclosure. A series of lines extend from the bulb, connecting it to what appear to be cables or conduits, terminating in a box-like object that some theorists argue could represent a power source. The craftsmanship is meticulous, with attention to proportion, curvature, and spatial arrangement that suggests both artistic skill and conceptual clarity. Mainstream interpretations suggest that the image represents a lotus plant generating a snake as a symbol of creation, fertility, or cosmic energy, yet the technological analogy to a light bulb is difficult for many observers to dismiss entirely, given the striking parallels to modern electrical components. Proponents of the ancient electricity theory argue that the Dendra relief demonstrates not merely symbolic artistry but a functional understanding of energy generation. If the carving indeed represents an electrical device, the Egyptians may have harnessed electricity for lighting, ceremonial purposes, or even technological applications that have left no other surviving evidence. The implications are staggering. A civilization long thought to rely exclusively on manual labor, simple tools, and rudimentary metallurgy could have had access to advanced knowledge and practical application of energy far ahead of its time. While no physical remnants of electrical systems have been found at Dendra, the existence of the relief raises questions about the extent of lost knowledge in ancient civilizations. Critics and mainstream Egyptologists maintain that the relief is purely symbolic, part of the broader tradition of Egyptian sacred art. In their view, the lotus flower represents creation and rebirth, the snake signifies divine energy or the renewal of life, and the bulbous enclosure is merely a stylistic convention. According to this interpretation, ancient Egyptians did not require technological knowledge to convey complex cosmological and religious ideas. Their art was encoded with symbolism that modern observers may misinterpret when applying contemporary technological paradigms. While plausible, this explanation does not fully account for the uncanny resemblance to electrical components, leaving room for debate and speculation. The context of the relief adds to its intrigue. It is located in a subterranean crypt, an area that would have been dark without artificial illumination. This raises practical questions. If the Egyptians had advanced lighting methods, were such devices in use, or was the relief purely symbolic? Could it be that the depiction represents a hybrid concept, combining symbolic meaning with real-world technology, now lost to history? The placement in a shadowed chamber suggests intentionality, hinting at either ceremonial secrecy or the preservation of specialized knowledge accessible only to a select few. The Dendra light is not an isolated anomaly. Other examples of intricate Egyptian craftsmanship, such as precise stone cutting, advanced metallurgy, and architectural alignment with celestial bodies, indicate that the Egyptians were capable of remarkable technical achievements. The relief, therefore, must be understood within a broader context of exceptional engineering, planning, and artistry. It challenges the conventional narrative that ancient civilizations were incapable of abstract, practical applications of scientific principles, suggesting that the Egyptians may have experimented with or conceptualized technologies that remain enigmatic. Modern technology has provided new tools for analyzing the relief. High-resolution imaging, 3D modeling, and comparative studies with contemporary electrical schematics have allowed theorists to scrutinize every line, curve, and connection. Some researchers argue that the proportions of the bulb correspond to an elongated gas-filled tube, with the serpent representing the filament, and the lotus the base or support. The tubes leading to the box-like structure could signify a power source, perhaps even a rudimentary battery. While speculative, these interpretations underscore the possibility that the relief encodes practical knowledge rather than purely symbolic motifs, suggesting that ancient Egyptians may have possessed concepts approaching electrical engineering. The relief also invites consideration of the transmission and loss of knowledge. Even if the dendrolite represents functional technology, the absence of physical devices today suggests that such knowledge was fragile, possibly restricted to priestly classes or specific workshops, and ultimately lost over centuries. Societal collapse, invasions, and the natural decay of materials could have erased practical implementations, leaving only symbolic depictions. This aligns with broader patterns observed in archaeology, where evidence of advanced techniques appears sporadically and discontinuously, often leaving modern researchers to reconstruct possibilities from fragments, artistic representations, and contextual clues. Another intriguing aspect is the cultural and ritual context. Egyptian society placed immense importance on symbolism, religious observance, and the afterlife. The blending of technical precision with symbolic imagery at Dendra may reflect a culture in which technology, art, and spirituality were deeply intertwined. Devices, if they existed, could have served both practical and ceremonial purposes, illuminating sacred spaces, enhancing rituals, or embodying divine principles in material form. The duality of function and symbolism highlights the sophistication of Egyptian thought, suggesting that their approach to technology was holistic, integrating practical use, religious significance, and philosophical meaning. Debates surrounding the dendrolite illustrate a broader tension between mainstream archaeology and alternative interpretations of ancient technology. Skeptics emphasize that symbolic explanations are sufficient to account for the relief, while proponents of alternative theories argue that the Egyptians' technical genius has been systematically underestimated. Regardless of the ultimate explanation, the relief serves as a focal point for discussions about lost knowledge, the sophistication of ancient civilizations, and the potential for discoveries that challenge conventional historical timelines. It embodies the enduring mystery of human innovation, bridging art, technology, and spirituality in a manner that continues to provoke curiosity. Finally, the dendrolite invites reflection on the nature of human history itself. Whether symbolic or technological, the relief is a testament to the intellectual and creative capacity of ancient Egyptians. It demonstrates that a civilization thousands of years old could conceptualize complex systems, encode meaning in visual form, and integrate artistic, scientific, and spiritual knowledge. The mystery of the dendrolite challenges modern assumptions about the past, reminding us that what we see preserved in stone may only hint at a far richer and more sophisticated understanding of the world than conventional history acknowledges. Ultimately, the dendrolite is more than a bas-relief, it is a symbol of the enigma that surrounds ancient Egypt. It embodies the intersection of art, technology, and spirituality, raising profound questions about human capability, the preservation of knowledge, and the limits of historical interpretation. Whether it represents an advanced electrical device or a masterful symbolic construct, it forces us to confront the possibility that our ancestors possessed insights and ingenuity that surpass what we often assume. It is a silent challenge from the past, urging us to look deeper, question assumptions, and acknowledge that history is far more complex, mysterious, and astonishing than the conventional narrative allows. Among the most enigmatic and widely debated mysteries of ancient Egypt are the so-called Saqqara pyramids, particularly the Step Pyramid of Djoser, which predates the Great Pyramid of Giza and represents a pivotal moment in human architectural history. Unlike the smooth-sided pyramids that followed, Djoser's pyramid is a stacked, step structure, composed of 6 mastabas diminishing in size as they ascend, creating a towering monument that rises roughly 69 meters into the sky. Built around 2630 BCE by the architect Imhotep, it is often celebrated as the first monumental stone structure of its kind, a daring leap from traditional mud brick construction to a carefully planned stone edifice. Yet even this first pyramid harbors mysteries that continue to baffle historians, engineers, and archaeologists, from its precise alignment and construction techniques to its symbolic and ritual significance. The Step Pyramid was part of a larger mortuary complex, including courtyards, temples, and ceremonial structures that extended over several hectares. The precision with which the complex was laid out demonstrates an advanced understanding of geometry, measurement, and spatial planning, despite the absence of modern surveying instruments. Excavations reveal that the site was meticulously organized, with subterranean tunnels, chambers, and galleries carved deep into the limestone bedrock. These tunnels served both functional and ritual purposes, providing storage for offerings and facilitating ceremonies intended to honor the pharaoh and ensure his journey into the afterlife. The integration of above-ground architecture with an intricate subterranean network reflects a sophisticated approach to design that anticipates the grandeur of later pyramids, raising questions about the knowledge and ingenuity of early Egyptian builders. What is particularly striking about the step pyramid is the technical mastery required to transition from mud brick to stone construction. Stone, unlike mud brick, demands precision in cutting, alignment, and load distribution. Imhotep and his team would have needed to understand the properties of limestone, including how it responds to pressure, weathering, and erosion. They carved massive blocks with remarkable uniformity, fitting them together to ensure stability over millennia. Some of the stones weigh multiple tons, and their careful placement demonstrates not only engineering skill but also logistical prowess, as materials had to be quarried, transported, and positioned with exacting accuracy. The challenge of moving heavy stones, particularly for the upper levels, indicates a level of social organization and labor coordination previously underestimated for this early period. Equally puzzling is the pyramid's alignment. The structure is oriented along the cardinal points with impressive accuracy, suggesting knowledge of astronomy and surveying techniques. Determining true north, south, east, and west without modern instruments would have required careful observation of celestial bodies, such as stars or the sun's movement, over extended periods. This precision indicates that the Egyptians were capable of integrating scientific observation with architectural planning, anticipating techniques that would become hallmarks of pyramid construction for centuries. The alignment is not merely practical, it is symbolic, reinforcing the connection between the pharaoh, the cosmos, and the eternal order of the universe, a concept central to Egyptian religious thought. The subterranean chambers beneath the step pyramid are themselves a marvel of ancient engineering. Stretching over 6 kilometers of tunnels, they include storage rooms, burial chambers, and ceremonial spaces, carved deep into the bedrock. The precision and complexity of these passages are extraordinary, with carefully aligned galleries and chambers designed to distribute weight and prevent collapse. The use of corbelled ceilings, niches, and reinforced supports reflects an advanced understanding of structural engineering. Moreover, the labyrinthine layout may have had ritual significance, symbolizing the pharaoh's journey through the underworld and his eventual resurrection. This dual function, structural and symbolic, demonstrates a level of planning and conceptual sophistication that continues to challenge historians. The symbolic dimension of the step pyramid cannot be overstated. The step design itself may represent the pharaoh's ascent to the heavens, with each mastaba symbolizing a stage in the journey from mortal life to divine immortality. Carvings, inscriptions, and reliefs throughout the complex further emphasize themes of rebirth, cosmic order, and divine kingship. The pyramid's verticality, combined with its subterranean depth, creates a symbolic axis connecting the earth, the underworld, and the sky, reflecting a holistic vision of existence that integrates physical construction with spiritual meaning. Such integration of architecture and cosmology underscores the Egyptians' ability to translate abstract religious concepts into enduring material form. Another aspect that continues to puzzle researchers is the sheer labor required for construction. Estimates suggest that tens of thousands of workers, including skilled artisans, laborers, and supervisors, were involved over a period of decades. Organizing and sustaining such a workforce would have required not only logistical skill but also social cohesion, resource management, and hierarchical organization. Evidence from workers' villages and provisioning sites suggests that the Egyptians provided food, shelter, and medical care for laborers, indicating a society capable of sustaining large-scale projects over long periods. This challenges assumptions that monumental construction requires a fully urbanized society, showing instead that centralized planning, cultural motivation, and coordinated effort can produce extraordinary achievements even in relatively early stages of civilization. The discovery of artifacts, tools, and inscriptions at Saqqara further highlights the Egyptians' technical and artistic sophistication. Copper chisels, stone hammers, and dolerite pounding stones were used to shape limestone blocks with remarkable precision. Inscriptions and reliefs suggest that the pyramid's construction was a carefully documented process, with architects, scribes, and priests playing specific roles in overseeing the project. The integration of administrative oversight, technical skill, and spiritual purpose demonstrates a culture in which engineering, governance, and religion were inseparably linked. The step pyramid was not merely a tomb but a manifestation of state power, religious devotion, and human ingenuity. Despite centuries of study, many questions remain. The exact methods used to move the stones, construct the corbelled ceilings, and maintain alignment continue to elude definitive explanation. Experimental archaeology has attempted to replicate aspects of construction, using ramps, levers, and counterweights, but the precision achieved at Saqqara often surpasses modern expectations. Some theorists even suggest the possibility of lost techniques or tools, now forgotten, that allowed early Egyptians to accomplish feats that remain difficult to reproduce today. The mystery persists because the step pyramid embodies a combination of scale, precision, and symbolic sophistication that is rare not only in ancient Egypt but in global architectural history. The significance of Saqqara extends beyond its historical and technical aspects. It challenges modern assumptions about the trajectory of human civilization. By demonstrating that monumental stone construction, precise alignment, and complex symbolic integration were possible in the 3rd millennium BCE, it forces a re-evaluation of what early civilizations could achieve. The step pyramid suggests that social organization, religious motivation, and technical skill were deeply intertwined, and that monumental architecture was as much about cultural expression and cosmological understanding as it was about engineering. Ultimately, the step pyramid of Djoser is a testament to human vision, ambition, and capability. It represents a moment in history when humans transcended simple construction, integrating technical knowledge, symbolic meaning, and social coordination into a single enduring form. Every precisely cut stone, every aligned chamber, and every carved relief speaks to a civilization that understood both the material and the metaphysical. Saqqara invites us to reconsider the nature of ancient achievement, challenging assumptions about technological and societal development and reminding us that human ingenuity has always been capable of astonishing feats. In contemplating the step pyramid, we are confronted with profound questions about knowledge, creativity, and the transmission of skill across generations. The methods, tools, and conceptual frameworks used to construct this monumental site may be partially lost to time, yet the enduring structure provides undeniable evidence of extraordinary achievement. Saqqara is not merely a tomb, it is a chronicle carved in stone, a testament to the power of human imagination, and an enduring mystery that continues to captivate scholars, engineers, and enthusiasts. Its existence challenges the linear narratives of history, suggesting that ancient societies possessed levels of sophistication, technical ability, and symbolic insight that continue to inspire awe and provoke debate. The step pyramid remains a profound symbol of human potential. It demonstrates that the desire to reach toward the heavens, to codify belief in physical form, and to organize society around shared purpose has been present in human civilization since its earliest monumental endeavors. Saqqara's legacy is more than architectural, it is philosophical, cultural, and technological, compelling us to confront the remarkable capabilities of our ancestors and to recognize that the mysteries of the past often extend far beyond the explanations we think we know. Across the arid expanse of Peru, hidden high in the Andes Mountains, lies one of the most enigmatic archaeological sites in the world, Machu Picchu. Unlike the sprawling cities of ancient Mesopotamia or the monumental pyramids of Egypt, Machu Picchu was constructed in relative isolation, perched precariously on a mountain ridge nearly 2,430 meters above sea level. Built during the 15th century under the Inca Empire, it represents an extraordinary blend of engineering, architecture, and environmental adaptation. While it is often celebrated for its breathtaking beauty and integration with the surrounding landscape, Machu Picchu also poses profound mysteries that challenge conventional understanding of Inca technology, societal organization, and cultural priorities. One of the most remarkable aspects of Machu Picchu is the precision and stability of its stone construction. The Incas employed a technique known as ashlar masonry, in which massive stones are cut with such accuracy that they fit together without mortar. Some of the largest stones weigh several tons, yet their joints are so precise that even a knife blade cannot fit between them. This method provided exceptional durability, allowing the structures to withstand centuries of earthquakes and heavy rainfall in a region notorious for geological instability. The engineering knowledge required to quarry, transport, shape, and fit these stones is staggering, particularly given the steep and rugged terrain, which would have presented enormous logistical challenges. The city's location itself raises questions about Inca planning and astronomical knowledge. Machu Picchu is oriented in a way that aligns with key astronomical events, including the solstices and equinoxes. Certain structures, such as the Intihuatana stone, a carved rock believed to function as an astronomical observatory, demonstrate precise alignment with the sun's position throughout the year. This integration of architecture and astronomy indicates that the Incas possessed sophisticated observational knowledge and were able to incorporate it into urban design. It also suggests a society deeply attuned to celestial cycles, linking the practical and spiritual aspects of life in ways that continue to fascinate modern scholars. Water management at Machu Picchu further highlights the ingenuity of Inca engineering. The site contains an intricate network of aqueducts, channels, and fountains designed to distribute and manage water efficiently across the city. Rainwater, abundant in the region, is channeled and filtered, preventing flooding and erosion while providing fresh water for agricultural terraces and residential areas. The drainage systems are designed with an understanding of gravity, pressure, and seasonal variation, showcasing an advanced mastery of hydraulics. This level of environmental adaptation underscores the Incas' ability to harmonize construction with nature, creating a city that is both functional and resilient despite the challenges posed by its location. The agricultural terraces surrounding Machu Picchu are another testament to Inca ingenuity. Carved into steep mountainsides, these terraces not only provided food but also stabilized the slopes and reduced soil erosion. The Incas implemented sophisticated soil management techniques, incorporating layers of gravel, sand, and fertile topsoil to optimize drainage and fertility. The terraces reflect a combination of agricultural science, environmental engineering, and labor organization, allowing the Incas to sustain a substantial population in a region where traditional farming would have been nearly impossible. This interplay of agriculture, architecture, and landscape engineering demonstrates a holistic approach to city planning that remains extraordinary by modern standards. Despite these achievements, the purpose of Machu Picchu remains a subject of debate. Some scholars argue that it functioned primarily as a royal estate for the Inca Emperor Pachacuti, serving as a retreat, administrative center, and ceremonial hub. Others suggest it may have had a more spiritual or religious function, possibly acting as a pilgrimage site or sacred observatory. The lack of definitive written records complicates interpretation, but the combination of ceremonial spaces, residential complexes, and agricultural infrastructure indicates a multifaceted role. Whatever its purpose, Machu Picchu reflects an unparalleled synthesis of engineering, aesthetics, and cultural significance, revealing a civilization capable of extraordinary achievements in both practical and symbolic realms. The logistics of construction continue to puzzle researchers. Moving massive stones up steep, often unstable mountain slopes without wheeled vehicles or draft animals required extraordinary coordination and ingenuity. The Incas likely relied on manpower, ropes, levers, and carefully constructed pathways, yet the precision achieved suggests careful planning, trial-and-error experimentation, and a deep understanding of material behavior. Some stones exhibit complex joints, irregular shapes, and precise angles that imply a level of craftsmanship that continues to inspire awe. The combination of scale, precision, and terrain management makes Machu Picchu one of the most technically sophisticated sites in pre-Columbian America. Equally remarkable is the city's integration with its natural environment. Buildings are constructed to complement the contours of the mountain, preserving natural rock formations and minimizing ecological disruption. The architects of Machu Picchu designed structures that blend seamlessly with the landscape, creating a harmonious visual and functional unity between human construction and natural terrain. This integration extends to the spiritual dimension as well. The Incas revered mountains, rivers, and celestial phenomena, embedding cosmology into the city's layout. Machu Picchu exemplifies a society in which environmental awareness, engineering skill, and spiritual belief were inseparable, producing a site that is both practical and profoundly symbolic. Archaeological research also reveals the social complexity required to realize Machu Picchu. Coordinating thousands of laborers for quarrying, transporting, and constructing stone structures, while simultaneously managing agricultural production and ceremonial activities, indicates a highly organized society with administrative and logistical capabilities. The labor force would have required provisioning, shelter, and healthcare, suggesting that the Incas had sophisticated systems for resource management, social hierarchy, and communal cooperation. These organizational skills, combined with technical expertise, underscore the Incas' ability to mobilize and sustain large-scale projects, challenging assumptions about the technological limitations of pre-Columbian societies. The preservation of Machu Picchu adds to its mystique. Hidden from the outside world until its rediscovery by Hiram Bingham in 1911, the site remained largely intact due to its remote location. The preservation of stone structures, terraces, and ceremonial areas allows modern observers to appreciate the ingenuity and sophistication of Inca engineering firsthand. Even in the face of centuries of erosion, earthquakes, and environmental pressures, the site continues to demonstrate the resilience of Inca construction methods. The combination of durability, precision, and aesthetic integration remains a benchmark for architectural and engineering achievement, inspiring scholars, engineers, and tourists alike. Machu Picchu also invites reflection on the nature of lost knowledge. The Incas left no written records in the form of alphabets, relying instead on quipus, knotted cords used for record keeping, leaving much of their technical and administrative knowledge opaque to modern researchers. How they achieved such precise stone cutting, terrace construction, and water management without conventional writing or formal engineering texts remains a puzzle. The city stands as a testament to the sophistication of oral knowledge, practical experience, and cultural transmission, highlighting the human capacity for complex problem-solving even in the absence of documented scientific principles. The spiritual dimension of Machu Picchu cannot be overlooked. Temples, shrines, and ritual spaces are strategically placed to interact with natural features, such as sunrises, sunsets, and mountain peaks. Ceremonial centers, including the Temple of the Sun, demonstrate precise astronomical alignment, further reinforcing the connection between observation, ritual, and architecture. The Incas' ability to integrate celestial phenomena into construction reflects a worldview in which science, spirituality, and governance were deeply interconnected. Machu Picchu exemplifies a society in which technological achievement was inseparable from religious and cultural meaning. In the end, Machu Picchu stands as both a technical marvel and a symbol of human ingenuity. Its stonework, terraces, water management systems, and astronomical alignments reveal a civilization capable of extraordinary achievements in engineering, architecture, and urban planning. The site demonstrates that the Incas were not merely agriculturalists or conquerors but visionary architects, planners, and engineers who harmonized human endeavor with the natural environment. Machu Picchu continues to inspire awe, provoke scholarly debate, and challenge assumptions about the limits of pre-Columbian knowledge. Ultimately, the city serves as a reminder that human creativity, ingenuity, and adaptability have long been capable of extraordinary feats. Machu Picchu is more than a collection of stone structures, it is a reflection of the Inca worldview, an enduring testament to the power of cultural vision, and a monument to human potential. It challenges modern observers to reconsider the capabilities of ancient societies and to acknowledge that the mysteries of the past often surpass even our most imaginative expectations. In its enduring stone walls and terraces, Machu Picchu silently narrates a story of technological mastery, environmental harmony, and cultural sophistication, inviting us to explore, question, and marvel at the ingenuity of humanity's ancestors. High atop the mountains of Bolivia, near the serene expanse of Lake Titicaca, lies Puma Punku, a site that continues to defy conventional understanding of ancient engineering and architectural capability. Part of the larger Tiwanaku complex, Puma Punku is a testament to human ingenuity, where enormous stone blocks, precise joinery, and complex construction techniques converge in a manner that seems to challenge the technological limitations of its time. Built between 500 and 600 CE, the site reveals an advanced understanding of geometry, astronomy, and materials science, all applied without the aid of modern machinery or written engineering manuals. The more researchers study Puma Punku, the more its creator's sophistication becomes apparent, leaving archaeologists and engineers alike both awed and perplexed. The scale of the stones at Puma Punku is immediately striking. Some blocks weigh over 100 tons, yet they are cut with such precision that they fit together perfectly without the use of mortar. Many stones feature intricate interlocking shapes, including right angles, L-shaped cuts, and precisely drilled holes designed to hold dowels or pins. The precision with which these stones were carved, polished, and positioned implies a level of craftsmanship far beyond what is traditionally attributed to pre-Columbian societies. Experimental archaeologists attempting to replicate the cuts and fits using stone or copper tools consistently encounter difficulties, demonstrating that the techniques employed at Puma Punku were not only sophisticated but also potentially lost to time. Transportation of the stones adds another layer of complexity to the site's mystery. Many of the massive blocks were quarried several kilometers from their final positions, often across steep, uneven terrain. Moving these stones would have required a combination of ingenuity, manpower, and perhaps tools or techniques that remain unknown. Hypotheses suggest sledges, rollers, levers, or lubricated pathways, yet even the most plausible methods strain credibility when faced with the size and weight of the stones. The feat implies not just technical skill but also exceptional organization, coordination, and an understanding of physics that allowed the builders to manipulate enormous materials with precision. In addition to sheer size, Puma Punku demonstrates extraordinary attention to geometric and architectural precision. Many stones are perfectly squared, with angles so exact that they would be difficult to achieve even with modern equipment. The alignment of certain platforms and structures suggests that the builders had knowledge of astronomy, potentially using the stars or sun as reference points to orient their constructions. Some theorists propose that specific alignments mark solstices or other celestial events, indicating that Puma Punku was not only a technical achievement but also a ceremonial or cosmological site. The integration of practical construction, aesthetics, and astronomical alignment reflects a sophisticated intellectual framework that continues to captivate scholars. The site also features complex architectural techniques, such as finely fitted stone terraces, channels, and platforms designed to provide stability and resist seismic activity. The precision of the stone joints, some of which include tongue-and groove mechanisms, demonstrates an understanding of stress distribution and structural integrity that is remarkable for its time. These methods suggest that the builders possessed empirical knowledge of construction principles, potentially passed down through generations, which allowed them to design structures that have endured for centuries despite earthquakes and other natural forces. Some researchers have proposed that Puma Punku might reflect the influence of a lost or unknown civilization, whose advanced knowledge preceded the Tiwanaku culture. The exceptional precision and scale of the stonework are not mirrored in contemporary sites in the region, raising questions about whether the knowledge required for such feats was inherited, independently developed, or perhaps even partially forgotten by subsequent generations. This possibility adds a layer of intrigue, as it challenges linear conceptions of technological development and suggests that ancient history may contain chapters that remain hidden or poorly understood. The symbolic and ceremonial aspects of Puma Punku are equally compelling. The orientation of platforms, placement of stones, and potential astronomical alignments indicate that the site served purposes beyond the practical. It may have functioned as a center for religious rituals, astronomical observation, or societal governance. The integration of sacred geometry into construction reflects a worldview in which architecture was inseparable from cosmology, spirituality, and social order. Such considerations highlight that the site was not built merely for utilitarian reasons but as a deliberate expression of cultural, religious, and scientific knowledge. The technical challenges faced by the builders were immense. Quarrying, shaping, and transporting stones of such magnitude required advanced knowledge of material properties, cutting techniques, and force management. The precise interlocking joints suggest the use of templates or measurement systems, though no physical evidence of these tools has survived. The alignment and leveling of platforms indicate careful observation and possibly iterative adjustment, reflecting both patience and an empirical understanding of engineering principles. The convergence of these skills in one site underscores the sophistication of the society that created Pumapunku. Archaeologists and engineers continue to be fascinated by the tools that might have been used. While evidence points to stone hammers and chisels, these simple tools seem insufficient to achieve the extraordinary precision observed. Some have speculated about lost techniques, advanced mechanical devices, or highly refined manual methods that have yet to be rediscovered. The absence of definitive records leaves the site shrouded in mystery, allowing for both scientific inquiry and imaginative speculation. Pumapunku thus serves as a reminder that history may have included capabilities and knowledge that were lost over time, only hinted at through the enduring stones themselves. The endurance of Pumapunku is a testament to both the materials and techniques employed. Despite centuries of earthquakes, weathering, and human interference, the site remains remarkably intact. The precision and durability of the stonework reveal a deep understanding of natural forces and material science, highlighting that ancient societies were not merely constructing for the present but designing with foresight and permanence in mind. This longevity reinforces the idea that the site's creators possess technical knowledge and planning skills that rival, and in some cases surpass, modern expectations. Finally, Pumapunku continues to inspire questions about human potential, lost knowledge, and the nature of ancient civilizations. The site challenges assumptions about pre-Columbian technological capabilities, suggesting that societies of the Andes achieved feats previously thought impossible without advanced machinery. The extraordinary precision, scale, and integration of engineering, astronomy, and ceremonial purpose make Pumapunku one of the most compelling archaeological mysteries in the world. Its existence urges scholars and enthusiasts to reconsider linear narratives of technological development and to recognize that ancient cultures may have possessed knowledge and skill that is now partially forgotten or misunderstood. Pumapunku stands as a testament to ingenuity, coordination, and vision. Every precisely cut stone, every interlocking joint, and every astronomically aligned platform is evidence of a civilization capable of extraordinary achievements. The site compels us to confront the possibility that human history is far richer and more complex than conventional narratives suggest. It challenges us to imagine the methods, knowledge, and cultural motivations that enabled such feats and to acknowledge that the past still holds secrets capable of reshaping our understanding of human capability. Pumapunku is not only a marvel of construction but also a profound reminder that ancient societies were capable of combining art, science, and spirituality in ways that continue to captivate and mystify the modern world. Deep within the dense jungles of Central America, nestled along the steep ridges and river valleys of Guatemala, lies the ancient city of Tikal, one of the most magnificent and mysterious centers of the Maya civilization. Flourishing between 200 and 900 CE, Tikal was a city of staggering scale and complexity, featuring towering temples, expansive plazas, intricate roadways, and monumental palaces. The city's achievements in architecture, astronomy, mathematics, and urban planning continue to astonish researchers, particularly given the technological constraints of the time. Yet Tikal also holds mysteries that remain unresolved, from the methods used to construct its soaring temples to the reasons for its sudden decline, challenging scholars to piece together a civilization whose sophistication rivals that of ancient Egypt and Mesopotamia. The scale of Tikal is breathtaking. Temple 4, one of the tallest pre-Columbian structures in the Americas, rises over 70 meters into the sky, visible from miles around. Constructing such a monumental structure in a tropical jungle environment, with limited tools and without wheeled vehicles, required extraordinary engineering skill. Stones had to be quarried, transported, and shaped with precision, often over challenging terrain, while wooden scaffolding and ramps facilitated construction at great heights. The stability of these structures, many of which have withstood earthquakes, hurricanes, and centuries of environmental decay, demonstrates not only practical engineering expertise but also a deep understanding of materials, structural forces, and the local ecosystem. One of the most remarkable aspects of Tikal is the precision with which the Maya integrated astronomy into urban design. Observatories and temple alignments reveal a sophisticated understanding of solar, lunar, and planetary cycles. Certain temples, such as Temple I and Temple II, are positioned so that sunlight illuminates specific shrines during solstices or equinoxes, indicating careful observation and recording of celestial events over decades, if not centuries. These alignments were likely tied to ritual calendars, agricultural cycles, and the political authority of the rulers, who derived legitimacy from their perceived connection to celestial forces. The ability to combine architecture, ritual, and astronomy highlights the Maya as both scientists and spiritual leaders, capable of integrating empirical observation with symbolic meaning. Tikal's infrastructure is equally impressive. The city was interconnected by a network of causeways, plazas, and residential compounds, carefully planned to facilitate movement, trade, and ceremonial processions. Water management systems, including reservoirs, canals, and terraces, allowed the city to sustain a large population in a region subject to seasonal rainfall variation. These engineering feats demonstrate not only technical knowledge but also sophisticated urban planning, with attention to logistics, resource management, and sustainability. The Maya achieved a delicate balance between human habitation and the surrounding jungle environment, ensuring the city's prosperity while minimizing ecological disruption. The artistry of Tikal is a testament to the civilization's cultural sophistication. Temples and palaces are adorned with intricate carvings, stucco reliefs, and hieroglyphic inscriptions documenting history, mythology, and political events. The precision of the carvings, combined with the complexity of the Mayan calendar and writing system, suggests a highly literate and organized society capable of preserving knowledge across generations. These inscriptions not only celebrate rulers and deities but also encode astronomical and calendrical information, reflecting a civilization in which art, science, and governance were deeply intertwined. Despite these achievements, Tikal's construction methods remain enigmatic. The Maya lacked iron tools, draft animals, and the wheel, yet they managed to move and shape massive limestone blocks with remarkable precision. Quarrying techniques, transport methods, and lifting systems remain partially speculative, with hypotheses ranging from simple manpower and wooden levers to more complex arrangements involving scaffolding, ramps, and counterweights. The consistency and accuracy of construction across the city indicate a standardized approach, likely involving master builders, skilled laborers, and coordinated teams, suggesting a level of social organization that was both disciplined and highly hierarchical. The city's sudden decline adds another layer of mystery. By the end of the 9th century, Tikal experienced a dramatic population decrease and abandonment, coinciding with the broader collapse of the southern Maya lowland cities. While factors such as drought, environmental degradation, warfare, and social upheaval have been proposed, no single explanation fully accounts for the rapidity and extent of the decline. This collapse, following centuries of architectural, astronomical, and societal achievement, challenges assumptions about the stability of complex civilizations and highlights the delicate interplay between human ingenuity and environmental constraints. Tikal's temples, particularly Temple IV and Temple V, illustrate advanced understanding of both load distribution and aesthetics. The steep staircases, elevated platforms, and precisely fitted stones reflect careful calculation of weight, balance, and structural integrity. The temple's soaring heights were likely designed to project political and spiritual authority, with their verticality symbolizing a connection between the earthly realm and the cosmos. Their endurance over centuries, surviving both natural forces and human activity, demonstrates that the Maya mastered construction techniques that combined functionality with symbolic resonance, creating monuments that were simultaneously practical, ceremonial, and visually imposing. Water management in Tikal exemplifies an advanced understanding of environmental engineering. The city's reservoirs and canals were carefully positioned to capture, store, and distribute rainwater throughout the year, sustaining agriculture and daily life even during prolonged dry seasons. Terraces, filtration systems, and channels reflect an empirical understanding of hydrology and soil conservation, allowing the Maya to thrive in a region where mismanagement of water could have led to rapid decline. This ingenuity underscores the Maya's ability to adapt to their environment, demonstrating that their technological sophistication extended beyond architecture and astronomy into the practical management of resources critical for urban survival. Social organization at Tikal was complex and highly structured, as evidenced by the scale and coordination required to construct monumental architecture, maintain infrastructure, and conduct ceremonial activities. Large labor forces, likely numbering in the tens of thousands, would have been mobilized to quarry stone, transport materials, and execute construction projects, requiring systems for food distribution, shelter, and healthcare. Administrative oversight was necessary to coordinate artisans, laborers, and priests, reflecting a civilization capable of complex governance and large-scale project management. This integration of technical expertise, social organization, and religious authority exemplifies the Maya as a sophisticated civilization, capable of both intellectual and practical achievements that continue to inspire admiration. The inscriptions and artifacts found at Tikal further deepen the mystery. Hieroglyphic texts provide insight into rulers, dynasties, and ceremonial events, while ceramics, sculptures, and painted murals reveal an advanced aesthetic sensibility. These artifacts indicate a society that valued knowledge, artistry, and historical memory, capable of encoding complex information into physical and visual forms. The combination of monumental architecture, astronomical observation, and symbolic expression illustrates a civilization in which science, religion, and art were not separate disciplines but components of a unified cultural worldview. In reflecting on Tikal, one confronts the remarkable ingenuity and sophistication of the Maya civilization. The city's temples, plazas, and infrastructure demonstrate technical mastery, while its integration with astronomy and ritual illustrates profound intellectual and spiritual understanding. Tikal challenges modern assumptions about the limits of pre-Columbian technology and urban planning, revealing a civilization capable of creating monumental achievements that rival those of the Old World. Its construction, resilience, and sudden decline provoke questions about human ingenuity, environmental adaptation, and the fragility of complex societies. Ultimately, Tikal is more than an archaeological site, it is a testament to human potential and a repository of mysteries that continue to captivate scholars and enthusiasts alike. It demonstrates that ancient civilizations could integrate technology, culture, and spirituality in ways that remain astonishing today. Every precisely constructed temple, every astronomical alignment, and every intricate inscription reflects a civilization that combined observation, skill, and vision to create a city of enduring significance. Tikal stands as both a monument to achievement and a reminder of the enduring mysteries of human history, challenging us to reconsider what ancient societies were capable of and to acknowledge the sophistication and ingenuity of a people whose knowledge continues to inspire wonder. Hidden deep within the deserts of modern-day Jordan lies a city that has captivated explorers, historians, and archaeologists for centuries, Petra. Carved directly into rose-colored cliffs, Petra is a marvel of ancient engineering, artistry, and urban planning. Thought to have been established as early as the 4th century BCE by the Nabatean civilization, Petra thrived as a crucial trading hub connecting Arabia, Egypt, and the Mediterranean world. Yet beyond its striking facades and monumental tombs, Petra harbors secrets that continue to baffle researchers, from its advanced hydraulic engineering to the sophisticated methods used to construct its elaborate rock-cut architecture. The city challenges our understanding of what ancient civilizations could achieve with limited technology, revealing a level of ingenuity and adaptation that continues to inspire awe. The most immediate and striking feature of Petra is its monumental facades carved into cliffs of sandstone. The treasury, or Al-Khazna, is perhaps the most famous example, with its intricate Corinthian columns, elaborate sculptures, and precise proportions. Unlike conventional construction, these structures were not built from stacked stones but sculpted directly from solid rock, requiring careful planning, skilled artisanship, and exceptional spatial awareness. The precision of the carvings, the symmetry of the facades, and the integration of architectural elements demonstrate a mastery of both artistry and engineering. Achieving this level of detail and scale in a vertical cliff face is a feat that continues to challenge modern craftsmen and engineers, highlighting the Nabateans' remarkable capabilities. Petra's urban design reflects an extraordinary understanding of spatial planning and environmental adaptation. The city is not a random cluster of dwellings and tombs, it is a carefully organized settlement with streets, plazas, residential areas, and ceremonial spaces laid out to maximize both function and aesthetic impact. The Sikh, a narrow gorge serving as the main entrance, functions not only as a defensive feature but also as a controlled ceremonial pathway, guiding visitors through a dramatic approach to the city. This careful orchestration of movement, perspective, and spatial experience demonstrates an understanding of urban psychology and architecture that remains sophisticated even by contemporary standards. Perhaps the most remarkable aspect of Petra is its advanced hydraulic engineering. The city was constructed in a region with scarce and unpredictable water resources, yet the Nabateans developed a system of dams, cisterns, channels, and reservoirs capable of storing, distributing, and managing water throughout the settlement. Rainwater was captured from surrounding cliffs, filtered, and directed into storage systems that ensured a reliable water supply year-round. This network also prevented flooding during seasonal storms, protecting the city's structures from erosion and collapse. Such hydraulic ingenuity reveals a profound understanding of environmental engineering, allowing the Nabateans to create a thriving city in a harsh and arid landscape. The construction techniques used at Petra further exemplify the civilization's technical skill. Carving structures from solid rock required precise planning to prevent structural collapse, careful sequencing of excavation, and coordination among skilled artisans. The Nabateans had to visualize entire buildings and facades in 3 dimensions before carving, ensuring that proportions, angles, and decorative elements aligned perfectly. The integration of functional architecture, such as water channels and residential spaces, with ceremonial and decorative elements reflects a holistic approach to urban design that combines practicality with aesthetics. Petra's monuments are not only engineering feats but also cultural statements. Tombs, temples, and public buildings exhibit a fusion of artistic styles, including Hellenistic, Roman, and indigenous Nabatean influences. This blending of cultural motifs demonstrates the city's role as a cosmopolitan hub, absorbing and synthesizing artistic and architectural traditions from across the ancient world. The ability to integrate diverse influences while maintaining technical precision and cohesive design underscores the Nabatean sophistication and adaptability. The logistical challenges of constructing Petra in such a rugged environment are staggering. Transporting materials, coordinating labor, and carving massive structures in sandstone cliffs required extensive planning and organization. The Nabateans would have needed a workforce skilled not only in stone carving but also in engineering, hydraulics, and urban planning. Evidence of terraces, stairways, and scaffolding suggests advanced techniques for both construction and maintenance, indicating that Petra was not only built but continuously adapted and expanded over centuries. The combination of skill, labor organization, and ingenuity reflects a society capable of large-scale, long-term projects with remarkable precision. Petra also demonstrates a sophisticated understanding of natural hazards and geology. The Nabateans chose sandstone cliffs for their workability, yet sandstone is prone to erosion and weathering. Structures were carefully oriented and designed to minimize damage from water runoff and seasonal rains. Cisterns, channels, and terraces were engineered to manage water flow, reduce erosion, and stabilize cliff faces. This integration of geology, architecture, and urban planning highlights an empirical knowledge of natural forces, suggesting that the Nabateans combined observation, experimentation, and practical application to create a resilient city. The religious and ceremonial aspects of Petra are equally significant. Temples, tombs, and ritual spaces are strategically positioned and often aligned with celestial events or natural features. The Khazna, for example, may have functioned as both a tomb and a ceremonial focal point, while other structures, such as the monastery, ad-Dair, reflect astronomical alignments and symbolic orientation. These alignments reveal a culture deeply attuned to cosmology, ritual, and the sacred dimension of space, integrating spiritual, practical, and aesthetic concerns into the very fabric of the city. Trade and economic sophistication also contributed to Petra's prominence. Located along caravan routes connecting Arabia, Egypt, and the Mediterranean, the city prospered as a center of commerce, taxation, and resource distribution. Its urban planning, defensive design, and monumental architecture reflect a society that leveraged wealth and strategic positioning to assert power and influence. The integration of economic, political, and ceremonial functions within a city carved from cliffs underscores the Nabateans' ability to combine multiple domains of knowledge in practical and symbolic ways. The sudden decline and partial abandonment of Petra remain a mystery. While trade route shifts, earthquakes, and political changes are cited as contributing factors, the exact reasons for the city's decline are still debated. Despite this, the monuments and urban infrastructure that survive continue to astonish visitors, providing insight into the capabilities and sophistication of a civilization that thrived in a harsh, demanding environment. The city's enduring legacy lies not only in its monumental beauty but also in the technical and organizational knowledge embedded within its design. Petra's influence extends beyond its immediate historical context. Its architecture, engineering, and urban planning provide evidence of a civilization capable of integrating artistry, science, and practicality in ways that continue to inspire modern architects and engineers. The combination of monumental rock-cut structures, advanced water management, and carefully planned urban layouts illustrates a society that understood both the physical and symbolic dimensions of city building. Petra challenges assumptions about the technological and cultural capabilities of ancient civilizations, showing that ingenuity and adaptability are not confined to resource-rich or technologically advanced societies. Ultimately, Petra stands as a testament to human creativity, resilience, and technical mastery. Its rock-cut monuments, hydraulic systems, and urban design reflect a civilization capable of achieving extraordinary feats in challenging conditions. The city invites us to reconsider our understanding of ancient engineering, architecture, and urban planning, demonstrating that ingenuity and vision are universal human traits. Petra's enduring beauty, precision, and complexity continue to captivate, inspire, and mystify, offering a window into a past where human determination, skill, and creativity converged to produce one of the most remarkable cities the ancient world has ever known. In contemplating Petra, one recognizes not just a marvel of stone but a monument to human adaptability, intelligence, and ambition. Every carved facade, engineered water system, and carefully planned plaza testifies to a civilization that thrived through knowledge, observation, and skill. Petra challenges the modern imagination, reminding us that human potential, when combined with vision, creativity, and ingenuity, can overcome even the most daunting natural obstacles. It is a city that speaks across the millennia, quietly asserting that the mysteries of the past are not only to be studied but to be marveled at, inviting us to ponder what other secrets remain hidden, waiting to be discovered and understood. Scattered across the remote deserts of Saudi Arabia and stretching into parts of Jordan and Iraq, the mysterious structures known as the Nabatean and pre-Islamic desert monuments, including enigmatic stone circles, megalithic tombs, and massive carved monoliths, continue to perplex archaeologists and historians. These structures, many of which date back thousands of years, challenge conventional understandings of early human engineering, astronomical knowledge, and ritual practice. Unlike the well-documented civilizations of Mesopotamia, Egypt, or the Indus Valley, these desert sites often lack inscriptions, written records, or clear cultural context, leaving researchers to interpret them through their physical and spatial characteristics. The sheer scale, precision, and location of these monuments raise profound questions about the capabilities, knowledge, and motivations of the people who constructed them, suggesting that ancient societies may have possessed technical and astronomical understanding far beyond what is typically assumed. One of the most striking features of these desert monuments is the precision with which massive stones were placed and aligned. In many cases, the stones form circles, lines, or geometric arrangements that correspond closely with celestial events, such as solstices, equinoxes, or the positions of prominent stars. The alignment is so exact that some archaeologists have argued that these structures functioned as astronomical observatories, allowing ancient peoples to track the movements of the sun, moon, and planets for calendrical, ceremonial, or agricultural purposes. The ability to observe celestial phenomena and translate them into large-scale stone constructions implies a sophisticated understanding of geometry, timekeeping, and spatial reasoning, achieved without the benefit of modern tools or written instructions. The sheer size of the stones involved adds to the mystery. Many megaliths weigh multiple tons, and in some cases, they have been moved considerable distances from their original quarries. The logistical challenge of transporting, lifting, and placing such stones on uneven desert terrain is staggering. Researchers speculate that ancient builders may have used combinations of ramps, levers, sledges, and human labor to maneuver these massive blocks, yet even with these hypotheses, the precision achieved in their placement is astonishing. The ability to coordinate large labor forces, manage resources, and execute such complex tasks suggests an organized and technically knowledgeable society capable of large-scale planning and execution. In addition to geometric and astronomical considerations, many desert monuments appear to have served ritual or ceremonial purposes. Some stone circles and alignments are located near natural features such as springs, cliffs, or wadis, suggesting that they may have marked sacred sites or functioned as gathering places for religious observances. Excavations have revealed traces of fire pits, offering platforms, and small artifacts, indicating that these sites were not merely symbolic but actively used by communities for ritual activity. The combination of practical engineering, astronomical alignment, and spiritual function reflects a culture in which scientific observation and religious practice were deeply intertwined, creating a holistic worldview encoded in stone. The absence of inscriptions or written records at many of these sites complicates efforts to fully understand their purpose and origin. Unlike civilizations that left behind texts explaining their monuments, these desert structures must be interpreted solely through their physical characteristics and contextual clues. This ambiguity invites both rigorous scientific analysis and speculative theories. Some researchers argue that the sites may have been part of a widespread cultural network, sharing architectural principles, ritual practices, or astronomical knowledge across vast distances. Others suggest that these monuments could represent isolated experiments in geometry, astronomy, or social organization, reflecting localized ingenuity and experimentation. One of the most fascinating aspects of these monuments is the degree of standardization observed across sites separated by hundreds of kilometers. Certain stone circle dimensions, spacing patterns, and orientations recur with remarkable consistency, suggesting the existence of shared measurement systems or architectural templates. This level of standardization implies that knowledge was transmitted between groups or generations, possibly through oral tradition, apprenticeship, or ritual practice. The ability to maintain technical precision across time and space highlights the sophistication of these early desert societies and their capacity for coordinated, long-term projects. Hydraulic and environmental engineering may also have played a role in the placement and function of these desert monuments. Many are strategically located near water sources, seasonal floodplains, or natural catchment areas, indicating an awareness of resource management. Some stone arrangements appear to channel water or prevent erosion, suggesting that builders incorporated practical environmental considerations into ceremonial or astronomical structures. This integration of technical, ecological, and spiritual knowledge demonstrates a holistic understanding of the landscape, where survival, observation, and ritual were interconnected in ways that modern observers are only beginning to appreciate. The methods used to achieve precise geometric arrangements continue to baffle researchers. Despite the lack of conventional tools or written measurement systems, many monuments display near-perfect symmetry, angular alignment, and proportional consistency. Some theorists speculate that builders may have employed primitive sighting devices, ropes, or plumb lines to achieve accuracy, while others argue that advanced observational techniques, possibly passed down through generations, allowed for meticulous planning and execution. Regardless of the methods employed, the results demonstrate a level of technical and cognitive sophistication that is remarkable for prehistoric societies operating in harsh and challenging environments. These desert monuments also raise questions about the social and political organization of their creators. Large-scale construction projects, particularly those involving massive stones and precise layouts, require coordination, leadership, and resource allocation. The existence of these monuments implies a society capable of organizing labor, sustaining construction efforts over long periods, and transmitting technical knowledge to successive generations. This organizational sophistication challenges assumptions that prehistoric desert societies were necessarily small, nomadic, or technologically limited, suggesting instead a capacity for complex social structures and centralized decision-making. The symbolic significance of these monuments cannot be overlooked. Many structures incorporate abstract geometric forms, such as circles, squares, and zigzag patterns, which may have conveyed cosmological, spiritual, or societal meanings. The alignment of these forms with celestial phenomena suggests that ancient peoples encoded their understanding of time, space, and the universe into the built environment. The interplay of geometry, astronomy, and ritual function reflects a worldview in which human observation, environmental awareness, and spiritual expression were inseparable, creating monuments that were both practical and profoundly meaningful. Despite extensive study, many questions remain unanswered. The techniques used to quarry, transport, and place massive stones with such precision, the purposes behind specific alignments, and the cultural context of the builders remain partially obscured. The absence of written records, combined with the erosion and destruction of some sites, leaves significant gaps in our understanding. Yet these very gaps contribute to the enduring fascination of desert monuments, inspiring ongoing research, debate, and speculation. They serve as a reminder that human history is far more complex and nuanced than the surviving records alone can convey. The enduring mystery of these desert monuments also invites reflection on the broader capabilities of early civilizations. The integration of geometry, astronomy, engineering, and ritual suggests that even societies often considered technologically primitive could achieve feats of precision, coordination, and symbolic expression that rival later civilizations. These structures challenge linear narratives of technological development, demonstrating that human ingenuity has long been capable of extraordinary achievement, even in harsh and remote environments. Ultimately, the desert monuments of Arabia and surrounding regions stand as silent witnesses to the ingenuity, vision, and skill of their creators. Every carefully placed stone, every aligned axis, and every geometric configuration speaks to a civilization that understood both the physical and symbolic dimensions of their world. The complexity, precision, and mystery of these sites continue to inspire awe, provoking questions about lost knowledge, ancient technology, and the capabilities of societies long vanished from the historical record. These monuments remind us that human potential has always been remarkable, and that even in the harshest landscapes, early civilizations were capable of creating works that challenge and astonish the modern mind. In contemplating these desert structures, one is struck not only by their technical mastery but also by the depth of vision and cultural intelligence required to conceive and execute them. They embody a synthesis of observation, planning, and spiritual expression that transcends time, leaving a legacy of wonder that persists millennia after their creation. These monuments stand as testaments to human curiosity, creativity, and determination, challenging us to explore, question, and marvel at the capabilities of civilizations that existed long before the advent of written history, and reminding us that the past still holds secrets capable of reshaping our understanding of human achievement. High in the mountains of southern Turkey and northern Syria lies one of the most enigmatic and least understood archaeological sites in the world, Göbekli Tepe. Dating back to around 9600 BCE, this site predates Stonehenge by nearly 6,000 years and challenges conventional narratives of human civilization. Unlike the agricultural villages that emerged later, Göbekli Tepe was constructed by hunter-gatherer societies, suggesting a level of social organization, architectural planning, and symbolic thinking previously thought impossible for this period. Its massive stone pillars, intricately carved with abstract symbols and depictions of animals, raise profound questions about the origins of religion, community, and monumental architecture in human history, challenging the assumption that complex society arises only after agriculture. The scale and complexity of Göbekli Tepe are immediately striking. The site consists of multiple circular and oval structures, each defined by massive T-shaped limestone pillars that reach up to 6 meters in height and weigh as much as 20 tons. These pillars are arranged in precise circles, with two central pillars often flanked by smaller stones, creating a deliberate architectural rhythm and symmetry. Carved into many of these stones are detailed reliefs of animals, including foxes, boars, snakes, and birds, along with abstract symbols that remain undeciphered. The precision and ambition of these constructions indicate that the builders possessed a sophisticated understanding of geometry, design, and communal coordination far beyond what was previously attributed to hunter-gatherer societies. One of the most astonishing aspects of Göbekli Tepe is that it was constructed before the widespread adoption of agriculture. Conventional archaeological theory has long held that the development of permanent settlements, food surpluses, and social hierarchies enabled monumental architecture. Yet Göbekli Tepe appears to have been built by mobile groups who relied on hunting and foraging, suggesting that social and religious motivations may have preceded agriculture, rather than emerging as a consequence of it. This flips traditional models of human societal development on their head, implying that communal, symbolic, and ritual imperatives could drive large-scale cooperative efforts even in societies without settled economies. The carvings at Göbekli Tepe are another source of wonder and mystery. The animal motifs are strikingly realistic, while the abstract symbols are enigmatic, hinting at a symbolic or religious system that we can only partially comprehend. Some researchers speculate that these depictions encode cosmological or mythological knowledge, reflecting a worldview in which humans and animals were deeply intertwined. The presence of such detailed iconography suggests not only artistic skill but also cognitive sophistication, demonstrating that symbolic thought and cultural expression were highly developed long before the rise of cities, writing, or metallurgy. The construction techniques employed at Göbekli Tepe continue to baffle archaeologists. Quarrying, shaping, and erecting massive limestone pillars would have required careful planning, precise measurements, and significant manpower. Experimental archaeology indicates that teams of hunter-gatherers could have accomplished such tasks using ropes, wooden levers, and basic tools, yet the sheer scale and uniformity of the site suggest a level of organization and technical understanding that defies assumptions about nomadic societies. The coordination necessary to quarry, transport, and erect the pillars, as well as to carve intricate reliefs, implies a centralized vision or leadership, raising questions about social hierarchy and decision-making in pre-agricultural communities. The site's layout further hints at sophisticated knowledge of geometry and spatial organization. The circular and oval enclosures are not random, their dimensions, proportions, and alignment indicate deliberate planning. The placement of central pillars and the orientation of entrances may reflect astronomical observations, ritual pathways, or symbolic cosmological principles. Such deliberate architectural choices suggest that the builders of Göbekli Tepe possessed not only technical skill but also conceptual sophistication, integrating symbolic, functional, and environmental considerations into their monumental constructions. Göbekli Tepe also forces a re-evaluation of the role of religion and ritual in early human society. The scale, effort, and symbolic content of the site suggest that it was not merely utilitarian but served as a central ceremonial or religious center. Communal gatherings at Göbekli Tepe may have fostered social cohesion, reinforced shared beliefs, and coordinated labor across dispersed groups. In this sense, the site may have played a critical role in the emergence of complex social structures, acting as a catalyst for cooperation, cultural transmission, and technological innovation long before the rise of agriculture or urban settlement. The preservation of Göbekli Tepe is remarkable. Buried deliberately around 8000 BCE, the site remained hidden for millennia, preserving its stone carvings, structural arrangements, and symbolic motifs. The intentional backfilling suggests an understanding of the site's sacred or symbolic value, hinting at beliefs concerning ritual closure, memory, or cosmology. This deliberate act of concealment adds a layer of mystery, raising questions about why these monumental structures were abandoned and intentionally buried, and what social, religious, or environmental factors drove these decisions. Archaeological evidence indicates that the labor invested in Göbekli Tepe was immense. Tens of thousands of person-days would have been required to quarry, transport, carve, and erect the massive stones, as well as to organize gatherings and maintain the site. For hunter-gatherer communities, this represents an extraordinary allocation of time, energy, and resources, suggesting that the symbolic and ritual significance of the site outweighed immediate economic or survival concerns. The commitment to such monumental effort indicates that early humans were capable of prioritizing shared cultural and spiritual goals, challenging modern assumptions about the motivations and capabilities of pre-agricultural societies. Göbekli Tepe also offers insights into early technological innovation. The stone tools and flint implements found at the site indicate that the builders developed specialized methods for carving, shaping, and finishing limestone, as well as techniques for lifting and positioning massive pillars. The precision of the carvings, combined with the scale of construction, suggests experimentation, problem-solving, and knowledge transmission within the community. The technological acumen displayed at Göbekli Tepe underscores the creativity and adaptability of early humans, revealing that monumental construction is not exclusively a product of sedentary or agrarian societies. The symbolic and ritualistic significance of Göbekli Tepe cannot be overstated. The site appears to have functioned as a focal point for community identity, spiritual expression, and cultural cohesion. The repeated motifs, aligned enclosures, and communal construction suggest that ritual activity was central to societal life, potentially shaping social hierarchies, alliances, and cultural norms. By placing symbolic and religious imperatives at the core of monumental effort, Göbekli Tepe demonstrates that cultural complexity can precede, rather than follow, technological or economic development, redefining how scholars conceptualize the emergence of civilization. Despite decades of research, many questions remain unresolved. The purpose of the site, the meaning of the carvings, the methods of construction, and the reasons for deliberate burial remain open to interpretation. Each excavation uncovers new insights but also deepens the mystery, reinforcing the sense that Göbekli Tepe represents a window into a cognitive, cultural, and technological world radically different from what was previously imagined for this period. The site challenges the linear progression often assumed in human history, showing that monumental architecture, symbolic thought, and social complexity existed long before agriculture, writing, or urbanization. Ultimately, Göbekli Tepe is a testament to human ingenuity, creativity, and collective ambition. Its massive pillars, intricate carvings, and deliberate layouts reflect a civilization capable of extraordinary achievement in a hunter-gatherer context. The site forces a reconsideration of the relationship between social organization, ritual, and technological innovation, demonstrating that humans have long been capable of organizing labor, transmitting knowledge, and creating monuments of lasting significance. Göbekli Tepe stands as both a marvel of prehistoric engineering and a profound symbol of the cognitive and cultural sophistication of early humanity, challenging us to rethink the origins of civilization and the capabilities of our distant ancestors. In contemplating Göbekli Tepe, one is struck not only by the scale and craftsmanship but also by the vision and coordination required to realize it. The site embodies a synthesis of technical skill, symbolic expression, and social cohesion that continues to inspire and mystify modern researchers. Every carefully carved pillar, every precisely placed stone, and every enigmatic relief speaks to a society capable of monumental achievement without the conventional foundations of agriculture or writing. Göbekli Tepe invites us to explore the origins of human ingenuity, question the assumptions about the emergence of civilization, and marvel at the enduring mysteries of a world long buried beneath the sands of time. Deep in the frozen expanses of Siberia, far from the sun-drenched deserts and fertile river valleys of early civilizations, lies a set of archaeological discoveries that has left historians, paleontologists, and archaeologists struggling to reconcile known human history with startling evidence of advanced prehistoric life. These are the mammoth and megafauna hunting sites of the Upper Paleolithic, where humans not only survived in one of the harshest climates on Earth but apparently did so with a level of ingenuity and technological skill that continues to astound modern researchers. The frozen steppes and tundra of Siberia, stretching across thousands of kilometers, conceal remnants of human ingenuity, tools, bones, and carvings, that suggest the early inhabitants were capable of feats once thought unimaginable for their time. Their ability to hunt enormous Ice Age creatures, organize large-scale communal activities, and create symbolic artifacts challenges conventional narratives of prehistoric human limitations, implying a sophistication that modern archaeology is only beginning to fully appreciate. The scale and nature of hunting undertaken in these regions are staggering. Evidence shows that Paleolithic humans hunted mammoths, woolly rhinoceroses, and other megafauna weighing several tons. Successfully capturing and killing such animals required extraordinary coordination, planning, and technical skill. Archaeologists have unearthed pits lined with sharpened wooden stakes, traps designed to funnel herds, and evidence of organized drives, where groups of humans would herd animals into strategically prepared kill zones. This level of tactical ingenuity demonstrates not only knowledge of animal behavior but also advanced social coordination, communication, and forward planning. Unlike typical small-scale hunting scenarios, these efforts involve dozens, if not hundreds, of participants, suggesting complex social organization and the ability to mobilize large groups around shared goals. Stone and bone tools from these sites further reveal a remarkable technological aptitude. The precision of spear points, harpoons, and knives indicates mastery of flint knapping and an intimate understanding of materials. Some tools exhibit microlithic craftsmanship, where small, standardized components were combined into composite weapons, reflecting not only technical skill but also cognitive sophistication in planning multi-step manufacturing processes. The durability, effectiveness, and efficiency of these tools allowed Paleolithic humans to survive and thrive in conditions that were unforgiving and perilous, revealing a level of adaptive intelligence often underestimated in early hunter-gatherer societies. The architectural and organizational aspects of these hunting sites are equally intriguing. Excavations have revealed evidence of temporary shelters, designated processing areas for carcasses, and even rudimentary storage pits for meat and hides. These sites suggest that Paleolithic humans were not merely opportunistic hunters but engaged in complex logistical planning to maximize the yield of their hunts. Organizing large groups, coordinating the construction of traps, and managing the division of resources required sophisticated social hierarchies, rules, and leadership structures. The implication is that early humans were capable of societal complexity long before the advent of agriculture or permanent settlements, challenging traditional assumptions about the linear progression of social development. Symbolism and art associated with these Siberian sites add another layer of mystery and fascination. Carvings on bones, depictions of animals, and geometric patterns suggest that these early humans were not only concerned with survival but also engaged in symbolic thought and cultural expression. Some carvings appear to represent hunting scenes, possibly serving ritualistic or communicative purposes, while others seem abstract, hinting at early forms of narrative or religious expression. The sophistication of these artistic endeavors suggests a rich cognitive and cultural life, indicating that symbolic thought, artistic sensibility, and perhaps even proto-religious practices were present among hunter-gatherer groups much earlier than previously believed. The sheer endurance required to live in Siberia during the Upper Paleolithic cannot be overstated. Temperatures regularly dropped to extremes well below freezing, and the landscape offered limited vegetation for sustenance. Yet humans not only survived but thrived, adapting their clothing, shelter, and hunting techniques to a harsh and unforgiving environment. Analysis of bone fragments and isotopic data suggests a diet heavily reliant on megafauna, supplemented by seasonal plant resources, small game, and fish. This adaptation reflects a deep ecological knowledge, including the ability to predict seasonal animal movements, understand terrain features, and manage resources sustainably over extended periods. The sophistication and resilience required to inhabit such an environment illustrate a level of adaptive intelligence that challenges modern perceptions of prehistoric humans as simplistic or primitive. One of the most astonishing revelations comes from the discovery of complex social rituals tied to hunting and communal life. Some sites contain evidence of ceremonial arrangements, such as the deliberate placement of animal bones, stone arrangements, and burnt offerings. These ritualistic behaviors suggest that hunting was not solely a matter of survival but intertwined with cultural and symbolic systems. They imply that early humans imbued their interactions with the natural world with meaning, possibly seeking to ensure future hunting success, honor the animals they relied upon, or strengthen social cohesion. This blending of practical, spiritual, and social considerations highlights a complexity of thought that rivals much later civilizations. The use of fire at these Siberian sites also demonstrates advanced knowledge and strategic application. Controlled use of fire for warmth, cooking, and processing animal hides and meat was essential for survival in extreme cold. Hearths are often carefully positioned to maximize heat distribution within shelters or communal areas, while charred remains indicate that fire was used for ritual or symbolic purposes as well. The dual practical and cultural application of fire shows that early humans were capable of abstract thought, planning, and the integration of technology into both survival strategies and social life, underscoring the depth of their cognitive abilities. Archaeological evidence also points to the organization of labor and division of roles within these communities. Different individuals may have specialized as hunters, toolmakers, butchers, or ceremonial leaders, indicating a sophisticated social structure. Such specialization would have allowed for more efficient hunting, resource processing, and cultural expression, enhancing the survival and cohesion of the group. Coordinating these roles across potentially large and mobile groups suggests the existence of leadership systems, rules of conduct, and methods of knowledge transmission, revealing a level of societal organization that is often underestimated for hunter-gatherer populations. The evidence of long-distance interaction further complicates the picture. Artifacts, raw materials, and stylistic motifs suggest that these Siberian groups were not entirely isolated but engaged in trade or cultural exchange over significant distances. Flint sources, pigment materials, and ornamental items indicate that people moved, exchanged, and communicated ideas across the vast Siberian steppe. This connectivity challenges the notion of early humans as insular or parochial, demonstrating a capacity for networked social structures, information sharing, and cultural cohesion across wide geographic areas. Environmental and climatic adaptation was another critical factor in the success of these prehistoric Siberian communities. The Upper Paleolithic coincided with periods of glaciation, fluctuating temperatures, and shifting ecosystems, requiring constant adjustment of hunting strategies, seasonal migration, and shelter construction. Humans in this region developed technologies for clothing, including sewn garments from animal hides, footwear to navigate snow and ice, and layered insulation to retain heat. Their ability to engineer solutions to environmental challenges demonstrates a sophisticated understanding of material science, ergonomics, and long-term survival strategies in extreme conditions, further highlighting their ingenuity and adaptability. The preservation of bones and tools in the permafrost has provided a wealth of information about these early humans, revealing dietary patterns, health, injuries, and cultural practices. Analysis of wear patterns on tools, cut marks on bones, and residues of pigments indicates a high level of skill and intention in daily activities. These details paint a vivid picture of life in a challenging environment, showcasing the cognitive, technical, and cultural sophistication required to thrive in one of the planet's most inhospitable regions. Moreover, genetic studies of populations in Siberia during this period suggest complex interactions, migrations, and adaptations. Early humans in this region were likely part of broader migratory networks that spread technology, cultural practices, and genetic diversity across Eurasia. These findings challenge simplistic notions of isolated groups and instead portray a dynamic, interconnected human landscape, where survival, innovation, and cultural exchange were intimately linked. The implications of these discoveries extend far beyond Siberia, offering insights into the movement, adaptability, and ingenuity of humans during the Upper Paleolithic. The mysteries surrounding these Siberian sites extend to the cognitive and symbolic life of their inhabitants. Carvings, geometric patterns, and possibly early ritualistic arrangements suggest a capacity for abstract thought, planning, and symbolic communication. This evidence points to early forms of culture, narrative, and perhaps even proto-religion, indicating that humans at this time were not solely preoccupied with survival but were capable of reflecting on their environment, expressing meaning, and shaping their world according to cultural frameworks. Ultimately, the Siberian Upper Paleolithic sites are a testament to human resilience, ingenuity, and complexity. The combination of large-scale hunting, advanced tool use, environmental adaptation, social organization, and symbolic expression reveals a civilization capable of extraordinary achievement despite extreme environmental challenges. These communities challenge traditional narratives that underestimate prehistoric human capability, demonstrating that technological innovation, social cohesion, and cultural sophistication were well within the reach of hunter-gatherer societies tens of thousands of years ago. In contemplating these Siberian sites, one is struck not only by the scale of the human endeavor but also by the integration of survival, ingenuity, and cultural expression. The massive mammoth hunts, the precise craftsmanship of tools, the sophisticated environmental adaptations, and the symbolic carvings all speak to a level of intelligence and social organization that is often unacknowledged in discussions of prehistoric humanity. These sites compel us to reconsider assumptions about human potential, revealing that early societies were capable of combining strategy, art, technology, and community in ways that continue to inspire awe. The frozen steppes of Siberia thus serve not only as a repository of bones and artifacts but as a living testament to the remarkable capabilities of humans in the deep past, reminding us that ingenuity, cooperation, and culture have long been defining traits of our species. High on the windswept plains of southern Africa, in a region where the savanna stretches endlessly toward the horizon, lies a site that has left archaeologists both fascinated and confounded for decades, the stone ruins of Great Zimbabwe. Unlike any other site on the continent, Great Zimbabwe represents a peak of architectural achievement, social organization, and cultural sophistication that challenges simplistic narratives of African history. Constructed between the 11th and 15th centuries CE, this sprawling city encompasses massive stone walls, towering enclosures, and intricate passageways built entirely without mortar, yet with such precision and stability that some structures have survived for centuries. The site stands as a testament to human ingenuity and raises profound questions about the technological, social, and cultural capabilities of the civilization that built it, forcing a re-evaluation of the sophistication of pre-colonial African societies. The most immediately striking aspect of Great Zimbabwe is its monumental stonework. The walls, some reaching over 5 meters in height, are composed of carefully shaped granite blocks that interlock seamlessly without the use of mortar. This dry stone construction, which requires precise planning, expert craftsmanship, and intimate knowledge of the properties of stone, allowed the walls to withstand centuries of weathering, earthquakes, and human activity. The Great Enclosure, the largest single structure on the site, encompasses an area of over 7,000 square meters and features towering walls, intricate passageways, and conical towers that showcase a mastery of geometry and engineering. The scale and sophistication of these constructions indicate that the builders possessed not only technical skill but also an advanced understanding of structural forces, spatial organization, and aesthetic design. The construction techniques employed at Great Zimbabwe continue to baffle researchers. Each stone was carefully selected, shaped, and positioned to create stability through weight and friction alone. The builders demonstrated an empirical understanding of load distribution, joint stability, and material properties, achieving architectural feats that rival contemporaneous civilizations in Europe and Asia. The absence of mortar did not compromise the integrity of the structures, instead, it required precise alignment and a keen eye for proportion, highlighting the exceptional craftsmanship and engineering acumen of the builders. Experimental archaeology has shown that replicating such walls with similar precision is a complex and labor-intensive process, underscoring the remarkable ingenuity of the original constructors. Beyond the technical mastery, Great Zimbabwe reflects a sophisticated understanding of urban planning and societal organization. The city is divided into multiple functional areas, including the hill complex, the Great Enclosure, and the valley complex, each serving distinct social, ceremonial, and residential purposes. The layout suggests careful consideration of topography, water access, defensive strategy, and ceremonial prominence. For instance, the hill complex, situated on elevated terrain, likely served as a political or spiritual center, symbolizing authority and control over the surrounding region. The deliberate spatial arrangement indicates an understanding of both practical urban management and symbolic representation, suggesting that the builders conceived of the city as a harmonious integration of function, status, and meaning. Trade and economic sophistication were central to the success of Great Zimbabwe. Archaeological evidence reveals that the city was a hub in a vast trade network, exchanging gold, ivory, and other valuable resources with distant civilizations along the Indian Ocean coast and beyond. Beads, Chinese porcelain, and Arab coins found at the site indicate that Great Zimbabwe was not isolated but deeply integrated into global commerce. This connectivity required not only access to valuable resources but also the organizational capacity to manage production, transport, and trade relations, reflecting complex economic planning and diplomatic engagement. The ability to coordinate such long-distance trade networks underscores the civilization's sophistication and influence in regional and international contexts. Cultural and symbolic expression at Great Zimbabwe is equally compelling. The site is replete with carved soapstone birds, monolithic sculptures, and intricate decorative motifs that convey religious, political, and cultural meanings. The Zimbabwe birds, perched atop pillars and walls, are widely interpreted as symbols of spiritual authority, ancestral veneration, and political legitimacy. These artistic elements reveal a civilization that combined practical engineering with rich symbolic expression, embedding identity, belief, and power into the very fabric of the city. The integration of art, ritual, and architecture highlights a worldview in which aesthetic, spiritual, and functional considerations were inseparable, creating a city that was both utilitarian and profoundly meaningful. The social structure necessary to construct and maintain Great Zimbabwe was highly organized. The scale of the labor required for quarrying, transporting, shaping, and positioning massive stones suggests a centralized authority capable of mobilizing large workforces. Roles likely included stonemasons, artisans, laborers, traders, and ceremonial leaders, coordinated through systems of governance that ensured efficiency, productivity, and social cohesion. The existence of specialized roles, combined with long-term urban planning and monumental construction, indicates a complex hierarchy and societal sophistication that challenges earlier assumptions about pre-colonial African communities. Water management at Great Zimbabwe illustrates the builder's environmental intelligence and foresight. The region experiences seasonal rainfall, and effective water collection and storage were critical for sustaining a dense population. Terraces, channels, and cisterns integrated into the city's design reflect a practical understanding of hydrology, soil conservation, and resource distribution. These systems allowed the city to thrive in a challenging landscape, demonstrating the civilization's ability to manipulate and harmonize with its environment to ensure long-term sustainability. The integration of water management into urban design reveals a sophisticated approach to ecological engineering, resource planning, and communal welfare. The religious and ceremonial dimensions of Great Zimbabwe further highlight its cultural sophistication. The positioning of certain enclosures, the placement of ritual artifacts, and the symbolic carving suggest that religious practice and governance were deeply intertwined. Temples and sacred spaces likely functioned as centers for ritual activity, community cohesion, and the legitimization of authority. Ceremonial structures and art reinforce the idea that social and spiritual life were inseparable, with architecture serving as both a practical and symbolic medium for cultural expression. The blending of sacred and secular considerations underscores the civilization's nuanced understanding of social cohesion, political legitimacy, and cultural identity. The sudden decline of Great Zimbabwe in the 15th century remains a subject of debate and speculation. Shifts in trade routes, environmental degradation, resource depletion, and political instability have all been proposed as contributing factors. Regardless of the cause, the city's abandonment marked the end of an era of remarkable architectural and cultural achievement. Yet the ruins continue to inspire awe, providing a tangible link to a civilization that achieved unprecedented sophistication in stone construction, urban planning, trade, and cultural expression. The endurance of these structures, despite centuries of exposure to natural elements, attests to the skill, foresight, and ingenuity of their builders. The mysteries of Great Zimbabwe also extend to the interpretation of its symbols and artifacts. The Zimbabwe birds, monolithic pillars, and decorative motifs remain subjects of scholarly debate, with theories ranging from ancestral veneration to representations of political power or cosmological understanding. These symbols suggest that the city's creators encoded knowledge, belief, and authority into the architecture itself, creating a multi-layered communication system that conveyed cultural values across generations. The combination of technical achievement and symbolic sophistication reflects a civilization capable of complex thought, abstract reasoning, and cultural continuity. Archaeological investigations continue to uncover new insights into the technological capabilities of Great Zimbabwe. Experimental studies on the construction techniques reveal not only the feasibility of dry stone building but also the ingenuity required to achieve stability, durability, and aesthetic harmony. The precise alignment of walls, the careful interlocking of stones, and the creation of elaborate passageways demonstrate a mastery of spatial reasoning, materials science, and engineering principles. These accomplishments place Great Zimbabwe on par with contemporaneous civilizations elsewhere in the world, challenging outdated notions of technological or cultural inferiority in pre-colonial Africa. The scale and complexity of Great Zimbabwe suggest that it was not merely a city but a symbol of identity, power, and cultural achievement. Its monumental architecture, integrated urban planning, and artistic expression convey a civilization that understood the interplay between politics, economy, religion, and community. The city served as a focal point for governance, ritual, trade, and social cohesion, demonstrating that complex societies can emerge in diverse environmental contexts and thrive through ingenuity, organization, and cultural expression. The enduring legacy of Great Zimbabwe lies in its ability to communicate both the technical skill and the visionary capacities of its creators, reminding us that human achievement is not confined to a particular geography or technological paradigm. Ultimately, Great Zimbabwe stands as a monument to human creativity, resilience, and sophistication. Its massive stone walls, intricately carved symbols, and carefully planned urban layout reflect a civilization that combined engineering, art, ritual, and social organization into a harmonious whole. The site challenges conventional historical narratives, demonstrating that pre-colonial African societies possessed the knowledge, skill, and vision to construct monumental architecture, organize complex societies, and participate in global trade networks. In contemplating Great Zimbabwe, one recognizes not only the extraordinary technical and artistic achievements but also the cultural intelligence, leadership, and social cohesion that enabled its creation. The ruins serve as a testament to human potential, a reminder that ingenuity, creativity, and ambition have always been hallmarks of our species, capable of manifesting in forms that continue to inspire, educate, and mystify generations across the world. Great Zimbabwe's legacy extends beyond its physical remains. The stories, symbols, and structures encapsulate centuries of knowledge, innovation, and cultural expression, offering a window into a civilization that achieved greatness through vision, collaboration, and ingenuity. Each meticulously placed stone, each carved motif, and each thoughtfully designed enclosure speaks to a society that understood both the practical and symbolic dimensions of human life. The city challenges modern observers to reconsider assumptions about technological progress, cultural sophistication, and the diversity of human achievement, reaffirming that the capacity for innovation, artistry, and social complexity is a universal aspect of humanity. In this sense, Great Zimbabwe is more than an archaeological site, it is a timeless testament to the remarkable capabilities of human civilization. In the heart of the Andean Mountains of South America, where jagged peaks pierce the sky and valleys descend into mist-filled chasms, lies Machu Picchu, one of the most extraordinary archaeological sites ever discovered. Perched nearly 2,430 meters above sea level, this Incan citadel embodies a combination of architectural genius, astronomical knowledge, engineering skill, and spiritual symbolism that continues to captivate the world. Built in the 15th century under the reign of Pachacuti, Machu Picchu was abandoned less than a century later during the Spanish conquest, yet it remained hidden from the outside world until its rediscovery by Hiram Bingham in 1911. What makes Machu Picchu so remarkable is not merely its breathtaking location but the complexity, precision, and sophistication of its construction, which raises profound questions about Incan engineering, urban planning, and the extent of knowledge possessed by pre-Columbian civilizations. The first thing that strikes a visitor, or even a viewer of photographs, is the seamless integration of Machu Picchu into the surrounding landscape. Terraces carved into steep mountainsides serve multiple purposes. They prevent erosion, create microclimates for agriculture, and display an aesthetic harmony with the natural environment. The Incas demonstrated a profound understanding of geology, hydrology, and agriculture, selecting the location not just for its defensibility but for its strategic advantages in sustaining life. The terraces are supported by retaining walls of precisely cut stone, fitted together without mortar, showcasing the Incas' mastery of dry stone masonry, or ashlar construction, which has allowed these structures to endure centuries of seismic activity, heavy rainfall, and environmental stress. The precision of stonework at Machu Picchu is unparalleled. The granite blocks used in constructing temples, palaces, and residential complexes were cut to fit together so perfectly that even a knife blade cannot slip between them. This technique, called ashlar masonry, allowed buildings to withstand earthquakes common in the region without collapsing, as the stones move slightly under seismic stress and then settle back into place. Achieving this level of precision required not only technical skill but also a sophisticated understanding of physics, structural forces, and materials. It also reflects an organized workforce capable of large-scale coordination and meticulous execution, emphasizing the sophistication of Incan society. Machu Picchu's urban layout reveals an advanced understanding of urban planning, space utilization, and social organization. The city is divided into distinct areas for religious, residential, and agricultural purposes, with temples, plazas, and royal residences strategically positioned to reflect both functional and symbolic priorities. The Temple of the Sun, for example, is carefully aligned with solstices, allowing sunlight to illuminate specific niches on important dates. This demonstrates the Incas' astronomical knowledge, which they integrated seamlessly into their architecture. Such precision suggests that urban design was not merely practical but deeply symbolic, linking the physical layout of the city to cosmology, religious practice, and political authority. Water management at Machu Picchu represents another pinnacle of engineering ingenuity. The Incas designed a sophisticated network of channels, fountains, and drainage systems that harnessed mountain springs to supply clean water throughout the city while preventing erosion and landslides. Rainwater was carefully diverted through stone channels into terraces and agricultural plots, ensuring soil stability and water availability during dry periods. The ability to manipulate the natural flow of water in such a challenging environment required advanced hydrological knowledge, meticulous planning, and precise construction, reflecting a civilization capable of harmonizing environmental understanding with urban and agricultural needs. The astronomical knowledge embedded in Machu Picchu is equally remarkable. The Intihuatana, or hitching post of the sun, is a carved stone that served as an astronomical observatory, ritual site, and calendar marker. Its position and alignment allowed the Incas to track solstices, equinoxes, and other celestial events, critical for agricultural planning and ceremonial practices. This integration of astronomy into city design reflects a society where observation of the heavens was not merely intellectual but practical and spiritual, guiding daily life, agricultural cycles, and religious rituals. The interplay between architecture, astronomy, and ritual highlights the Incas' holistic approach to knowledge, where science, culture, and spirituality were inseparable. The construction methods used to transport and position massive stones on such steep, rugged terrain continue to intrigue researchers. Many stones weigh several tons and had to be quarried from distant locations, transported across mountains, and lifted into precise positions without modern machinery. Theories suggest the use of inclined planes, levers, rollers, and human labor coordinated through sophisticated management systems, yet the exact methods remain partially speculative. The logistics of moving such enormous stones over rugged terrain and placing them with such precision underscore the organizational capacity, technical understanding, and innovative problem-solving skills of the Incan builders. Machu Picchu's integration of spiritual symbolism into its architecture is particularly striking. Temples, shrines, and ceremonial plazas were constructed in alignment with sacred mountains, rivers, and celestial markers, reflecting the Incan belief in the interconnectedness of nature, cosmos, and human society. The city itself may have been designed as a microcosm of the Incan world, embodying cosmological principles and spiritual ideals in stone and landscape. The combination of religious symbolism, urban planning, and environmental engineering suggests a civilization that perceived its environment as an active participant in spiritual and social life, rather than merely a backdrop for human activity. The agricultural terraces at Machu Picchu were not only functional but also experimental. Researchers have found evidence that the Incas tested soil composition, microclimates, and crop varieties on these terraces, essentially conducting controlled agricultural experiments long before modern scientific methods were formalized. The terraces allowed the cultivation of a wide range of crops, including maize, potatoes, and quinoa, across different altitudes and exposure levels. This experimental approach indicates an empirical understanding of agronomy, climate, and ecosystem management, demonstrating that the Incas combined observation, experimentation, and adaptation to sustain a thriving population in challenging mountainous terrain. Social organization at Machu Picchu was highly sophisticated. The division of labor, coordination of construction projects, management of water and agriculture, and organization of ceremonial life all indicate a centralized authority capable of directing complex tasks and maintaining social cohesion. The city likely housed elite administrators, priests, artisans, farmers, and support staff, each contributing specialized skills to the functioning of the community. The ability to sustain such a complex society in a remote, high-altitude environment speaks to the Incas' mastery of administration, logistics, and governance, reflecting a civilization with an intricate balance of political, economic, and spiritual structures. Trade and resource management further demonstrate Machu Picchu's sophistication. Though geographically isolated, the city was connected to wider Incan networks that supplied tools, luxury goods, and ceremonial items. The exchange of resources facilitated not only economic stability but also cultural cohesion, ensuring that Machu Picchu remained integrated into the broader Incan state. Evidence of finely crafted stone tools, pottery, textiles, and ceremonial artifacts indicates that the city was a hub of both material production and cultural activity, reflecting a complex interplay between economy, craft, and ritual life. Machu Picchu's sudden abandonment around the time of the Spanish conquest adds another layer of intrigue. Unlike many Incan cities, it was spared from large-scale looting and destruction, perhaps due to its remote location, leaving a nearly intact urban and ceremonial complex. This preservation provides an unprecedented window into Incan life, technology, and spirituality, allowing researchers to study the city as a cohesive entity rather than as a fragmented ruin. The reasons for abandonment remain debated, with theories ranging from strategic relocation, disease, political upheaval, or the disruption of trade networks. Regardless, the site's near-pristine condition continues to challenge researchers and captivate the imagination of the world. Archaeological research at Machu Picchu also reveals the Incas' sophisticated understanding of materials. The granite used in construction was quarried with stone and bronze tools, shaped to fit with remarkable precision, and arranged to maximize stability and durability. Stones were often fitted with slight inward tilts and interlocking joints to resist seismic activity, a testament to the Incas' empirical knowledge of structural dynamics. This attention to detail, combined with the aesthetic and symbolic elements of construction, illustrates a civilization that merged technical mastery with cultural expression in a seamless and enduring manner. Machu Picchu also raises questions about the extent of knowledge transfer and communication across the Incan Empire. The coordination required to quarry stones, transport them, and construct buildings in a challenging mountainous environment suggests organized training systems, shared construction knowledge, and effective leadership structures. The sophistication of water management, urban planning, and architectural design implies that knowledge was systematically preserved, transmitted, and refined across generations, highlighting a civilization capable of both innovation and continuity. The spiritual and symbolic significance of Machu Picchu cannot be overstated. The alignment of temples, plazas, and terraces with sacred mountains, celestial events, and water sources indicates a cosmological and ritualistic design philosophy that permeated all aspects of city planning. The Intihuatana stone, ceremonial plazas, and sun temples reflect a civilization in which the natural and spiritual worlds were intricately connected, guiding not only practical life but also cultural and religious practices. This integration of science, art, and spirituality challenges modern distinctions between technology and belief, demonstrating that the Incas perceived knowledge as a holistic and interconnected system. Ultimately, Machu Picchu stands as a testament to human ingenuity, adaptability, and cultural sophistication. Its precise stonework, intricate urban planning, advanced water management, and astronomical alignments reveal a civilization capable of extraordinary achievement under challenging environmental conditions. The city exemplifies a holistic integration of engineering, agriculture, astronomy, social organization, and spiritual symbolism, offering insights into the cognitive, cultural, and technical prowess of the Inca civilization. In reflecting on Machu Picchu, one is struck not only by its monumental scale and beauty but by the profound intelligence, creativity, and coordination required to conceive and execute it. Every terrace, temple, and carefully fitted stone speaks to a society that mastered both practical and symbolic dimensions of life. The citadel challenges modern assumptions about pre-Columbian engineering and architecture, demonstrating that the Incas achieved a level of sophistication that continues to inspire awe. Machu Picchu is more than an archaeological site, it is a living testament to the ingenuity, vision, and enduring legacy of one of humanity's greatest civilizations, offering an unparalleled glimpse into a world where human knowledge, creativity, and spirituality were inseparably intertwined. Along the arid plateaus of the Middle East, where the sun scorches the land and wind-carved rocks dominate the landscape, the ancient city of Petra rises from the desert like a mirage, a testament to human ingenuity, architectural mastery, and cultural sophistication. Carved directly into rose-colored cliffs, this city served as the capital of the Nabatean kingdom from around the 4th century BCE until its decline in the 2nd century CE. Petra's existence and preservation defy conventional assumptions about what an ancient desert civilization could achieve. The Nabateans, often described as nomadic traders, managed to create a thriving urban center, complete with elaborate water management systems, monumental facades, intricate tombs, and bustling marketplaces. The city's hidden location and the precision of its construction have left modern scholars both awed and perplexed, raising questions about the engineering, social organization, and cultural sophistication of a people whose accomplishments rivaled contemporary civilizations such as Rome or Alexandria. The first impression upon entering Petra is the sheer scale and intricacy of its rock-cut architecture. The Siq, a narrow winding canyon that serves as the main entrance, opens dramatically to reveal the treasury, or Al-Khazna, one of the most iconic structures in the ancient world. The facade rises nearly 40 meters high, carved with Corinthian columns, intricate friezes, and sculptural details that suggest a profound understanding of both aesthetic principles and structural engineering. What is particularly remarkable is that these monumental structures were not constructed with traditional building materials or techniques. Instead, the Nabateans sculpted them directly from solid rock, carefully planning proportions, depth, and alignment to achieve both grandeur and stability. This precision implies a sophisticated knowledge of geometry, load distribution, and architectural aesthetics, all achieved without the aid of modern tools or scaffolding. Petra's water management system is among its most extraordinary features, reflecting the Nabateans' ingenuity and intimate knowledge of their harsh environment. Situated in an arid desert with sporadic rainfall, the city required a reliable water supply to sustain its population, agriculture, and livestock. Engineers carved channels, dams, cisterns, and reservoirs into the cliffs and valleys to capture and store rainwater, redirect seasonal floods, and provide drinking water throughout the year. Some channels were designed to filter debris, while others used gravity to distribute water to public fountains, baths, and residential areas. This intricate system allowed Petra to flourish in a desert environment where many settlements would have failed, demonstrating a mastery of hydraulics, environmental adaptation, and urban planning that continues to astonish modern engineers and archaeologists. The Nabateans were also highly skilled in urban planning and spatial organization. Petra is divided into distinct areas, including residential quarters, religious complexes, marketplaces, and burial sites, each carefully positioned to balance functionality, social hierarchy, and symbolic meaning. Streets, stairways, and terraces were constructed to navigate the rugged terrain while maximizing accessibility and visual impact. The alignment of temples, tombs, and public spaces reflects an understanding of sightlines, spatial hierarchy, and the human experience of movement through urban space. This deliberate planning indicates that the Nabateans approached city building not merely as a practical endeavor but as an integrated exercise in engineering, art, and social organization. The tombs of Petra reveal both the technical and symbolic sophistication of the Nabateans. Numerous rock-cut facades, ranging from modest niches to monumental cliff-face palaces, served as elaborate burial sites for elite individuals. These tombs incorporate Hellenistic, Roman, and local architectural influences, blending diverse stylistic elements into a uniquely Nabatean aesthetic. The scale, detail, and precision of the carving suggest that tomb construction was not only an expression of wealth and status but also a reflection of spiritual beliefs, cosmology, and an understanding of architectural permanence. In particular, the combination of decorative intricacy and structural stability indicates that Nabatean artisans possessed advanced knowledge of material properties, spatial design, and aesthetic principles. Trade and economic prowess were central to Petra's development and prosperity. The Nabateans controlled key trade routes that connected Arabia, Egypt, Syria, and the Mediterranean, facilitating the exchange of spices, incense, precious metals, textiles, and other luxury goods. This strategic position allowed Petra to become a hub of commerce, wealth, and cultural exchange. The city's prosperity enabled investments in monumental architecture, water infrastructure, and public amenities, reflecting a civilization capable of mobilizing resources, labor, and expertise on a grand scale. The integration of economic strategy with urban planning, architecture, and cultural expression highlights the sophistication of Nabatean society. Religious and ceremonial life in Petra was closely intertwined with architecture and landscape. Temples, shrines, and sacred spaces were carved into cliffs and positioned to align with natural features, such as mountain peaks, valleys, and water sources. Some temples display complex iconography that blends local deities, Greco-Roman influences, and Nabatean cosmology, suggesting a rich and syncretic spiritual life. Ritual practices may have included offerings, processions, and astronomical observations, reflecting a society in which religion, art, and daily life were deeply interconnected. The careful integration of sacred architecture into the natural and urban landscape demonstrates a sophisticated worldview in which spiritual, practical, and aesthetic considerations were inseparable. Petra's preservation is partly due to its hidden and defensible location. Situated in a rugged canyon network, the city was naturally protected from invasion, allowing it to flourish relatively undisturbed for centuries. The strategic use of the landscape demonstrates not only tactical intelligence but also an intimate understanding of geography and defense. The city's planners exploited natural features such as cliffs, narrow passes, and elevated plateaus to control access, enhance security, and create dramatic visual experiences for residents and visitors alike. This interplay between natural environment and human design underscores the Nabateans' ability to merge practical engineering with aesthetic and strategic considerations. The transportation and carving of massive stone blocks into intricate facades required extraordinary technical skill and coordination. Artisans and laborers carved directly into sandstone cliffs, ensuring structural stability while achieving highly detailed decorative motifs. The complexity of these carvings, combined with the precision of structural alignment, suggests the use of advanced measuring techniques, planning tools, and skilled craftsmanship. Furthermore, the ability to coordinate large labor forces over extended periods, while maintaining quality and consistency, indicates a high degree of social organization and managerial sophistication. Petra's role as a cultural and intellectual center further illustrates the breadth of Nabatean sophistication. The city was not only a commercial hub but also a place where architectural innovation, artistic expression, and knowledge of astronomy, hydraulics, and urban planning coalesced. Scholars have noted that certain structures may have served as observatories, aligning with solar and lunar cycles, which would have informed agricultural, ceremonial, and temporal planning. This integration of scientific observation into everyday life highlights the Nabateans' capacity for empirical thinking, symbolic interpretation, and the application of knowledge to practical challenges. Despite centuries of study, many aspects of Petra remain shrouded in mystery. The full extent of its population, the precise methods used for construction, and the details of daily life are still being uncovered through ongoing excavations and research. Some scholars speculate about lost technologies, sophisticated surveying methods, and symbolic systems embedded in architecture that modern investigators are only beginning to comprehend. The combination of monumental construction, hidden city planning, and advanced water management ensures that Petra remains a site of continuous discovery, drawing scholars and explorers eager to unlock its secrets. Petra also raises intriguing questions about cultural exchange and influence. Architectural motifs, construction techniques, and artistic styles reveal a blend of local traditions with Hellenistic, Roman, and Arabian influences, suggesting that the Nabateans were active participants in regional and international cultural networks. This synthesis of styles indicates not only openness to external ideas but also the ability to adapt, integrate, and innovate, creating a unique cultural and architectural identity that has stood the test of time. The city exemplifies how civilizations can achieve remarkable sophistication by combining indigenous knowledge with selective adoption of external innovations. Social hierarchy and governance are implicit in Petra's urban design. Monumental tombs, grand facades, and ceremonial spaces suggest the presence of elite classes who commanded labor, resources, and religious authority. The coordination required for such a complex city implies administrative structures capable of managing trade, labor allocation, construction projects, and resource distribution. This level of societal organization reflects a civilization that balanced economic, political, and religious functions in a coherent and integrated system, allowing it to flourish in a challenging desert environment. The legacy of Petra extends beyond its monumental architecture. The city embodies lessons in environmental adaptation, urban planning, hydraulic engineering, and cultural expression that continue to inspire modern scholars, architects, and engineers. Its integration of natural landscape with human ingenuity, aesthetic design, and functional utility demonstrates that ancient civilizations were capable of sophisticated problem-solving, strategic planning, and artistic expression even in harsh environments. Petra is not only a historical treasure but a testament to the universality of human creativity, adaptability, and ambition. Ultimately, Petra stands as one of the most remarkable achievements of the ancient world. Its monumental facades, intricate water systems, strategic urban planning, and rich cultural symbolism reveal a civilization that combined technical mastery, aesthetic sensibility, and social organization in ways that continue to challenge modern understanding. The Nabateans' ability to thrive in a desert environment, sustain a thriving urban center, and create enduring monuments illustrates human ingenuity at its highest level. In contemplating Petra, one cannot help but marvel at the intelligence, vision, and artistry required to carve a city from solid rock, manage scarce resources, and construct a society that harmonized commerce, spirituality, and governance. The city remains a timeless testament to the capacity of human civilizations to overcome environmental challenges, achieve architectural brilliance, and leave a legacy that inspires wonder millennia after its creation. Petra, with its hidden canyons, monumental tombs, and sophisticated infrastructure, forces us to reconsider assumptions about the capabilities of ancient desert civilizations. Far from being simple traders or nomads, the Nabateans demonstrated an extraordinary ability to manipulate their environment, organize complex societies, and create a city that was both functional and profoundly symbolic. Every carved facade, every channel, and every ceremonial space reflects careful planning, advanced technical knowledge, and an appreciation for beauty and meaning. Petra is thus more than an archaeological site, it is a living record of human ingenuity, social complexity, and the enduring power of creativity in the face of environmental and logistical challenges. Hidden deep within the dense jungles of Central America, the ancient city of Tikal rises as a testament to the grandeur, complexity, and sophistication of the Maya civilization. Flourishing between approximately 200 and 900 CE, Tikal was one of the most powerful and influential city-states in the Maya lowlands, serving as a political, religious, and economic hub that governed vast territories and commanded immense resources. The scale of Tikal's architecture, the precision of its astronomical knowledge, the complexity of its societal organization, and the sophistication of its art and inscriptions reveal a civilization capable of achievements that continue to astonish modern scholars. Unlike more isolated ancient societies, the Maya at Tikal developed a fully integrated culture, combining monumental construction, mathematical innovation, complex writing systems, and intricate ceremonial practices to create a city that functioned as both a living urban center and a symbolic expression of cosmic order. The first aspect that immediately impresses any visitor or researcher is the monumental scale of Tikal's architecture. Rising above the rainforest canopy are towering pyramids, such as Temple I, Temple II, and Temple IV, which dominate the skyline and serve as visual statements of political and spiritual authority. Temple IV, the tallest structure at Tikal, soars to nearly 70 meters, constructed without modern machinery yet exhibiting remarkable precision in alignment, stability, and proportion. These pyramids were not simply utilitarian structures but carefully designed as sacred spaces, connecting the earthly realm with the divine. Their orientation often aligns with celestial events, such as solstices or equinoxes, reflecting an advanced understanding of astronomy integrated directly into urban design. The very act of building such immense structures in the middle of a dense jungle, using only human labor and simple tools, demonstrates not only technical ingenuity but also an extraordinary capacity for organization, resource management, and long-term planning. Underlying Tikal's architectural brilliance was a sophisticated understanding of engineering and construction techniques. The Maya used limestone quarried locally to construct stepped pyramids, palaces, and temples. They employed techniques such as corbelled arches and carefully fitted stone blocks to create durable and stable structures capable of withstanding tropical storms and the test of centuries. The construction of these monumental edifices required not only physical labor but also precise surveying, planning, and coordination, indicating a society with highly developed knowledge of geometry, structural forces, and project management. Moreover, the spatial arrangement of the city, with its plazas, causeways, and ceremonial platforms, reflects deliberate urban planning designed to facilitate both civic and religious life, manage population flow, and express social hierarchy visually and symbolically. Water management was another remarkable aspect of Tikal's sophistication. Situated in a region without reliable surface water sources, the Maya constructed an intricate system of reservoirs, canals, and cisterns to capture and store rainwater throughout the year. This system not only provided drinking water for a substantial population but also supported agriculture, ceremonial practices, and daily life. The reservoirs were engineered to minimize sedimentation, maximize storage capacity, and integrate seamlessly into the city's layout. The ability to design and maintain such hydraulic systems in a challenging tropical environment demonstrates advanced engineering knowledge and environmental adaptation, reflecting a civilization capable of harmonizing urban planning with natural resource management. The societal organization of Tikal further emphasizes the complexity of Maya civilization. Archaeological evidence indicates a highly stratified society, with an elite ruling class overseeing religious, political, and economic functions, while artisans, farmers, and laborers supported the city's daily operations. Monumental inscriptions and stelae record the deeds of kings, military campaigns, and dynastic lineages, demonstrating a sophisticated system of record-keeping and historical consciousness. These inscriptions not only served propagandistic and ceremonial purposes but also functioned as tools for social cohesion, legitimizing the authority of rulers and embedding the history of the city into the collective memory of its inhabitants. The ability to coordinate large-scale construction projects, manage agricultural production, and maintain ceremonial cycles points to a high degree of administrative sophistication and centralized governance. Astronomical knowledge was central to the planning, construction, and ceremonial life of Tikal. The Maya meticulously observed the movements of the sun, moon, planets, and stars, integrating this information into architectural alignments, agricultural calendars, and ritual schedules. Certain pyramids and temples are oriented so that sunlight illuminates specific structures during solstices or equinoxes, while inscriptions record the timing of celestial events with remarkable precision. This integration of astronomy into urban and ceremonial design reflects not only intellectual achievement but also practical applications, such as guiding planting cycles, organizing religious festivals, and structuring civic life. The Maya conception of time and cosmology, embodied in their architecture and inscriptions, demonstrates a civilization deeply attuned to the rhythms of the natural world and capable of translating complex observational knowledge into practical and symbolic forms. Art and symbolism were central to Tikal's identity and cultural expression. The city is adorned with stelae, altars, and carvings that depict rulers, deities, mythological narratives, and ceremonial events. These works of art reveal a sophisticated aesthetic sensibility, technical skill, and an understanding of iconography as a medium for communication and social control. The carvings served multiple purposes, commemorating significant events, legitimizing rulers, reinforcing religious beliefs, and educating the populace about the social and cosmic order. Through these artistic expressions, the Maya of Tikal created a visual language that conveyed both practical information and profound cultural meaning, integrating art, politics, and spirituality into the very fabric of the city. Trade and economic integration played a crucial role in Tikal's development and influence. Archaeological evidence suggests extensive trade networks connecting Tikal with distant regions across Mesoamerica, exchanging obsidian, jade, ceramics, salt, cacao, and other valuable commodities. These networks facilitated the flow of resources, knowledge, and cultural practices, allowing Tikal to maintain its political and economic dominance while fostering cultural innovation and cosmopolitanism. The management of trade, resource allocation, and labor demonstrates a sophisticated understanding of economics and logistics, highlighting the ability of the Maya to create and sustain complex urban centers in challenging environments. Religious practice permeated all aspects of life at Tikal, influencing architecture, social hierarchy, governance, and cultural identity. Temples, plazas, and ceremonial platforms were designed to accommodate large gatherings, rituals, and sacrifices, while the city's layout symbolically reflected the cosmic order. Kings were often regarded as divine intermediaries, their authority legitimized through ritual, architectural grandeur, and symbolic acts. This integration of religion and governance ensured social cohesion and reinforced the city's cultural identity, illustrating the profound interdependence of political and spiritual life in Maya society. The deliberate alignment of structures with celestial phenomena underscores the Maya's holistic worldview, where cosmology, ritual, and social order were inseparable. The decline of Tikal around the 9th century CE remains a subject of intense research and debate. Environmental stressors such as prolonged droughts, deforestation, and soil depletion may have contributed, while social factors, including warfare, political fragmentation, and economic disruption, likely compounded the challenges. Despite its eventual decline, Tikal's legacy endures through its monumental architecture, sophisticated urban planning, and the enduring intellectual and artistic achievements of its civilization. The city provides a remarkable case study of human ingenuity, resilience, and the capacity to create complex societies in challenging environments. The architectural achievements of Tikal, particularly its pyramids and palaces, reveal a deep understanding of both aesthetic principles and structural integrity. Stepped pyramids served multiple functions, including religious ceremonies, administrative activities, and social gatherings, reflecting a multifunctional approach to design. The precision of stone placement, the orientation of temples, and the integration of stairways, platforms, and plazas demonstrate careful planning and attention to both form and function. The Maya employed both empirical knowledge and ceremonial considerations in construction, creating spaces that were visually striking, structurally stable, and symbolically potent. Tikal also showcases advanced knowledge of agriculture and ecological management. The Maya employed terracing, raised fields, and forest garden systems to maximize crop yield and maintain soil fertility. These techniques allowed the city to support a substantial population despite the limitations of the tropical rainforest environment. The integration of agricultural innovation with urban planning and water management demonstrates a holistic approach to sustainability, revealing a civilization capable of adapting intelligently to complex ecological challenges. The ability to combine agricultural productivity with monumental construction, ceremonial life, and trade networks underscores the sophistication and resilience of Maya society. The city's inscriptions and stelae provide a detailed record of political events, dynastic succession, and ceremonial cycles, reflecting an advanced system of literacy, historical consciousness, and cultural codification. These records were not merely descriptive but also prescriptive, reinforcing social hierarchies, legitimizing rulers, and guiding civic and religious activities. The complexity and consistency of the written record indicate that Tikal's administrators and scribes possessed not only technical literacy but also a nuanced understanding of the interplay between information, power, and social cohesion. Writing served as both a tool for governance and a medium for cultural continuity, embedding knowledge, ritual, and authority within the city's material fabric. The interconnection of Tikal with regional networks further illustrates the city's influence and sophistication. Trade, diplomacy, and cultural exchange facilitated the flow of goods, ideas, and technologies across vast distances, allowing Tikal to maintain political dominance and cultural prominence. Artifacts such as ceramics, jade, and obsidian from distant regions attest to these networks, highlighting the city's role as both a hub and a conduit of Mesoamerican civilization. The ability to sustain such networks required organizational intelligence, strategic planning, and social negotiation, revealing the depth of political, economic, and cultural complexity achieved by the Maya. Ultimately, Tikal represents a pinnacle of human achievement in architecture, astronomy, urban planning, agriculture, governance, and cultural expression. Its monumental pyramids, intricate plazas, sophisticated water management systems, and rich artistic heritage testify to a civilization that understood how to harmonize technical mastery with social organization, spiritual belief, and environmental adaptation. The city's enduring legacy challenges assumptions about the capabilities of ancient societies, demonstrating that human ingenuity, coordination, and creativity can flourish even in the most challenging environments. In contemplating Tikal, one is struck not only by the physical grandeur of its pyramids and plazas but also by the intellectual, spiritual, and organizational capacities required to create and sustain such a civilization. Every stone, every inscription, and every carefully aligned temple speaks to a society that combined empirical observation, artistic sensibility, spiritual insight, and political acumen into a cohesive and enduring urban complex. Tikal is more than an archaeological site, it is a living testament to the Maya's capacity for innovation, adaptation, and cultural expression, offering a profound glimpse into a civilization that continues to inspire awe, study, and admiration nearly a millennium after its peak. In the remote deserts of Peru, where arid sands stretch endlessly under a blazing sun, lies a series of enormous geoglyphs etched into the earth that continue to baffle researchers and captivate imaginations worldwide, the Nazca Lines. Spanning nearly 500 square kilometers of the Nazca Desert, these intricate designs include depictions of animals, plants, geometric shapes, and even humanoid figures, some extending hundreds of meters in length. Created between 500 BCE and 500 CE by the Nazca culture, these enormous formations are so precise and enormous that they are best appreciated from the air, a fact that raises profound questions about the methods, purpose, and cultural significance behind their creation. The sheer scale, precision, and endurance of the Nazca Lines reveal a civilization with remarkable technical understanding, organizational skill, and symbolic sophistication, challenging conventional assumptions about the capabilities of pre-Columbian societies. The first striking feature of the Nazca Lines is their scale and geometric precision. Simple lines stretch for kilometers, while complex figures, depicting monkeys, hummingbirds, spiders, and other creatures, display astonishing symmetry, proportion, and detail. Creating these designs required advanced planning, careful measurement, and a systematic method of scaling that allowed small ground-level sketches to be expanded into enormous, coherent figures across uneven desert terrain. Researchers speculate that the Nazca people employed basic surveying techniques, such as ropes, stakes, and sighting lines, to maintain correct proportions and alignment, indicating a sophisticated understanding of geometry and spatial organization long before modern tools existed. The ability to produce both abstract geometric forms and highly naturalistic representation suggests a combination of artistic skill, mathematical understanding, and precise execution that continues to challenge archaeologists. The methods used to construct the lines are deceptively simple yet highly effective. The designs were created by removing the top layer of reddish-brown iron oxide-coated pebbles to reveal the lighter-colored sand beneath. This contrast created visible patterns that have endured for over a millennium, largely due to the region's hyperarid climate and minimal wind activity. Despite the apparent simplicity, the sheer precision and scale of the designs indicate meticulous planning and careful execution. Maintaining straight lines, consistent widths, and accurate proportions over hundreds of meters required coordinated labor and advanced knowledge of surveying principles, revealing that the Nazca were capable of highly organized collective work. One of the most intriguing aspects of the Nazca lines is their potential purpose, which has been the subject of scholarly debate for decades. Theories range from astronomical calendars and water-related rituals to religious and ceremonial pathways. Some researchers propose that certain lines and figures align with celestial events, such as solstices or the rising and setting of particular stars, suggesting that the Nazca may have used the geoglyphs as a form of astronomical observation or calendrical system. Other scholars argue that the lines were linked to water, a precious resource in the desert, serving as ceremonial channels, markers, or offerings intended to invoke rainfall and agricultural fertility. These interpretations highlight the complex interplay between environment, culture, and spirituality, indicating that the Nazca lines were not mere artistic expressions but deeply integrated into the social, religious, and ecological life of the community. The geometric and symbolic sophistication of the Nazca lines reflects an advanced understanding of abstraction, pattern recognition, and communication through scale. Some lines converge to form intricate networks, connecting ceremonial sites, water sources, and other cultural landmarks, suggesting that the geoglyphs served as a form of mapping or symbolic representation of the surrounding landscape. The combination of straight lines, trapezoids, spirals, and animal figures indicates that the creators had a comprehensive system for encoding meaning into the desert floor, blending artistry with functional and symbolic considerations. This capacity for large-scale abstraction and symbolic representation underscores the cognitive sophistication and cultural complexity of the Nazca civilization. Labor organization required for the creation of the Nazca lines further highlights the societal sophistication necessary to undertake such monumental projects. Constructing the figures and lines would have required coordinated teams, division of labor, and possibly hierarchical oversight to ensure accuracy and consistency across vast distances. Such projects imply not only social cohesion and authority structures but also the transmission of specialized knowledge regarding geometry, surveying, and ceremonial protocol. The ability to mobilize and sustain these efforts reflects a society capable of long-term planning, disciplined execution, and collaborative achievement on an impressive scale. The environmental adaptation evident in the Nazca lines also illustrates the ingenuity of the civilization. The hyperarid climate preserved the geoglyphs for centuries, but the Nazca engineers leveraged subtle topographical features, slopes, and natural contours to enhance the visibility and impact of the lines. This understanding of the desert environment, combined with practical engineering skills, allowed them to manipulate the landscape in ways that maximized aesthetic, symbolic, and possibly functional effects. The deliberate choice of location, coupled with precise execution, suggests that the Nazca had a sophisticated awareness of their environment and the ability to manipulate it for both cultural and practical purposes. Religious and ceremonial life appears to have been deeply intertwined with the creation of the lines. Many geoglyphs depict animals associated with fertility, water, and cosmology, implying that the figures were intended as offerings, symbolic invocations, or ritual markers. Large ceremonial gatherings may have been conducted along the lines, with the process of creation itself serving as a form of communal religious expression. The monumental scale of the figures would have reinforced social cohesion, collective identity, and the cultural significance of shared belief systems. By embedding ritual, art, and environmental knowledge into the landscape, the Nazca created a cultural expression that was both enduring and integrally tied to their worldview. Astronomical alignments among certain lines and figures provide additional insight into the intellectual sophistication of the Nazca. Some researchers suggest that the geoglyphs served as markers for the sun, moon, and stars, aiding in agricultural planning and ceremonial timing. While interpretations remain debated, the possibility that the lines functioned as both ritualistic and practical tools reflects a culture in which observation of the heavens was closely linked to survival, ritual, and societal organization. This integration of empirical observation, symbolic expression, and practical utility highlights the holistic nature of Nazca knowledge systems. The durability and preservation of the Nazca lines are equally remarkable. The dry climate, minimal wind erosion, and careful construction methods have allowed many figures to survive for over 15 centuries, maintaining clarity and impact. This longevity attests to the effectiveness of their techniques, the foresight of the builders, and the enduring power of human ingenuity. The fact that such enormous and precise designs could be created and preserved without modern tools or machinery emphasizes the exceptional skill, planning, and environmental understanding possessed by the Nazca civilization. Cultural transmission and continuity are evident in the repeated motifs and standardized proportions of the geoglyphs. Certain animal forms recur across multiple figures, suggesting the existence of a shared symbolic lexicon or codified visual language. This consistency indicates that knowledge of design, measurement, and symbolic meaning was transmitted across generations, reflecting sophisticated educational and ceremonial structures. The integration of symbolic continuity with technical precision exemplifies the fusion of cognitive, artistic, and social intelligence characteristic of the Nazca people. Trade and interaction may have influenced the geoglyphs as well. While the lines themselves were likely a localized cultural phenomenon, the presence of materials such as ceramics, textiles, and obsidian from distant regions suggests that the Nazca were part of broader trade networks. Exposure to external influences could have inspired stylistic innovations, reinforced ritual practices, and contributed to the social complexity necessary to undertake such monumental projects. The combination of local innovation and external interaction underscores the dynamic and interconnected nature of the civilization, highlighting its capacity for both adaptation and creative expression. The debate over the precise purpose of the Nazca lines continues to intrigue archaeologists and historians. While astronomical, religious, and water-related explanations dominate, some researchers propose additional possibilities, including initiation pathways, territorial markers, or symbolic representations of cosmological myths. Regardless of their exact function, the lines reflect a deliberate and highly sophisticated integration of art, ritual, and environmental knowledge, demonstrating that the Nazca were capable of conceptualizing and executing projects on a scale and precision that challenges modern assumptions about pre-Columbian societies. The interplay of scale, precision, and symbolic meaning in the Nazca lines illustrates a society that understood the power of human labor, collective organization, and visual communication. Creating figures visible only from elevated vantage points required trust in shared knowledge, careful planning, and precise coordination among artisans and laborers. The resulting geoglyphs communicate not only artistic expression but also cultural identity, cosmological understanding, and social cohesion, embodying the intellectual, spiritual, and practical achievements of the Nazca civilization. Ultimately, the Nazca lines stand as a testament to human ingenuity, cultural sophistication, and environmental adaptation. Their monumental scale, geometric precision, enduring preservation, and symbolic complexity reflect a civilization that combined technical skill, artistic vision, and ritual significance in a manner that continues to inspire awe. The geoglyphs challenge conventional assumptions about ancient societies, revealing a people capable of sophisticated planning, collective execution, and the integration of empirical, spiritual, and symbolic knowledge. The enduring mystery and beauty of the Nazca Lines make them not only a cultural treasure of Peru but a timeless monument to the creativity, intelligence, and ambition of humanity. In contemplating the Nazca Lines, one cannot help but marvel at the level of intellectual, artistic, and social sophistication required to conceive and execute such vast and precise designs in one of the most unforgiving landscapes on Earth. The lines demonstrate that even in a desert environment, a civilization could achieve extraordinary feats of planning, coordination, and symbolic expression. Each figure, each geometric shape, and each carefully measured line embodies the combined vision, skill, and cultural depth of the Nazca people, reminding us that human ingenuity, collaboration, and creativity have long been capable of producing wonders that endure for millennia. The Nazca Lines are not merely archaeological relics, they are living evidence of the power of human imagination and the capacity of ancient societies to shape both their physical and cultural worlds in ways that continue to captivate and challenge modern understanding. In the windswept deserts of southern Iraq, near the confluence of the Tigris and Euphrates rivers, lies one of the most enigmatic and foundational sites of human civilization, the ruins of Ur. This ancient city, a cradle of early urban society, flourished during the 3rd millennium BCE, serving as a major political, religious, and economic center of Sumerian culture. Excavations have revealed a complex urban landscape of ziggurats, palaces, residential quarters, and elaborate tombs, offering an unparalleled window into the technological, social, and spiritual sophistication of early Mesopotamian civilization. What makes Ur particularly compelling is its combination of monumental architecture, urban planning, and cultural innovation that laid the groundwork for many aspects of civilization as we understand it today. It challenges modern assumptions about the capabilities of early societies, showing that humans had achieved remarkable mastery over architecture, governance, agriculture, and ceremonial life long before the emergence of classical empires. The most striking feature of Ur is undoubtedly its ziggurat, a massive terrace structure constructed as a temple platform to honor the moon god Nana, the city's patron deity. Rising several stories above the surrounding city, the ziggurat dominates the skyline, a visible statement of both religious devotion and civic authority. Built from mud brick, a material prone to erosion, the structure was reinforced with baked bricks and bitumen, demonstrating the Sumerians' sophisticated understanding of construction materials and methods. The ziggurat served multiple functions. It was a religious center, a symbol of political legitimacy, and a hub for economic and administrative activity. Its precise alignment with cardinal directions and careful proportional planning indicate advanced knowledge of geometry, surveying, and architectural principles, revealing a civilization capable of harmonizing practical engineering with symbolic and ceremonial considerations. Surrounding the ziggurat was a complex network of temples, palaces, and administrative buildings, reflecting a highly organized urban society. Streets were laid out in a deliberate pattern, with residential and commercial districts carefully delineated, indicating an understanding of urban planning, social hierarchy, and functional zoning. Archaeological evidence suggests that the city supported a substantial population, requiring sophisticated systems for water management, waste disposal, and food distribution. The construction of canals, reservoirs, and drainage systems reveals an impressive capacity for environmental adaptation, enabling Ur to thrive in a semi-arid landscape where water was both precious and unpredictable. The integration of infrastructure, urban design, and resource management demonstrates that the Sumerians had developed a holistic approach to city building, blending practicality, aesthetics, and social organization in ways that remain remarkable even by modern standards. Ur's cemeteries and royal tombs provide further insight into the city's complexity and cultural depth. The Royal Cemetery, excavated by Leonard Woolley in the early 20th century, revealed elaborate tombs containing treasures of gold, lapis lazuli, and intricate jewelry, as well as human and animal sacrifices. These findings suggest a highly stratified society, with a ruling elite exercising authority over wealth, labor, and religious practice. The inclusion of sacrificial attendants and animals in royal burials points to beliefs in an afterlife and the continuity of social status beyond death, highlighting the sophistication of Sumerian cosmology and ritual practice. Moreover, the craftsmanship of the artifacts found within these tombs demonstrates advanced metallurgical, artistic, and decorative skills, revealing a culture that combined technological expertise with aesthetic sensibility and spiritual expression. Trade and economic activity were central to Ur's prosperity. Located near rivers and fertile land, the city became a hub for the exchange of goods, including agricultural produce, textiles, metals, and luxury items such as lapis lazuli and carnelian imported from distant regions. The Sumerians developed a system of weights and measures, standardized record-keeping, and early accounting practices using cuneiform writing on clay tablets. This administrative sophistication facilitated large-scale commerce, taxation, and resource allocation, reflecting a society capable of managing complex economic networks. The combination of trade, agriculture, and administrative control illustrates a civilization that had mastered not only the physical construction of urban centers but also the intangible infrastructure of governance, law, and economic organization. Cuneiform writing, first developed in Ur and neighboring Sumerian cities, represents one of the most significant intellectual achievements of the ancient world. Initially created for record-keeping and administrative purposes, this system evolved to encompass literature, law, astronomy, and religious texts. The ability to encode complex information into written symbols transformed the capacity for communication, historical documentation, and cultural continuity. Texts such as the Epic of Gilgamesh, one of the earliest known literary works, reveal sophisticated storytelling, philosophical reflection, and an understanding of human nature that resonates across millennia. The development and application of writing in Ur underscore the civilization's capacity for abstract thought, systematic knowledge, and cultural innovation, illustrating that technological and intellectual advancement was deeply intertwined with urban and social development. The religious life of Ur permeated every aspect of its society, influencing governance, architecture, and daily routines. Temples were not only centers for worship but also hubs of economic and administrative activity, controlling land, labor, and production. Priests played a central role in mediating between the divine and the population, performing rituals, interpreting omens, and maintaining sacred knowledge. The integration of religious, political, and economic functions within the temple complex demonstrates a holistic approach to social organization, where spiritual authority reinforced civic governance and economic stability. This interconnection of religion and governance reflects a sophisticated understanding of human psychology, social cohesion, and the mechanisms by which authority and culture could be maintained in a growing urban population. Technological innovation in Ur extended beyond architecture and writing. The Sumerians developed irrigation techniques that transformed the surrounding plains into productive agricultural land, supporting dense populations and surplus production. They constructed canals, levees, and reservoirs to control the flow of the Tigris and Euphrates, mitigating the risks of flooding while maximizing arable land. These hydraulic systems required careful planning, coordination, and ongoing maintenance, demonstrating an advanced understanding of engineering principles and ecological management. The ability to manipulate the environment on such a scale reflects both practical ingenuity and a long-term vision for societal sustainability, allowing Ur to maintain its prosperity over centuries. Art and craftsmanship in Ur further highlight the civilization's sophistication. Artisans produced intricately carved cylinder seals, jewelry, pottery, and statues, combining technical skill with aesthetic sensibility. The seals, used to mark ownership or authenticate documents, also reveal the Sumerians' capacity for symbolic representation, narrative communication, and social organization. Similarly, jewelry and decorative artifacts indicate mastery of metallurgy, stoneworking, and design, suggesting a society that valued both functional and ornamental excellence. The convergence of utility, symbolism, and beauty in these artifacts underscores the holistic approach of the Sumerians to technology, culture, and expression, demonstrating a level of refinement that is both practical and artistic. The social structure of Ur was hierarchical yet highly organized, with clear roles and responsibilities spanning rulers, priests, artisans, farmers, and laborers. Monumental construction projects, agricultural production, and ceremonial life required coordinated effort, specialized skills, and centralized planning. Evidence of scribes, bureaucrats, and administrative officials suggests a complex governance system capable of mobilizing labor, managing resources, and enforcing social norms. This integration of administrative, economic, and ceremonial structures reflects an advanced understanding of organizational dynamics, highlighting the Sumerians' ability to create durable and resilient social systems. Urban planning in UR also demonstrates the civilization's sophistication. Streets, residential areas, marketplaces, and ceremonial spaces were arranged with careful attention to function, hierarchy, and accessibility. The city accommodated both the practical needs of a large population and the symbolic requirements of religious and political authority. The careful organization of space, combined with monumental architecture and infrastructure, reveals a society capable of integrating aesthetic, functional, and symbolic considerations in urban design. This multidimensional approach to city building highlights the Sumerians' capacity for long-term planning, environmental adaptation, and social engineering, making UR a model of early urban sophistication. The integration of technological, social, and cultural achievements in UR is particularly evident in its ability to support both monumental architecture and dense populations. By combining hydraulic engineering, organized labor, economic networks, religious authority, and administrative systems, the city exemplified the capacity of early urban societies to achieve remarkable complexity. Each technological innovation, architectural achievement, and social institution reinforced the others, creating a resilient and adaptive urban ecosystem. The city's enduring legacy illustrates the interdependence of technological mastery, social organization, and cultural expression in the development of complex civilizations. Trade, culture, and diplomacy extended UR's influence far beyond its immediate geographic location. Artifacts and inscriptions indicate contact with distant regions, suggesting that UR played a pivotal role in regional politics, commerce, and cultural exchange. This connectivity facilitated the flow of materials, ideas, and technologies, further enhancing the city's capacity for innovation and adaptation. The ability to maintain both local infrastructure and broader networks of influence highlights the sophistication of Sumerian planning, diplomacy, and economic strategy, reinforcing UR's status as a preeminent center of early civilization. Ultimately, UR stands as a monumental achievement in the history of human civilization. Its ziggurats, palaces, and tombs reflect advanced architectural and engineering knowledge, its inscriptions and artifacts reveal profound intellectual, artistic, and administrative sophistication, and its social, economic, and religious structures demonstrate an integrated approach to governance, resource management, and cultural expression. The city exemplifies the extraordinary capabilities of early human societies to create complex, resilient, and enduring urban centers, challenging modern assumptions about technological and cultural development in antiquity. In contemplating UR, one is struck by the scale, intelligence, and vision required to construct and sustain such a city. Every brick of the ziggurat, every canal and reservoir, and every artifact from the royal tomb speaks to a civilization that combined empirical knowledge, artistic creativity, spiritual insight, and organizational skill into a coherent and enduring society. UR is more than an archaeological site, it is a testament to the ingenuity, adaptability, and ambition of humanity, offering a profound glimpse into a world in which early urban civilization achieved levels of sophistication, complexity, and cultural depth that continue to inspire awe and study thousands of years later. High in the mountains of southern Peru, overlooking the sacred Urubamba Valley, lies the ancient city of Choqquequirau, a sprawling complex often overshadowed by its more famous neighbor, Machu Picchu, yet equally remarkable in its scale, architectural sophistication, and cultural significance. Believed to have been constructed in the late 15th century during the height of the Inca Empire, Choqquequirau served as a political, religious, and military hub, reflecting the strategic vision, engineering expertise, and spiritual worldview of the Incas. Perched on a series of steep terraces carved into the mountainside and connected by intricate stairways, terraces, and ceremonial platforms, the city demonstrates an extraordinary ability to harmonize architecture with the natural environment. Despite its relative obscurity and difficult access, the site has revealed a wealth of information about Incan engineering, urban planning, agriculture, and spiritual life, challenging modern perceptions of what ancient civilizations were capable of achieving in seemingly inhospitable landscapes. Choqquequirau's location alone exemplifies strategic foresight and environmental mastery. Situated approximately 3,050 meters above sea level, the city occupies a series of terraces overlooking deep gorges, rivers, and mountains, providing natural defense against potential invaders while offering panoramic vistas that connect it symbolically to sacred landscapes. The choice of this location reflects not only military and defensive considerations but also spiritual and cosmological significance, as the Incas often aligned their cities, temples, and ceremonial spaces with prominent natural features such as mountain peaks, rivers, and celestial markers. This integration of geography, symbolism, and functionality demonstrates the Incas' sophisticated understanding of the interplay between environment, architecture, and spiritual practice, creating a city that was both practical and symbolically resonant. The terraces at Choqquequirau are a testament to the Incas' mastery of engineering, agriculture, and erosion control. Carved into the mountainside, these terraces were constructed with stone retaining walls, layers of gravel, sand, and fertile soil to ensure proper drainage, soil stability, and agricultural productivity. The terraces supported diverse crops, including maize, potatoes, and quinoa, adapted to varying microclimates created by altitude and exposure. Beyond their agricultural function, the terraces also served as structural support, preventing landslides and creating stable platforms for buildings and ceremonial spaces. This dual-purpose design highlights the Incas' ability to merge environmental adaptation with urban and agricultural planning, reflecting an advanced understanding of both engineering and ecological sustainability. Architecture at Choqquequirau showcases the Incas' skill in stonework, construction, and spatial organization. The city contains temples, plazas, residential complexes, storage buildings, and ceremonial areas, all constructed with precisely cut granite blocks fitted together without mortar. This dry stone technique, known as ashlar masonry, allowed structures to endure earthquakes, heavy rainfall, and the shifting of mountainous terrain. Buildings were often aligned with astronomical events, such as solstices and equinoxes, reflecting the Incas' advanced understanding of astronomy and its integration into urban planning. The spatial arrangement of temples, plazas, and residential areas also suggests careful attention to social hierarchy, functional zoning, and ceremonial movement, creating a city that was both highly organized and symbolically meaningful. Water management at Choqquequirau further exemplifies the Incas' ingenuity and understanding of hydraulics. The city includes a network of channels, fountains, and drainage systems designed to capture and distribute rainwater while preventing erosion and landslides. Engineers carefully directed water through terraces, agricultural plots, and ceremonial areas, ensuring both practical irrigation and the maintenance of sacred spaces. The integration of water management with urban and agricultural planning demonstrates the Incas' holistic approach to city building, blending functionality, environmental adaptation, and spiritual symbolism into a seamless and enduring system. Choqquequirau's ceremonial and religious significance is evident in the placement and design of its temples, plazas, and sacred spaces. Large ceremonial platforms, often aligned with mountains, rivers, and celestial events, suggest that the city functioned as a spiritual center where rituals, offerings, and processions took place. Certain structures, such as the Temple of the Sun, may have been used to observe solstices and equinoxes, connecting agricultural cycles with religious practice and reinforcing the Incas' cosmological worldview. The integration of ritual, urban design, and environmental alignment reflects a society in which religion, politics, and daily life were deeply intertwined, with sacred architecture serving both practical and symbolic purposes. The organization of labor at Choqquequirau demonstrates the Incas' ability to mobilize and coordinate large workforces for complex construction projects. The precision of stone masonry, the creation of terraces, and the establishment of water channels required specialized skills, careful planning, and coordinated execution over extended periods. This level of social organization implies hierarchical leadership, skilled artisans, and systematic training, revealing a civilization capable of sophisticated project management and collective effort. The scale and precision of the city also suggest that the Incas valued both functional efficiency and aesthetic harmony, creating spaces that were technically impressive and visually striking. Agriculture at Choqquequirau was both practical and experimental, reflecting the Incas' empirical knowledge of soil, climate, and crop management. The terraces allowed for cultivation at different altitudes, exposure levels, and soil types, enabling the testing of crop varieties and microclimate adaptation. Such experimentation indicates an advanced understanding of agronomy, environmental variability, and sustainable food production, ensuring the city's resilience in a challenging mountainous environment. The integration of agriculture with urban design also demonstrates the Incas' holistic approach to societal sustainability, linking food security with civic planning, ceremonial life, and environmental stewardship. Choqquequirau's connection to broader Incan networks highlights its political and strategic importance. The city was linked to other major centers, such as Cusco and Machu Picchu, via an extensive system of trails and communication routes, facilitating trade, administration, and military coordination. This connectivity allowed for the movement of resources, personnel, and information, reinforcing the city's role as both a strategic and cultural hub. The integration of Choqquequirau into the wider Incan infrastructure underscores the civilization's capacity for large-scale planning, logistical coordination, and strategic foresight. The ceremonial architecture of Choqquequirau exhibits remarkable attention to detail, symbolism, and alignment with cosmological principles. Temples, plazas, and stairways were designed to guide movement, ritual practice, and social interaction, creating an environment where sacred and civic life intersected seamlessly. Certain structures may have served as observatories for astronomical events, aligning with solstices, equinoxes, and other celestial phenomena. This integration of architecture, ritual, and astronomy reflects the Inca's sophisticated understanding of the cosmos and its relevance to agricultural cycles, religious practice, and social organization. Artistic expression at Choqquequirau is evident in the intricacy of stone carvings, architectural motifs, and urban design. While less ornate than Machu Picchu, the city displays a mastery of proportion, symmetry, and functional beauty, with ceremonial spaces designed to impress, inspire, and guide participants through ritual movement. The blending of technical precision, aesthetic consideration, and symbolic meaning illustrates the Inca's holistic approach to construction, emphasizing the inseparability of function, beauty, and spirituality. The preservation of Choqquequirau, due to its remote location and difficult access, offers a unique window into Incan life and engineering. Unlike more accessible sites, it has remained largely intact, allowing researchers to study its terraces, buildings, and ceremonial complexes in situ. This relative isolation provides invaluable insights into the planning, construction, and social organization of the Inca Empire, demonstrating the civilization's capacity to create monumental urban centers in challenging environments. The site's ongoing exploration continues to reveal new aspects of Incan ingenuity, highlighting both their technical mastery and spiritual sophistication. Military and strategic considerations were integral to Choqquequirau's design. The city's location on steep, defensible terrain, combined with its connection to other centers via well-maintained trails, suggests a dual purpose as both a ceremonial hub and a military stronghold. Fortified terraces, narrow access routes, and commanding views of surrounding valleys would have allowed defenders to monitor and repel potential threats effectively. This combination of spiritual, civic, and defensive functions underscores the Inca's strategic vision, demonstrating their ability to integrate multiple objectives into a coherent and enduring urban plan. Choqquequirau also reflects the Inca's understanding of environmental adaptation and sustainability. The terraces, drainage systems, and water channels illustrate a careful balance between human habitation, agricultural productivity, and ecological stability. The city was designed to minimize erosion, maximize soil fertility, and utilize the natural landscape effectively, demonstrating a sophisticated understanding of mountain ecology and resource management. This ability to harmonize human activity with environmental constraints highlights the Inca's advanced planning, engineering expertise, and respect for natural systems. Social and cultural life at Choqquequirau would have been vibrant and complex. Ceremonial plazas, temples, and residential complexes suggest a society organized around both ritual and daily life, with elite administrators, priests, artisans, and farmers contributing to the city's operation and cultural expression. Large-scale construction projects, coordinated agricultural practices, and ritual ceremonies would have reinforced social cohesion, hierarchical authority, and collective identity. The city's design, integrating practical, ceremonial, and aesthetic considerations, reflects a civilization capable of balancing functionality with symbolic meaning, creating spaces that were socially, spiritually, and environmentally integrated. Choqquequirau's enduring significance lies not only in its monumental architecture but also in what it reveals about Incan knowledge, vision, and cultural priorities. The city exemplifies the integration of engineering, agriculture, urban planning, astronomy, and spirituality, illustrating a civilization capable of sophisticated problem-solving, aesthetic refinement, and environmental adaptation. Each terrace, temple, and ceremonial platform embodies the Incas' ability to harmonize technical mastery with symbolic expression, creating a city that was simultaneously functional, beautiful, and spiritually resonant. Ultimately, Choqquequirau stands as a testament to the ingenuity, resilience, and vision of the Inca civilization. Its terraces, temples, and urban layout demonstrate advanced engineering, precise planning, and environmental adaptation, while its ceremonial architecture reflects deep spiritual understanding and cosmological awareness. The city embodies a holistic approach to urban design, integrating agriculture, water management, ritual, and social organization into a coherent and enduring system. In contemplating Choqquequirau, one is struck not only by its monumental scale and technical sophistication but also by the intelligence, creativity, and spiritual vision required to conceive and construct a city that harmonizes with its rugged natural surroundings while serving as a center of political, religious, and social life. This remarkable site continues to inspire awe, study, and admiration, offering profound insights into the capabilities of one of history's most extraordinary civilizations. Choqquequirau, with its challenging terrain, monumental terraces, and sophisticated water and ceremonial systems, forces a reconsideration of the limits of Incan engineering and urban planning. The city illustrates that the Incas were capable of overcoming extreme environmental challenges, mobilizing large-scale labor forces, and creating urban and ceremonial spaces of enduring significance. Every stone, terrace, and pathway reflects careful planning, technical mastery, and spiritual intention, revealing a civilization in which engineering, art, agriculture, and cosmology were seamlessly integrated. Choqquequirau is not simply an archaeological site, it is a living testament to human ingenuity, adaptability, and the capacity for creating monumental works that inspire wonder centuries after their construction. Deep within the dense forests of Cambodia lies Angkor, the sprawling capital of the Khmer Empire, a city of unmatched scale, sophistication, and architectural grandeur that continues to baffle historians, archaeologists, and engineers alike. Flourishing between the 9th and 15th centuries CE, Angkor represents one of the most remarkable achievements of pre-industrial civilization, combining monumental architecture, urban planning, hydraulic engineering, religious symbolism, and artistic mastery into a single, cohesive, and enduring complex. The city encompasses over 1,000 temples, palaces, reservoirs, canals, and causeways, covering an area of more than 1,000 square kilometers, making it one of the largest pre-modern urban centers in human history. The complexity of Angkor, its integration with the surrounding landscape, and the precision of its engineering challenge conventional assumptions about the technological capabilities, organizational skills, and cultural sophistication of ancient societies. At the heart of Angkor lies Angkor Wat, the most famous and meticulously constructed temple complex in the world, dedicated originally to the Hindu god Vishnu before later becoming a center of Buddhist worship. Angkor Wat is renowned for its monumental scale, precise orientation, intricate bas-reliefs, and harmonious proportions, reflecting a deep understanding of both religious symbolism and architectural principles. The central towers symbolize Mount Meru, the mythical home of the gods, while the surrounding moats and galleries reflect the cosmic ocean and celestial realms, integrating spiritual cosmology directly into urban and architectural design. Constructing Angkor Wat required not only an immense labor force but also advanced knowledge of stone quarrying, transportation, and precise masonry. The ability to carve and assemble massive sandstone blocks with such precision, without modern machinery, demonstrates the Khmer's exceptional technical mastery and meticulous planning. Beyond Angkor Wat, the city contains numerous other temples and ceremonial complexes, including Bayon, Ta Prohm, Preah Khan, and Banteay Srey, each showcasing unique architectural styles, intricate carvings, and advanced construction techniques. Bayon, for example, is famous for its enigmatic smiling faces carved into massive towers, while Ta Prohm remains partially engulfed by jungle, creating an awe-inspiring interplay between nature and architecture. These sites demonstrate the Khmer's ability to manipulate stone, create enduring monuments, and embed symbolic meaning into every aspect of their urban and ceremonial spaces. The stylistic diversity among temples also reflects cultural exchange, innovation, and a sophisticated understanding of both aesthetics and functionality. Hydraulic engineering at Angkor represents one of the most impressive achievements of pre-industrial civilization. The Khmer developed an extensive network of reservoirs, canals, and barrages to regulate water supply, prevent flooding, and support large-scale agriculture, particularly rice cultivation, which was the backbone of the city's economy. These hydraulic systems were carefully designed to store monsoon rains, distribute water to agricultural terraces, and maintain ecological stability, allowing Angkor to sustain a population estimated in the hundreds of thousands. The integration of water management with urban planning, temple construction, and agricultural production demonstrates an advanced understanding of hydraulics, topography, and environmental adaptation. Modern engineering analyses reveal that the Khmer achieved remarkable precision in gradient calculation, water flow control, and maintenance, indicating a sophisticated knowledge of applied engineering principles centuries before modern technology. The urban planning of Angkor also illustrates extraordinary foresight and organizational skill. The city's layout reflects careful alignment along cardinal directions, integration with topographical features, and functional zoning for religious, administrative, and residential purposes. Major temples, palaces, and civic centers were strategically positioned to emphasize political and spiritual authority while ensuring access to water, transportation, and agricultural resources. Roads, causeways, and bridges connected different districts, facilitating movement, trade, and ceremonial processions. The combination of monumental architecture, hydraulic infrastructure, and urban design demonstrates that Angkor was not simply a collection of temples but a fully integrated city, reflecting the Khmer's capacity for long-term planning, coordinated labor, and complex governance. Religious and ceremonial life permeated every aspect of Angkor's architecture and urban organization. Temples were meticulously aligned with celestial events, including solstices, equinoxes, and lunar cycles, reflecting the Khmer's sophisticated understanding of astronomy and its integration into spiritual practice. Ritual spaces, ceremonial platforms, and processional routes were designed to reinforce the authority of kings, priests, and the state while connecting the urban population to cosmic and religious order. Art and symbolism were central to this integration, with bas-reliefs depicting mythological narratives, historical events, and cosmological themes. These visual narratives not only conveyed religious doctrine but also legitimized political authority, reinforced social hierarchy, and created a shared cultural identity, demonstrating the Khmer's ability to weave symbolism, governance, and daily life into a cohesive urban tapestry. The construction techniques employed at Angkor reveal the Khmer's exceptional engineering skill and meticulous attention to detail. Massive sandstone blocks were quarried, transported over long distances, and fitted with precision to create enduring structures capable of withstanding centuries of environmental stress. Techniques such as corbelling, precise alignment, and interlocking stonework allowed for monumental temples, towers, and galleries to be constructed without mortar, ensuring durability and structural stability. Carvings, bas-reliefs, and decorative motifs were executed with remarkable precision, illustrating a mastery of both technical execution and artistic expression. Coordinating such large-scale construction projects required advanced project management, labor organization, and the transmission of specialized knowledge across multiple generations of artisans and engineers. Agriculture and resource management were critical to sustaining Angkor's vast population. Rice cultivation, supported by the sophisticated hydraulic system, provided the caloric foundation for urban life, while trade networks supplied luxury goods, building materials, and cultural influences from across Southeast Asia. The Khmer coordinated the extraction, transportation, and storage of vast quantities of stone, timber, and other resources, reflecting an advanced understanding of logistics, labor mobilization, and economic planning. This integration of agriculture, resource management, and urban development demonstrates a civilization capable of balancing the demands of subsistence, monumental construction, and ceremonial life on an unprecedented scale. The social organization of Angkor was hierarchical yet highly functional, enabling the mobilization of labor, administration of resources, and maintenance of complex urban and ceremonial systems. Kings and elites exercised authority over religious, economic, and civic functions, while skilled artisans, laborers, and agricultural workers contributed to construction, food production, and ceremonial activities. Evidence of specialized labor, training, and administration suggests a sophisticated bureaucracy capable of coordinating projects involving tens of thousands of people. The ability to integrate governance, religion, labor, and engineering demonstrates a level of societal organization that rivals other great civilizations of the pre-industrial world. Astronomical and cosmological knowledge played a central role in Angkor's design and function. Temples and ceremonial platforms were aligned with the sun, moon, and stars, linking architectural forms with seasonal cycles, agricultural planning, and ritual practice. The Khmer's ability to incorporate celestial observation into urban and ceremonial design reflects not only intellectual achievement but also the integration of empirical knowledge with religious and practical concerns. This holistic approach ensured that architecture, agriculture, and ritual were harmonized, reinforcing social cohesion, spiritual legitimacy, and environmental adaptation. Angkor's enduring legacy also lies in its artistic and symbolic richness. Bas-reliefs, sculptures, and temple carvings depict scenes from Hindu mythology, Buddhist cosmology, royal exploits, and daily life, providing a multidimensional narrative of Khmer society. These artistic expressions serve to educate, inspire, and reinforce cultural values, while simultaneously displaying the technical skill and aesthetic sensibility of the civilization. The integration of art, symbolism, and functional architecture exemplifies the Khmer's holistic approach to cultural expression, where beauty, meaning, and utility were inseparable. Trade, diplomacy, and cultural exchange further enhanced Angkor's sophistication. The city maintained connections with other Southeast Asian polities, facilitating the exchange of goods, ideas, and artistic styles. Artifacts such as ceramics, precious stones, and religious iconography reflect a cosmopolitan culture that blended local innovation with external influences. This connectivity not only supported economic prosperity but also fostered cultural dynamism, reinforcing the city's role as both a political and cultural hub in the region. Despite its grandeur, Angkor eventually declined, influenced by a combination of environmental, political, and social factors. Changes in water management, deforestation, climatic shifts, and internal strife contributed to the city's gradual abandonment in the 15th century. Yet even in decline, the monumental infrastructure, temples, and urban layout continued to stand as a testament to the Khmer's ingenuity, resilience, and visionary planning. Modern archaeology and engineering studies reveal the sophistication of their hydraulic networks, construction techniques, and urban planning, emphasizing that Angkor was not only a cultural and spiritual center but also a marvel of technical achievement. The preservation and study of Angkor continue to challenge modern scholars and engineers. Ongoing research into its hydraulic systems, construction methods, and urban organization reveals an extraordinary understanding of engineering, mathematics, and environmental adaptation. Each temple, canal, and plaza provides insight into the Khmer's capacity for complex problem-solving, aesthetic expression, and societal coordination. The city's integration of monumental architecture with practical infrastructure illustrates a civilization that understood the interdependence of social, technological, and environmental systems, creating an urban landscape that was functional, symbolic, and enduring. Ultimately, Angkor stands as one of the most impressive achievements of human civilization, embodying technical mastery, artistic sophistication, spiritual depth, and social organization. Its temples, hydraulic networks, and urban layout reveal a civilization capable of harmonizing monumental ambition with environmental adaptation, ceremonial significance, and aesthetic precision. Every carved tower, canal, and ceremonial platform reflects meticulous planning, collective effort, and an understanding of the interconnections between governance, spirituality, and survival. The city challenges modern assumptions about the capabilities of pre-industrial societies, demonstrating that human ingenuity, coordination, and cultural vision can produce achievements of staggering complexity and enduring beauty. In contemplating Angkor, one is struck not only by the monumental scale of its temples and hydraulic systems but also by the intelligence, vision, and cultural sophistication required to construct a city that functioned as a political, religious, and social hub while harmonizing with the surrounding landscape. The Khmer's ability to mobilize labor, manage resources, integrate astronomy, and create artful architecture demonstrates a civilization that understood the delicate balance between human ambition, environmental constraints, and spiritual imperatives. Angkor is far more than an archaeological site, it is a living testament to human creativity, engineering skill, and cultural achievement, offering profound insights into the capabilities of a civilization that continues to inspire awe, study, and admiration centuries after its zenith. Angkor, with its vast temples, intricate water management systems, and sophisticated urban planning, forces us to reconsider what was possible for ancient societies. It is a city where religious devotion, political authority, technological mastery, and artistic expression converge in a harmony that few modern cities achieve. Each structure, terrace, and canal embodies the Khmer Empire's capacity for foresight, coordination, and visionary planning. Angkor is an enduring symbol of the ingenuity, resilience, and cultural depth of humanity, demonstrating that even in the pre-industrial era, civilizations were capable of creating landscapes that were both practical and transcendent, functional and symbolic, awe-inspiring and enduring.